Yeah. So that it's basically it's what I explained earlier, and it's showing that that that's my garage, and it's showing the light bending towards cold and away from hot.
No, where have you measured this across the great distance we're talking about?
I used Dr. John's measurements. He posted it in his video. The temperature gradient. He actually measured it. I haven't done it. I'm using Dr. John's measurements. Why? What's wrong with his measurements?
I'm asking you about Dr. John's measurements. I'm asking you about yours to prove that it is happening.
Well, I haven't done a long distance laser measurement like Dr. John measuring the thing.
You haven't done anything.
He has though.
You haven't done anything. Yeah, but what I'm asking you is, where is your measure?
I've done experiments
that it is happening. It's just you saying it. It's just you saying it. It's just you saying it to counter something.
I think you're repeating yourself now. I think you made your point.
Can I ask a question now? Can I have a real quick one question for Mr. West? Mr. West, please. So I heard your father was part of the Flat Earth Society, and I was wondering, is the Flat Earth is the Flat Earth Society like a bunch of globers that are actually going around trying to make Flat Earth look stupid, and how are you not part of it? You know what I mean? And what do you think of Flat Earth Society?
I tried to make you look stupid. And my dad just did it ironically. I think he did it in the 70s. He did it ironically,
but he told you that the other side needs to be done. That's what you said on JRE. Don't you lie. Don't you lie. You lie me.
What am I lying about? I'm not sure what you mean there.
You just said he did it out of irony, but that's not what you said on JRE.
That's what I said. I said.
Well, I'm curious where your loyalty is. I'm curious
as a joke.
I'm wondering if you're more, if you're Flat Earth Society,
he's not going to tell you his loyalty, Bong. He's not going to tell you his loyalty.
Right. I'm just wondering.
What's your nationality? Let's just break apart his fucking stupid experiment first, though. Let's just do that. That'll get him out of here. So let's get back to your experiment, supposed, right? So your laser, what's the intensity of that laser?
Well, it doesn't really matter what the intensity is. It's a visible laser. It's just a laser pointer, but it works exactly the same.
So right, it's more exciting. So you said you held it up to a flame, right? You're next to a flame. Is that correct?
Yeah.
Is that flame putting out more energy than that laser? You would consider at that point it connects?
Probably, yeah. Because it's just heating the air.
All right, but can the
ice pack isn't putting out any energy?
Here's a question for you. Can the laser light heat air? Is that possible?
Not very easily, no, because air is transparent.
All right, so if you continue to increase the intensity of that laser, what will happen?
I'm not sure where you're going with this. Could you explain what your point is?
I'm trying to. If you can answer me that, what will happen?
What? Can I increase the intensity of the laser? No, it's a Logitech laser pointer.
All right, but he's
asking what if you did?
Right. Exactly.
It wouldn't make any difference whatsoever. Zero difference.
Wow, you heard this guy? Wow.
Well, Mr. West,
it's a
problem because if you take the supposed globe and surround it with concentric rings of air layers, then you would have, say, what you're trying to say is basically a warm layer under a cooler layer toward which the light refracts. Okay, that's fine. But over long distances, you're essentially saying that light goes up into the second layer and goes back down into the first warm layer to hit the eye of the observer. That's a little hard to believe because that would have for the thing to go
I'm not sure what you're saying.
So. He just doesn't. This guy doesn't understand lasers. There's no point arguing with him. He just doesn't have no idea.
Wait.
It's got to go.
Here's the whole problem, guys. With his whole entire thing, he's changing with the experiment that he's doing. He's changing the temperature around it, right?
Exactly.
Okay, but what's going on at night with these laser tests is it's stable. It's not changing anymore. So we're not going to see this. This is the problem. You're inducing this refraction. This is not happening naturally because there is no mixture of air where you're having that huge change at night anymore. Literally, you're not having that much change. So guess what's not going to happen? The refraction.
But Dr. John,
Jesus Christ, this is why we posted that damn graph, man, that you're going to deny again.
Well, are you going to deny Dr. John's measurements?
This guy doesn't know what he doesn't know. What
no, the graph he's talking about, Mick West, is I forgot who did it exactly, but it was a bunch of people that got together and they were trying to test the refraction. They tested it for about 72 hours, 3 days in a row, and they got the conclusion that I believe that the most amount of refraction they got was when was it, Rich, exactly? That they got the most?
The day is when you get the most amount of refraction, and in the evening and in the mornings it drops off rapidly, and at night there's none.
And that's why we have to match these conditions one for one, Mr. West. Otherwise, they have a theoretical sugar water abstraction.
None there.
And if you look at the reason why. Sorry, Lemon, hold on. If you look at the reason why, you'll notice it's the temperature difference, just like you said. Okay. The reason why, though, it goes and it bottoms out and it's nil is because the temperature in the air has already mixed, and now it is constant. There is nothing changing.
But would you agree, then, that you would have to measure the actual temperature gradient at that time?
They did take the temperature at the time they were doing the laser test.
They did do it, and they found that there was a temperature gradient.
But do you understand that there's different types of lasers?
Not at night, there wouldn't be.
They found it in Dr. John's experiment.
Hold on. Do you know that there's different types of lasers? Right? Do you understand that?
Well, sure, yeah. Different wavelengths, different ways of generating them.
And different kinds of Logitech lasers. What are different types of lasers used for? What can be the use for a laser? Can it be used as a weapon? Is that?
They used to illuminate things and they used to heat things. And they use for a variety of other reasons.
So why would a laser that's used to heat things be affected by what the fuck you're talking about?
Well, this is the thing with lasers. They're targeting devices. We can use lasers to point at shit and paint targets and say paint because that's what the military do. Now, military use lasers. Yeah. So military use lasers to paint targets over distances that should have to take into account the curvature of the Earth and now your light refraction. These are from vessels at sea. Now, it seems, with a little bit of research, that quite a lot of their ordnance and weapons that they use for the shit out of stuff requires a direct line of sight targeting system, up to and including about 100 miles. So if they can aim lasers at shit up to 100 miles away, that's got a direct line of sight and is directly in front of them from a vessel at sea, and the targeting device is somewhere about 40 foot off the surface of the water. Excuse me. So if that's happening, practical, everyday use, I think we're fine shooting lasers over 25 miles, right?
You wouldn't be shooting things that are at sea level because you wouldn't be able to see them.
According to you, but right now I've just pointed out, I said military, I should have said Navy. I did say vessel. I did give you a height of 40 foot above the surface of the water, aiming at a direct line of sight to a surface-based target. Now, this is 100 miles, it seems, with a little bit of research. Many of the ordnance they use require a direct line of sight.
I think you're probably referring to rail guns. I think you're conflating two different things.
No, I'm not. I'm actually not talking about rail guns.
All right, so post a link then.
Yeah, I'll go and get through. But what I'm referencing is military do seem to have lasers that paint targets that require a direct line of sight at distances where Earth curvature and refraction should have to be taken into account.
That's great. Let's go with that then. Let's post me that evidence, and that will prove it.
Okay. I'm surprised you haven't looked into this before yourself, Mr. Mick West, who knows everything about light refraction and what lasers do. We're talking about a test that's done over 25 miles, or one that's done over 10, or any other laser test or line of sight test that requires, like I just said, a direct line of sight. That's easy to understand light refraction. No flat earther is denying that light refracts through the medium of the Earth. Can it be demonstrated to curve around the curvature of your Earth? Not just a little box where you've got an ice pack underneath it, because we're talking about the majority and most conditions, depending on the air clarity and conditions of the day. Direct line of sight is required when shooting lasers at shit.
Oh, can you hear me? Yeah, line of sight is, but not a geometric line.
Yes, right? We can hear you.
So I want to put in my 2 cents about this. Like the experiment, that would be what you would consider a special case. That is not the general case of the atmosphere. So the basic claim of globe proponents is that the general case, generally, that air will refract light down because of the weather conditions. And that has not been demonstrated, right? Not been demonstrated in the environments that these tests have been done in. Now, of course, you can make a special case test. I think it was Greater Sapien did one over CO2 in frozen ice, right? So, but he didn't take into account that CO2 has a higher refractive index of air, and it's way colder than any environment on Earth. So these are special case experiments. These are not the general case conditions that we find ourselves in. And I think just showing that light can refract says really nothing. We all know light can refract. Okay?
So you got to look at the actual conditions.
Did it refract in this situation? And what do actual measurements and tests of refraction show?
Look at the actual measurements that Dr. John did. I can post them if you want. I've got them right here.
Mr. McWest, I have one point in your carriage test that is wrong, or I have a question for that. You said that in warm air, it's
just posted the temperature readings of Dr. John, by the way, for people who want to check out them. Sorry, but carry on.
Okay, in your carriage test, the laser.
I'm sorry. You said, my garage test, right?
Garage.
Yes.
Sorry, my English.
Garage.
Laser starts in warm air.
Yeah.
Like maybe 20 degrees Celsius in your garage.
Yeah.
And it goes nearby the ice. And it goes into the colder air. Maybe, I don't know, minus something. The ice was
probably like minus 20, minus 15, minus 20, or something like that.
Exactly. Where does that happen in nature? That your laser starts from a warmer temperature and goes through the colder temperature when you point it across the lake.
If you're on the shore of the lake, then the air around you is say like 90 degrees.
How many degrees
Fahrenheit
difference is in the where the laser starts?
What do you need actually? It's quite interesting. You only need about 1 degree of difference to curve like over the surface of a lake. It's quite interesting just how little of a temperature gradient, because the gradient it's not really the amount, it's the amount per meter. So if you've got a gradient of say 1 degree per meter, that's actually a huge gradient. But because it's very close to the surface of the water, you get this very, very steep gradient just at that point, which is why you have these issues with the lasers, and it's why you also get this very thick line of compression at the bottom of the images just over the horizon, because closer to the water, you get this steep gradient.
Okay, so I'm looking at
this. Is what Dr. Don showed.
Yeah, well, he didn't measure at 2 meters. He didn't measure at 1.5 meters. He didn't do his measurements at 1 meter. He did them at a single elevation, right?
No, it's this 5 measurements there. Oh, sorry, 4 measurements above the water: 0.5 meters, 1 meter, 1.5, and 2 meters. And the difference between above the water is 1.5 degrees.
The elevation that he did, the laser was at, the laser itself.
No, it doesn't matter there, because at some point the laser is going to be skimming the surface of the water.
Listen, it does matter because this is a vertical chart, right?
So either the laser's got to hit the water, or it's going to skim the horizon.
So I think.
So if it's skimming the horizon, that means
this chart is vertical. He didn't shoot the laser vertically.
Correct,
he didn't cross this gradient.
No, it shoots when you go along the gradient. What happens is that the light bends towards the more dense the air, the colder air in this case. This is something.
There's some boundary. There's some boundary.
No,
right?
no. It's actually a very difficult thing, and it took me a while to understand.
I mean, this is all theory, dude.
No,
when it comes down to it, like where's like the data sets that actually show this happening? You took an extreme case, 70 degree Fahrenheit, going over, minus 20 Fahrenheit. I don't know what type of environment that is in nature, because I don't know of it ever existing.
It's an extreme example because it's hard to show. But Dr. John's own measurements
just said it was easy. You just said a 1 degree temperature difference will show a significant amount of refraction.
Over that distance. It's hard to show in my garage because my garage is only like 40 feet long.
1 degree, right? So say you have 1 degree per meter difference. Okay, so you shine a laser 15 kilometers. That's 15,000 kilometers. Or 15,000 meters. So if you have a 1 degree difference, it's 15,000 degrees at the other side.
No, it's the vertical temperature gradient. It's again, it's like a difficult thing to explain
if
here.
you're crossing the vertical gradient.
No, that's the refraction. Look up a thing called gradient index optics. There's a difference between. There's a difference between light going from one medium to another and light going through a medium where there's a gradient. It's actually a very different type of thing. Light, even like you know about Snell's law, and the amount it bends when it goes from air to water. Now you think if something was shining parallel to the surface, there would be no bending. And so you think that if something is shining like at right angles to the temperature gradient, intuitively you would think there'd be no bending, but there actually is, because a light actually bends towards the more dense medium. It doesn't matter about if it's actually going into a more dense medium; it just bends towards it because it's not actually a line as such. It's actually a wave front. Light is a wave, so it will still bend down, even though the temperature gradient is only vertical.
So
it's
so
kind of confusing.
Of the cone, a portion of the wave front will go to the medium, and another portion won't. Right?
No, it will.
This is layers, right? This is 4 layers. I'm at 1 meter, so I'm just going off his little data here. This little data set from John D. So say the laser's at 1 meter. He's shining exactly horizontally. Now, and we assume that from the target from the source to the target, the laser is always at 1 meter elevation.
Yeah.
How is it crossing into the 1.5 meter?
No, that's the thing.
Meter?
That's the fascinating thing about it, is that it doesn't need to go.
I'm asking you how it's done. How does that happen? I know that there's beam divergence, right? So there's going to be spread. A portion of the wavefront is going to spread out and go higher and lower. But the centroid of the beam is not going to. That's not going to happen.
Light,
the main
light is like a wave,
right?
No, it's not. No, it's not. Light's not a wave. Wait, light's a particle.
Right, it's a particle that acts as a wave.
No, it doesn't. Particles don't act like waves. Particles act like particles.
Water is made of particles, and water.
Yeah, but light isn't. Light is made of particles. Light's not water. You false equivalence fallacy, knucklehead.
Water is made of molecules, which is
light is made of particles. It's not water.
And
clown show.
It acts like a wave.
Photons are particles.
Act like waves.
They don't.
Stop screaming.
Why do you get like interference and things like that then if they don't act like waves?
Yeah, QE, look, dude. Okay, we're talking about something else entirely, dude. And you come in here wanting to talk about waves and particles. Look, dude, you're not going to interrupt the conversation and take this in an entirely different direction. McWest, continue talking about refraction.
All right, so, yeah.
He was it is relevant, though.
Hold on. Hold on, got something. Mick made a claim. Mick made a claim.
From ray optics to wave optics, right?
QE is refuting his claim that he made as part of his argument.
That light acts like a wave, which it does.
No, it doesn't. You can keep on saying it, but you're wrong. To refute light as particles, you have to refute the photoelectric effect, number 1. Number 2, Compton scattering, number 2. Number 3, Heisenberg's uncertainty principle. You ready to do that right now?
I don't think any physicist would argue that light doesn't.
You can't speak. Objection, Your Honor. You can't speak to any physicist.
Dude, QE, if you don't,
Thank you.
Question
and answer.
Say again.
Dude, QE, stop yelling. Okay.
Hey, Who are you? Who's giving me instruction?
First.
Who's giving me instruction?
I mean, for the sake of conversation, let's try to keep it civil.
Hey, Indio, are you in here?
What?
1 second. Indio, are you in here?
I'm in here. I'm taking care of it. Just chill.
Okay.
All right. So, can I carry on?
No, you can't. Just wait.
Okay. All right. Yeah.
Yeah, because you sound really stupid.
Yeah, because just like when you stop Lemonbird when he says something wrong, QE is doing exactly the same thing. So don't get mad about that. Or Mick, what?
What is a science communicator, Mr. West? Because you are a science communicator, and so is Neil deGrasse Tyson. What is that?
Someone who popularizes science and explains it to people, I guess. It's like
stupid people, right?
You don't even know what science is. Wait a second.
Yeah,
science
you don't even know what lasers are. What the fuck is wrong?
Wait a second, folks. He's a science communicator. Do you even know what a scientific hypothesis is?
Asking me what a scientific
hypothesis is? I'm asking you, what is a scientific hypothesis? What is an let's keep it simple. What are the three constituent hold on a second. What are the three constituent parts of an experiment?
Well, off the top of my head, I don't know. Like, I guess.
And you're a science communicator?
Yeah, but this isn't the type of science that people want to be communicated with. I mean, you have like, the variable, you have the variable, you have the hypothesis.
I would
wrong.
I would argue communicating a scientific principle is different than communicating a scientific experiment.
Wrong.
Science
Everything, the whole basis of the scientific method is based on experiment.
That's why, like, Dr. John's experiment was actually a pretty good one.
Dr. John didn't perform an experiment. He even told you that. Now, let's get back. You're a science communicator, and you don't know what a friggin' experiment is? You'd fail 5th grade general science.
Well, I don't think that's really relevant here. Like,
he is also an expert on debunking on what chemtrails.
Would you stop changing the subject,
right?
But like you talk about, like stuff like dependent variables.
His life to debunking and making conspiracy theories look stupid. I just want to know what is.
Bong, let's stay on topic. Let's not switch it up.
So we got two subjects on the table. One, you don't know what the hell light is. Number two, you don't know what an experiment is.
No, I do know what light is.
No, you don't. It's not a wave. It's a particle. Now,
acts like a wave.
Listen, if you want to
he has to appeal to physics, to physicists. He's not going to answer.
What physics?
Why
oh my God.
Because you are not qualified to answer the question, Mick West, because you are paid. So you're not qualified to answer that question, am I right?
I'm not paid. No one's paying me.
So you have to appeal to physicists, right?
So
you can't answer the question.
Why are you asking me questions?
All right, listen, let's deal with this right now. Richard Feynman, Nobel laureate physics. The first thing Newton believed, light was corpuscular. Turned out that it had very strange properties from that point of view, and it was then explained that many of these strange properties was because, in fact, it was a wave, which was wrong. Turned out he was right. It was a particle. Richard Feynman, lectures on quantum electrodynamics.
Wave. Yeah, I know. It acts like a wave.
It doesn't act like a wave. Particles aren't waves. They don't act like waves.
Can someone mute him for fuck's sake?
Yeah, QE, can you stop yelling like a fucking kid, dude?
I'll tell you what, brother, Mr. Kid. Let's meet up, man. Me and you. Who said that? Who said it?
I said you should be muted, you fucking.
All right, you know.
All right, hold on, guys. Hold on. Hold on, everybody. This is what's going on. Hold on, everybody. Look, we got a bunch of the people that hate QE in here interrupting. All those people are getting muted because literally I'm trying to hear this discussion between Mick West and QE, and everyone else. Kind of let them go at it for a while and stop interrupting. Please.
Yeah, I'm going to pull over up here. I'm going to go ahead and ban everyone who's been interrupting QE like that because I know y'all don't like him. Okay, congratulations.
From the chair of physics at Yale, Professor Shanker, everything is really particles, all things, electrons, photons, protons, neutrons, they are all particles. So let there be no doubt about that.
Of course, yes.
Clown show.
Agrees with that. I'm not disagreeing with that. I said it acts like a wave.
That is horseshit.
It's demonstrably true.
It's okay, demonstrate it.
Well, constructive interference, for example.
No, here we go.
A wave. The wave function is not a wave. It's a mathematical construct. You're talking about the wave function, not a physical wave.
So Young slits, the Young splits experiment.
Young splits. It's not a split. It's a slit.
I know slits. Young slit experiment.
Yeah.
Demonstrates the wave-particle duality of the nature of light.
There is no wave-particle duality.
Well, the experiment seems to disagree with you.
Oh, really? Professor Shankar, chair of physics at Yale. So we have to play this game in two waves. It is particles, but its future is determined by a wave. But the wave is purely mathematical. You cannot put an instrument to measure the energy due to that wave. It's a construct.
You can see the effect.
It's a construct. You're mixing up the concept of a wave with the wave function.
If you can see it.
Misplaced concretism. It's reifying something that isn't real into something that is real.
You're reifying the wave function. It's not a physical reality. It's a probability amplitude of possible outcomes. That's all it is.
Exactly.
There's no physical reality.
Exactly.
But you can see it, though. You can see the effect.
You can't see it. Show it to us.
It's visible
right now.
Someone posted.
Can you? I can see the green codes falling down like Neo from the Matrix.
Okay, well, let's not yell and hurl insults, man. Just for the PR.
From the University of Tennessee, in one dimension, wave functions are often denoted by the symbol psi. They are functions of the coordinate x and the t time, but psi is not real. But a complex function does not have real. See, don't rumpus me, you clown. You don't even know what an experiment
is. You're denying reality. You can actually see.
Oh, kiss my ass! I just pummeled you. Pummeled you.
Are you denying that you can see the effect of young slits?
Oh my God! But the wave function itself has no physical interpretation.
That is a physical interpretation. You can actually see
the University of Tennessee, the professor of physics at Yale, Richard Feynman, and now we got Mick pseudo-fucking-West telling us the opposite.
All right. Well, if you want to deny the evidence of your own eyes...
Deny the evidence? Fine. Bullshit. You don't have any evidence. You just got clobbered, and you already denoted... You don't even know what an experiment is, Mick.
Wikipedia.
You want to know what denying the evidence of your own eyes is, Mick? It's looking at the sun and the moon and thinking that they're different sizes. That's denying your own eyes.
This guy doesn't even know what an experiment is. He doesn't even know.
It's a little weird. It's a little weird that you don't know what an experiment is, and you just said that you teach it.
The thing is, like,
science. You don't know the parts of an experiment.
The vernacular of an experiment is just something that you do to test or to demonstrate a hypothesis.
Yeah, but you need things in this test to conduct it, right?
Oh, you don't. You get the idea that you need a dependent variable, an independent variable, and control.
Idea. That's a scientific method. Yeah, we get that idea from the scientific method, and we're trying to demonstrate cause and effect relationships without personal bias.
No, he said you
can demonstrate very simple things, like you say, does light does it act like a wave? If it acts like a wave, then if you did a double slit experiment, there would be constructive and destructive interference, and you do the experiment.
That's a wave function for the 10th time.
It's something that actually happens, though.
What's a function?
Doesn't happen.
What's a function? Hold on a second. What's a function? Hold on a second. What's a function, Mick?
In what context? A function is it's basically a mapping of one variable through a mathematical operation to another, like a sine.
It's a mathematical construct. It's a function, a complex function, Mick.
Okay, let me ask you a question. Is this QED?
You ain't asking me shit. You don't even know what a hypothesis is.
Hey, Quantum. We're on the same side of this fence. But I realize it's like sometimes you have to realize when you're dealing with people that are trying to disprove like
trolling with stuff like that.
Jedi, you hear me, right? It's like you start to.
I hear you, mate. Yeah, I get you. But come on,
these guys came here to try to prove to us something that we can prove ourselves with math and logic and science. So at the end of the day, we don't have to start to get upset or like get rivaled or triggered by that.
Yeah, but they're pretender clowns.
Oh, I already know.
He's just doing his job.
At the moment, what we're doing is we're talking about light and it acting like a mathematical model.
But
now, a mathematical model isn't real. Is it?
It doesn't matter if it's real. When you drop an apple, it acts like the mathematical model of gravity.
See, that's exactly what I just said. I just said that. I was like, that's like fucking Neil deGrasse Tyson saying, "This is gravity drops the mic." Are you serious? Is that it?
Bong, I'm on.
Is that all you got, man?
But I'm trying to say, like, at the end of the day, like, if we're on this side of the fence, we should be sitting back in our chair and chilling. Like, we don't have to sweat them.
Oh, you should be.
Like, we have to let them fucking sweat because we already know we've done the math and they haven't done the math. So,
done the math?
I don't give a fuck.
Done the math?
Yeah, done the math.
Bring Neil deGrasse Tyson here, West. Okay,
Mick said he doesn't have to have independent and dependent variables in an experiment, right? He just said that.
Well, it depends what type of. If you want to have a strict interpretation
Penn State University. Let's go through these. Can we go through them, Mick? So we have Mick that says you don't have to have Mick.
Yeah, but
can I speak?
You don't have to be frustrated by guys that are just talking shit, trying to fucking waste our time.
Can I speak, please? I'm gonna refute Mick.
Go.
Pseudo McWestian 2 space. I'm gonna refute him right now. Are we ready?
Space. We live in 3 space.
Not according to your friggin' fairy tale gas model, but I digress. We'll get to that in a moment. Experiment. You said you didn't need Mick. You said you didn't need a dependent and independent variable in an experiment, right? That's what you said?
For the common understanding of what an experiment is.
Yeah, I got you on tape, so that's what you said. Here we go. Experiment, Penn State University. There should be 3 categories of variables in every experiment. Dependent, independent, and controlled. The Institute of Physics.
Would be great.
That would be great now, wouldn't it?
That's just one definition of.
That's okay. Let's get another one. Institute of Physics. When planning an investigation,
you're giving the same
definition. Please shut up, Mick. When I'm pummeling you, please shut up.
You're just going to keep doing the same thing over and over again.
Yeah, I'm going to keep refuting your dumb ass.
I'm going to take control, John. Going to take control. If you're just going to turn around in a minute and say, no, I'm just going to keep over-talking you, then that's not helping the conversation. Just let him finish. I'm sure he'll finish much quicker if you stop interrupting him.
Yeah, but I know he's going to do the same.
Don't even appeal to me. Next person's going to speak is going to be John. He's going to finish, and then you're going to answer.
Institute of Physics. When planning an investigation, students need to identify the variables that they consider significant and then select the ones they want to look at for cause and effect. If possible, any other variables that will affect the outcome of the experiment will need to be kept constant during the investigation. The variables are independent variable, dependent variable, and controls. Anne-Marie Helmutstein, PhD, Biomedical Sciences. When you design an experiment, you are controlling and measuring variables. There are 3 types of variables in an experiment: controlled, independent, dependent. Is that enough yet? Do we need to go a little further for you, Mick?
It's fine by me, because I already said that. That's one useful definition of an experiment, scientific experiment. Yeah. I mean, it's the type of thing that Nathan Oakley likes to go on about it. Because when people talk about an experiment, they don't necessarily mean that very, very precise thing.
Doesn't matter what they mean in the colloquial sense of experiment, just the broad umbrella experiment.
We were talking about scientific communication.
When I meet a girl at the bar, I want to experiment.
Scientific experiment.
Science.
And you're saying you don't need the IV, DV, and the CV. That's what you're saying.
I think that if you're trying to communicate science, those are not useful concepts to discuss with the general public.
Because the experiment and breaking it down into a very easily formulated method of where your dependent variable comes from, your naturally observed phenomena, and then how you build your hypothesis,
generally
you're answering the question of what causes that. So there's your independent variable. And then obviously you've got a control shit. So there's your controlled variables. You then got to take this forward in your experiment and test your hypothesis. Without these independent variables that are very easily explained, if that you just hand away from away about doing an experiment. Doesn't involve something that you're trying to manipulate to prove a cause of an effect.
Right. And the gold standard is basically that when you change something that you know is the cause independently, since you're independently changing the variable, you get a dependent variable that acts in accordance with your hypothesis to prove with as much proof as possible the causal relationship. And you have controls in the experiment that shouldn't change. If the experiment is properly controlled, all the factors have been factored, and nothing weird is changing in the experiment. If one of your controls changes, well, then perhaps there's another explanation you haven't explored or controlled for. Take with gravity.
Let him answer. Let him answer because hold on. Calm down. He said that you didn't need an independent or dependent variable in an experiment. I provided many citations here that said the opposite. Let him answer, please.
We're talking about scientific communication. And when you talk about things like dependent variables and independent variables and control groups, it confuses things for the general public. It's usually better simply to describe what the experiment does. You can keep that other stuff in the background as useful information. Like, this is why we need these things. We need controls. We need like this independent variable. We need a dependent variable. But in terms of scientific communication, it's usually best just to describe what's actually going on and what it shows.
Nick, you baited. Nick, I'm sorry, I'm going to have to stop you. You baited and switched us. I didn't ask you what you were teaching them. I asked you personally, what are the 3 constituent parts of an experiment? And you didn't know.
I couldn't remember off the top of my head at the time, and now I remember.
Man, can I quote you? Can I quote you from Wikipedia? It all stems from a fundamental distrust of science and authority. Are you not trusting science and authority when you say those things? Like, you don't have to explain the variables. Like,
so you're quoting Wikipedia? Like, if you look at the Wikipedia,
are these your words or not? Are those your words or not?
Which words?
The word on Wikipedia.
Which ones? What? I'm not sure what you're talking about.
Read them again.
I didn't write anything.
Right. Yeah, just read them again.
It all stems from a fundamental distrust of science and authority. You are always going to get a percentage of people who are true believers. My goal is to minimize that as much as possible, to stop people falling for it and help them get out as easily as possible. What does that mean?
That is what I said.
So we're talking about the scientific method here, and we're asking for the variables, and you're saying, what are you saying? You don't need those, or what?
I'm saying it's not productive. It's not productive for communication to the general public.
It sounds to me like he's describing atheists when it comes to religion.
But people asked me about science communication. They said, you're a science communicator. What is science? And I was trying to talk about it in the context of science communication.
Do you even know what that is? Do you even know what that is? Makes you a shell.
I'm scientist.
That's such a corporate little turd term. You know that, right? I'm a science communicator. I'm a product communicator. I communicate what the product is. You're an advertiser.
I don't say I'm a science.
I create synergies between.
Advertiser with a stick down your throat.
Well, propaganda is important even in science, saying proof for evolution or, proof of the God particle. Part of it is how you disseminate it to the masses to get funding and get support for your projects. But with gravity, we don't really have an experiment that's properly controlled to say we can tell that this is gravity versus, say, electromagnetism or something else. We don't even have proof that it coalesces things into balls for heliocentrism or makes orbits for heliocentrism's extravagant claims. That's why these experiments preferably would be properly controlled with some decent variables, and sometimes you have to revisit the experiments if you discover something after gravity's formulation, like, say, electromagnetism. Just to see
we're getting off into gravity and electromagnetism.
Yeah.
Hold on.
I think you're getting off into semantics as well.
Yeah.
Maybe we should get back to
semantics. Words mean things, Mick. So let's summarize. Yeah, words mean things, Mick. But let's summarize. You are a science communicator that didn't know the constituent parts of a scientific experiment.
The top of my head.
Fail 5th grade general science. Just to let you know. Okay? Thanks.
That's fine. No.
and light isn't
Well,
a wave.
that's the general pattern. I mean, he knew what we were talking about in general. That's not what's important. What's important is the shape of the Earth, and these experiments that are used to undergird gravity. Light appear not to have been very well controlled, and so we may have bad theory, built on top of bad theory, built on top of bad theory, leading us to where we are.
You don't have bad theories, Lemon Bird. Just stop. There is no bad scientific theories. Scientific theories are validated, confirmed hypotheses. There's a lot of things that go under the term theory that are not scientific theories.
To the general public, the word theory and the word hypothesis are pretty much interchangeable. Sure, not for scientists.
Yeah,
for the general public.
Yeah, that's the problem.
That's scientific theory. You're talking about colloquial theory?
That's intentional.
Or scientific theory?
Yeah, and this is why words mean things.
That's just you changing the meaning of words so you can weasel it around and make it mean whatever you want. And that's been intentional. And politicians,
how people use them.
Politicians have been doing that for a long time.
Really? What?
There's a word that we use quite often, just band it around, hoping it's going to do something that it probably won't because you can't demonstrate it. Refraction. Words do definitely mean things as well. Yeah, go on. Let's get back to this bending of light, and you tell us what light is. Let's go.
All right, excellent. So the problem is that, like I brought up the idea that light kind of acts as if it is a wave.
Wrong. You're wrong, Mick. I just drug you through the friggin'. I just drug you around by the short hairs for 20 minutes over this. Okay, please tell me in the photoelectric context how light is a wave. Please, the floor is yours.
Well, what I'm saying is that it appears to act like a wave.
Appears is not reality. I just told you the wave function is what you're talking about. The wave function is not real. How many more times do I need to go through this?
I thought that the entire flat Earth thing was that appearances are reality.
Oh my God!
Can't you just know what you see?
Well, to be fair to Mr. West, the wave function is based off of activity in reality and is a close approximation, ideally, as possible. But it is a mistake to reiterate it as reality if it's math and numbers. It's a model of what we think happens in reality. That's all.
Well, let's forget this whole wave thing then. Let's just ignore that for now. Let's just go back to just observable refraction. Like you would agree that...
Oh, hold on a second. Are you talking about terrestrial refraction?
Talking about refraction as a physical phenomenon.
On Earth, you're using terrestrial refraction. Is that correct?
Oh, I'm talking about light passing through a medium and how the refractive index gradient affects.
Okay. Can you please post? Okay, I got you. Can you please post? Let me pull Discord up in the live stream. I want the formula for refraction, please.
Which one do you want?
Which one?
Snell's law? Because that's not the one that's actually as applicable.
Which one? No, we want refraction, terrestrial refraction, Mick.
Ah, dear. So this is where we get into problems with science communication because it gets quite complicated. Refraction happens because of the refractive index slows down light. So light.
I don't want to. Mick, what did I just ask you for?
The equation of refraction. But so I guess if you want an equation, I've got to know what are the inputs to that equation and what's the output.
You're the one that claimed refraction, Mick. What, do you want me? It's not my job to support your claims. So please give me how they compute terrestrial refraction. That's all I want. We're going to evaluate the formula to see if there's any begging the question fallacies in it.
Right. So fundamentally, the refraction is governed by the speed of light in a medium. The speed of light in a medium is the speed of light in a vacuum divided by the refractive index.
No, it's not. No, it's not. You don't know this. Don't go into the speed of light, Mick. We want the go to Wiki for fuck's sake. At least
that actually is the underlying formula.
Oh my God!
It's a simplification.
Refraction.
That's actually a simplification.
All right,
but we're not seeing light travel through a vacuum. So why would you invoke that? We're talking about here, right? There are no vacuums here on Earth.
What you're trying to yeah. Do you know what a refractive index is?
Well, the refractive index
Unbelievable.
Travels through a medium, but we've seen 7.6R, we've seen 1/16th of it, R or whatever, or a degree. How about the one that gives the biggest amount of refraction? That'll help hedge in the discussion. How about the equation that gives the highest amount of refraction? Let's go to the limit. How about that?
We just want to see the equation they use for refraction. That's all I asked for.
That is the equation that you use for refraction. It's the speed of light divided by refractive index.
Where do they get the refractive index from, Mick? I want to see every variable in this equation. See, Mick, with equations, right? Every mathematician will tell you that every variable in an equation must be rigorously defined. I want you to post that friggin' equation right now, and I want you to define all the variables. You claimed it, you support it.
You're a programmer. You know that.
There's only two variables here, which is the speed of light. Well, it's not a variable, it's a constant. The refractive index is the only actual variable.
Oh my God.
Now, it varies based on the density of the air, which kind of varies based
optical
on temperature
density.
and pressure.
It's the optical density, not the mass density.
Humidity. Yeah. The optical density, which defines the refractive index.
There's a square root of epsilon times mu.
So the refractive index
electric permittivity of free space, and mu being the magnetic permeability of free space. So that's the actual refractive index. The values the values of vacuum is 1, and every other medium is set relative to that.
But I think the thing that's missing here is,
obviously.
I think the thing
that's actually pretty straightforward.
Yeah, hold on a second. I think the thing that's missing here is people are assuming that the refractive index is perfectly following the curve of the globe. Over 20, 30, 40, 50 miles is following perfectly. The refractive index within water or whatever medium that we're talking about is going to be whatever it is. But to assume that it's going to follow the globe perfectly all the way along at whatever distance we're talking about is ludicrous.
It's not what anybody's saying.
It's laughable.
Nobody is saying that. So you can laugh at it all you like, but no one's saying it. So you're laughing at ghosts.
So then at what point does refraction become a moot point? At what point?
It never becomes a moot point.
10 miles? Give me a number so I know, okay, refraction goes up until this point.
Refraction is always there because the atmosphere is always there, but usually always you get extinction.
There's no demonstration.
It's actually
that it's always there.
It's garbage. Give me some numbers so I can put my numbers to it.
The maximum refraction you should have is 7 inches per mile squared. I think the max with 7.6R is 6.8 inches per mile squared. That's why it helps to put this discussion within certain boundaries.
That's a simplification.
Yeah, exactly.
I was explaining earlier.
Matter. The boundaries matter.
You have to look at
the boundaries don't matter. It's
no, they don't. They don't matter.
Let's put these things within boundaries. Where does refraction bend? How much does it bend? And to what limits does it bend? And if it's beyond the limits of refraction, if we're talking about something that's beyond the limits of refraction, then we shouldn't even be talking about refraction anymore.
We need to look in history for the greatest refractions in history, and let's put that down as the refractive index. Let's try that and put this thing within certain boundaries.
Exactly. Yeah.
That's not how it works, sir.
Well said, Lemon Bird.
You have to use ray tracing.
Of course, that's not how it works. We don't understand.
Oh God, Ray! You still haven't answered my question though. Mick, do you see the live stream?
Yeah, I see the chat. Yeah.
Do you see Quantum Eraser? Do you see my post right in there?
Atmosphere is curved, follows the shape of the Earth. Calculations below. Rough value.
Of course it does.
What are you asking here?
Well, I'm not asking anything. I'm showing you that terrestrial refraction takes into account the radius of the Earth.
Well, that's because the atmosphere is curved.
So that's a big. You have to prove that the atmosphere is curved.
Wow.
Listen, can I bring up a point?
Well,
hold on a second. Let Mick prove that the atmosphere is curved.
We know that if the surface of the ocean is curved, we can see that.
Wait.
We're not using refraction to curve the curvature of the Earth.
Here, right? That's the only curvature you're about to find.
I don't know. You just said the atmosphere. Now it's the ocean.
Let's say it's not curved. Then let's say we don't know if it's curved or not.
Sure. Everybody knows that water does not curve. Everybody knows that.
What I was saying, Mick.
People know that.
What I was saying, Mick.
It's not actually true.
What I was saying, Mick, in the beginning when I said terrestrial refraction, I was trying to lead you to the definition and the equation for terrestrial refraction. As we can see, terrestrial refraction. I'm not done yet, Mick.
I know,
just one
I know
second.
what you're going to say. So
just one second. Oh, yeah, but this is for the audience.
Okay, go ahead.
What I wanted to say was I was trying to lead you to give us, because you claimed it, I just wanted you to support it. And as we can see, that terrestrial refraction is computed by already assuming the radius, i.e. curvature of the Earth. So to use that, you must first scientifically validate the radius of the Earth, and then we'll let you use your terrestrial refraction.
Yeah, okay.
So go ahead.
That's fine. No, that's not a problem.
Is that fair? Is that fair?
Yeah.
Okay,
yeah,
so
but we're not using refraction to prove the curvature of the Earth. We use Earth.
What are we using? Are we using measurements over land?
Okay, we've been talking about refraction all this time.
Yeah.
So why were we talking about So why were we talking about Hold on. One at a time.
Cut that out. Timestamp it. 2019. Mick West. Someone quickly.
Well,
that's hilarious.
Okay, listen. He's under. Listen. He's under great stress. We're all pounding on him.
I'm not worried at all. We use observations that are high up, that get above like the worst effects of refraction. So you stand on something like a cliff and you look at the distant mountain. So you're not looking too close to the surface of the ocean. Where you need to use refraction is to explain things like these laser tests or these mirror flash tests that go very close to the surface of the ocean.
Of course. So the ones that are actually measuring the ground of Earth, that's where we
I just want to ask a simple question.
No, they're not.
What model of refraction can make predictions? Is like what you just said. That's a post-diction. That's the Earth is curved. I see this, therefore my model, I'm going to fit that observation to my model. As opposed to, I have a model, I see an image, and now I know how much refraction, and I'm going to make a prediction based upon weather conditions on what I should see and what I shouldn't see.
Yeah,
that type of
and the assumption that refraction is going to follow.
That's a great question, and I have the answer.
There are hundreds of models of refraction. Yeah, you are aware of that, right?
Listen, I think that the thing that we need to focus on is the fact that they're trying to assert the fact that the refraction is going to follow the curvature of the Earth perfectly without any fucking deviation is insane.
Hold on, guys. We're doing it again. Hold on, Mick. Sorry, one sec. We're doing it again, guys. Someone makes a point. Someone brings up another point. Now Mick has 2 points to address. Can you first address what model you what model do you use or can you use to make refraction predictions?
You use one that incorporates the temperature gradient, and then you use ray tracing to trace the path of rays through that through the medium. And the more detail you can get in the variations of temperature, the better. But if you simply do a vertical temperature gradient and then do ray tracing through that, you can predict what things will look like. And I actually programmed a simulator that does exactly that, which I can share the link with. Let me look it up. Can you show it
actual measurements or tests to validate that model?
Yes, I can.
Okay, so let's see them.
Well, you want me to actually? I did it with Dr. Johns.
I know they don't exist because I've seen every experiment on refraction ever done in the last 150 years.
The dog ate them, Indio.
Used Dr. Johns' numbers, and it came out to be like basically matching what he saw with his numbers.
Indio, he said he had scientific evidence of this.
On a curved.
Indio, he said he had scientific evidence of this. Can he give us? I'm sorry, Mick.
I'm still wondering how it gets sucked. It's sucked into other layers. I'm still wondering that. You got a vertical
that's what we were talking about earlier. That's a great question, and I love talking about that because it's something that I didn't understand myself at first. And I actually wrote to this famous refraction expert, Andrew Young. He kind of explained it to me. But yeah, it seems like it shouldn't if something's going kind of between the layers, as you say, it shouldn't actually get bent down, but it does because
it does because the math says it does, or because it's observed.
No, you can actually demonstrate it. You can demonstrate it.
It sounds like we're assuming.
I just want to see these demonstrations, dude, of these models. Right?
Well,
these
the problem
models
is
that actually make predictions that are accurate.
Yeah. All right. Let me get my refraction simulator link up so you can see it.
Wait a second.
Wait, you wouldn't even give people data on your calculator, but yet you're going to expect us to believe that crap? Really?
I'm saying
sending you
models,
a link.
right?
I've got a link
reality, and we validate models by experiment, right? So where are the experiments validating the models?
Yeah, we want the hypothesis,
I know who A.P. Young is. I've read everything he's published, right? So I know who these people are.
Where at San Diego State University?
Use ray tracing. You're going to get a bend just from the nature of the equation, right? But that's just the equation. But that's fine. That's a model. So where's the actual experimental validations of these models?
Dr. John's experiment
Controlled experiments.
Dr. John, hold on a second. Hold on a second. We already talked about Dr. John. Dr. John didn't conduct an experiment. He already said as much. You don't know what an experiment is. That's the problem. Hey, Indio, he said scientific evidence. Can you please have him post the natural phenomenon? Go through the steps of the scientific method, please, Indio.
The natural phenomenon that he observed? There isn't.
There isn't one. What's your dependent variable?
Let's see, the temperature gradient.
Of the Earth.
The temperature. So the temperature gradient. Hold on a second. Hold on. So I'm going to write this down, Mick, because I want to make sure that I got this correct.
Temperature. It's just the changes. Are you doing the changing, or is something else changing based off of your changes? That's it.
Hold on a second. He said hold on a second. Hold on, people. Relax.
That's the dependent variable. Actually, will be the image itself.
So we're going from the temperature to the image now?
Get them mixed up. But it doesn't matter.
Wait, 1 second. So if I manipulate the image, what will I get?
No. If the temperature gradient changes and the image changes as predicted by the model, then that validates the model.
Mick, you have to have a hypothesis because a hypothesis is a scientific prediction. So we're only at the first step. Mick. 1 second. Now, the dependent variable, your observed phenomena, is now the image?
Yes, the image.
Okay, what's the independent variable?
I don't know. What would you... Give me an example of an independent variable.
He doesn't even know. The temperature,
oh my God. Mick, thank you.
Just want to make sure we've got the right terminology here.
Mick,
so, the temperature gradient.
Mick, it's your experiment. You're asking me for the independent variable for your experiment, son.
Yeah. So somebody clip the temperature gradient varies. It has an effect, which is changing the image. So, hypothesis. The hypothesis is that there's a model. There's the Earth is.
No.
Every time you stop real-time shit.
It's over 5 dozen people in here.
We're already on a ball when this is happening, right?
This is a clown show, Mick.
The hypothesis? Wait, did you really just say the hypothesis is it's a model?
Have you seen my refraction simulator?
Let him describe it.
Hold on, everybody. Please let him finish. Could you please let him?
Yeah. Go ahead, Mick. Go ahead.
Mick, I'm gonna have you over for a beer.
Cool. So the model. You want me to describe the model that I use?
No. Let's just summarize. Yeah. 1 second. You said the dependent variable was the image. The independent variable was what?
The temperature gradient.
Temperature gradient. Okay. Give us your hypothesis.
That if you ray trace light through air that is curved, with the temperature gradient being like the same over every point on the curved surface, then you will get images that match reality.
So I thought you said the temperature gradient was your independent variable. In your hypothesis, I didn't see any temperature gradient being manipulated.
You would take 2 different temperature gradients.
No, you, Mick,
You can't manipulate temperature gradients because that's what they
then
are.
It's not a viable independent variable because your independent variable is number one, your cause. Number two, you have to vary and manipulate it.
You vary and manipulate it by waiting to a later time in the day.
Waiting. Very manipulating anything that's waiting.
So is this proof
yes,
of
but it
time?
changes. It changes.
Are we going to prove time? If your hypothesis is time, is that what we're trying to prove?
Let's say your hypothesis is that you can see better.
You can manipulate the
distance. Does this have anything to do with the flat Earth?
No.
God, he's Doctor Who.
Flat Earth.
All right, guys.
So,
all right, guys.
We have to.
Mick, thank you very much, sir, for showing what a complete imbecile you actually are. Thank you very much.
This isn't
That'll be all
about
for me.
Midwest. This is about the flat Earth. But we have to assume curvature, so it's whether or not there is curvature on the Earth. And so if we do not have reliable sources, say because NASA is lying, or because lenses are adding curvature, we may need to revisit the very basis of our hypotheses that we're, making these experiments off of.
Sure.
I think my simulator does actually fulfill the criteria for an experiment if you apply it to real-world situations.
May I ask a quick question, Mr. West? What caused you to join our server today? Like what?
I was invited by somebody. I can't remember his name. It's somebody flat Earth literalist. No, flat Earth level literalist.
Horizontal.
Thanks, Ben. I thank you for gracing us with your presence. Yeah.
Welcome. I'm talk about this stuff.
Did he happen to ask you?
Very interesting. I like the variety of feedback that I've got, and I know that you think that I'm wrong, but I would disagree. And I would encourage you to have a look at the refraction simulator because it's quite detailed, and it simulates a number of different things.
So
it even does lasers.
Does this refraction simulator simulate the distance with which refraction starts to divert from the curvature of the Earth, or does it just follow the curvature of the Earth all the way around 360 degrees?
When
does the refraction stop? Is my question.
It doesn't stop.
So it goes all the way around 360 degrees.
No.
So when does
look at it?
If it doesn't
look at it, and you'll see.
If it doesn't go 360, it has to stop somewhere, right?
It stops because of atmospheric extinction and scattering.
Okay, but where does it break?
Theoretically?
Where does the simulator stop working? Is my question.
My simulator is only set up to go to really about 200 or 300 miles because I didn't see much point going beyond that.
Limit to the simulator. Okay.
Yeah, actually, let's see. I think you can set it to be quite a long way, but it's kind of pointless because you won't be able to see that far anyway.
200 to 300 miles
of variation.
Is that a flat surface or 200-300 miles of a curved surface?
You can do both. You can set it to be flat or curved, and you can turn
on your simulator.
What's the drop on 300 miles?
Either.
What's the drop on 300 miles? It's that's a crazy amount of drop, right?
Yeah, no, there is a crazy amount of drop.
So you're trying to say a laser that was shot over that?
No, I'm not trying to say that at all. Not at all. No. It's
not going to hit a target.
No, you're not.
So then how is it accurate if it won't hit a target over that distance?
It will show you not hitting it.
It'll show you not hitting it, but then it's not accurate. So that means that the distance that it's actually accurate is less than that. Am I wrong?
If I showed it hitting it, would it be accurate?
At 100 miles.
I'm asking you the refraction indicator, whatever the device you're talking
simulator.
about.
It's a simulator. Have a look at it.
It's going to tell us refraction up to a certain distance.
Let me show you a screenshot of
it. Don't interrupt me. If the laser does not hit the target within that distance, that means the simulator is wrong at that distance. That means we'd have to scale it back because the simulator is shit. Maybe the simulator only works for 200 miles or 50 miles or 100 miles, whatever it is. But there's a distance where the simulator breaks and it stops working. So we need to know
still waiting on that data to support
with a laser, because if we're talking refraction bullshit right now, there's a limit where the simulator is going to stop working, and my laser is not going to make it around the curve. What's that distance? If you're telling me it goes 300 miles, I need to know what the drop is at 300 miles, given the numbers that NASA gave us. If it doesn't add up, something's broken with the simulator or something's broken with NASA. Nothing's broken with our math on this side. So somebody has to set it straight for us so I get what's wrong here.
Simulator uses like real world situations, so it's trying to like demonstrate what you actually see.
That can go 200, 300 miles. But if it doesn't go 200, 300 miles, then something's wrong with the simulator. Is it?
The simulator uses real world conditions to an extent, right? Until you invoke that radius, right?
Well, did you account for the temperature of the water, if there's water in there, and the gradient temperature, whatever, of the atmosphere? Did you account for all that? Like, probably not.
Yeah,
right? I don't believe because you just spoke about how you did an experiment where you put cold, the hot pushes the laser towards the cold, right? Did you account for that?
No, that's not an experiment.
It's basically built into the simulator.
None of that is in your simulator.
Lasers shoot straight to my eyes.
No, it is because you can
altogether. I don't give a fuck about a simulator.
The temperature gradient.
Yeah. He didn't perform
something you don't have all the variables for.
Refraction is bullshit.
Yeah. He didn't perform an experiment. We already established that.
To fucking distract us. Refraction is bullshit. Straight up.
Yeah, and he has no experiments. He doesn't even know what an experiment is.
Hold
on a second. I just want to finish up. Mick, friend, sir. Hello?
Oh, I'm here.
Yep. You have been erased. Thank you very much. Have a nice day.
Yeah.
Thank you. Terminated.
The problem with refraction is usually it's only talked about in one terms going up and down. But if light goes in all directions, we should talk about, the image refracting this way, that way, left, right, up, down, in all directions. So the model appears to be inadequate in some ways theoretically, does it not?
Yeah, makes sense.
It's pretty much up and down there because of the gradient usually goes vertically. You do get some side to side. If you look at things like the air over a bonfire, you will see all this kind of shimmering, and that's a bit of side to side movement as well. But in the atmosphere over long distances, it's really only up and down.
Sure, but by their simulator, 300 miles, it follows the curvature of the Earth flawlessly. It's laughable at this point, man. The fact that they say it out loud is embarrassing.
Who's saying that?
I don't know who said it. Somebody said it. I don't know. I didn't look at the names, but somebody said out loud, 300 miles.
It's a little bit of special pleading because the picture should be unstable, hazy. How is it stable? Going over the curve of the Earth in one direction, up and down. I mean, this is just too much special pleading, and we haven't even factored in perspective at all and how things can compress to the eye line of the observer based off of the angular resolution of light and the angle that the observer is viewing the object at over possibly a flat plane.
It's all built in. It's built in because I do proper projection.
What curve of the Earth?
Making a claim and actually providing the data is two totally different things. Your bullshit claim means nothing without data behind it. Prove your calculator is even worth anything. Where's the data that John D's been asking for months?
How dare you?
I was using his data.
Here.
No, he's talking about.
Kid.
No, did you? Wow, you're not even paying attention.
I don't need to.
I'm talking about your atmospheric refraction simulator. It has not been validated yet. Dr. John D and you had a thing going around about this. You never answered him. You never gave him the data on it yet. So we can't trust that simulator.
See what I just posted. See what I just posted in the chat.
What a photo is not proof of anything.
Oh, that's what Dr. John uses as evidence of things. What I posted is
he's asking for the data for your simulator to validate it, to make sure your simulator is following the proper laws. That's what he's asking for. You're not providing it. You never did.
I gave it.
No, you did.
You can go. You can.
Really? Where's the video of him going over it then? Because it's not there.
He obviously did not. Let me find it. My email that I sent to him.
I have a quick question. I just want to know, Mick, when did you start debunking conspiracy theory?
It's about 2005, but it's kind of stuff I've always been interested in since I was young.
And don't forget, we can find out if he actually communicated with you or not. We have.
Yeah, I've got all his emails here. You a screenshot of my
screenshots of what?
My exchanges with Dr. John.
Screenshot of what? Like I said, it could be anything.
It could be, but
it doesn't have to be you and him. Literally.
But yeah, it could be all lies.
We need to validate that you actually made this conversation with him and not through you. I need to hear it from him.
All right. Well, you can.
I can't trust
CC you on an email if you like.
You kidding me?
No, that's true. That's true. I would encourage you not to trust me. I'm just trying to find where I sent him.
That's a weird statement.
Hey, I just looked at the values in your little calculator here. Is that in degrees? The beam divergence?
Which one? Oh, yeah. That's. Let me. I think. The
degrees are radians.
I'm tired of the math that they're handing us, bro. I'm just tired of the fucking math they're handing us. The only
beam divergence for the laser.
It's just a bunch of magic tricks.
Only math I want to talk about is the curvature of the Earth math. No
I think
other math.
the laser divergence is the standard laser, which I think is like in degrees per 1,000 meters. I'm not entirely sure though. But whatever, like the standard units of laser divergence.
Large. Well, I'm just going by the screenshot.
Yeah. So it's or per 1,000 feet or something like that. I can't remember what it is. I could look it up, but I was looking up something else.
Well, I mean, there's only going to be one angle
not in that screenshot.
It isn't going to like. Listen, if it exits,
on the screenshots,
25-degree angle, it's going to stay at that. It isn't going to get crazy.
Divergence is greatly exaggerated on the screenshots. You can actually turn that off with one of the options, side zoom. It turns it to flat.
Yeah, I'm not interested.
Anyway,
in that. I want to talk about the measured flat Earth and like why that 8 inches per mile squared. At least that parabolic equation doesn't fucking ever come out the way NASA told us it should. Like that's the only thing I want to focus on.
Because of refraction, basically.
I'm not even interested in talking about. I don't want to talk about space. I don't want to talk about refraction. I don't want to talk about shit.
The problem is
8 inches per mile squared. Why is it found by the people that
you've got a big problem? You got a big problem.
That's all I want to talk about. Everything else is bullshit to me. Everything else is word salad. Everything else is obfuscation. Everything else is bullshit. Where's the 8 inches per mile squared? Let's talk about that.
Catalina.
Explain that to me in simple terms, because I'm so dumb. I don't get it.
We know how far away Catalina is. We know how high we are off the ocean. We know how far away Catalina is.
What do we know?
How far away Catalina Island is from Santa Monica. Santa Monica.
And what's the distance?
I believe it was 35 miles.
35 miles. And what does that equate to in terms of curvature?
You mean in terms of how much should be hidden?
Droppage.
Well, droppage isn't the important
no, it
thing.
is.
It's the actual...
I should not see how many feet should be obfuscated from my view. That's what I
well, that's not the same as drop. That's the hidden value, which is different because that depends upon the viewer height.
Let me just get to my curve. That means it's no longer in my view. It's obfuscated from my view because it's past the curvature, right?
All right, so 35 miles.
How much? How many feet?
You should have 682 feet hidden.
682 feet.
Or 576 with refraction. Yes.
Is that what we observe?
Yes,
and that's what we observe. Mick, I got a picture in the chat for you that shows your point.
You can't invoke terrestrial refraction, Mick.
In reality, Zanuck, hold on, I'm talking.
Hold on a second. He invoked refraction again.
Is that?
Oh my God. We can ignore that if you like.
He added it.
Mick, is that what we observe in reality, or can we actually see Catalina Island?
Yes, we can see Catalina Island.
See what I showed you in the picture.
Well, that's a problem.
If you can find
because Catalina Island is like 1,400 feet high or so.
Okay, well, how much of it can we see?
I just did a
the amount that is expected. Look at the photograph that Zanuck posted.
Let me show you what it looks like when you're closer in the shore.
I found a video. I just did a quick search, Catalina flat Earth, and here's a video that shows flat Earth and Catalina Island from 48 miles away. So what do you have to say?
I've looked at many photos of Catalina.
What distance is this?
About this guy he has a video.
But there's an up close picture.
But his video is just showing that you can actually see Catalina. Of course, you can see the top of it.
48 miles away. 48 miles, not 36. 48 miles.
Did the observation from across the water, Catalina Island.
This guy.
Order in the court, guys.
You can see the amount of Catalina Island that you would expect.
Useless. We need someone that actually did the entire experiment across the water.
I've been there.
Measured the shoreline, measured how much we could see.
That wasn't an experiment.
Right, so do you deny the existence of Catalina Island, or just how big
it wasn't an experiment? Is the problem?
An experiment.
Observation.
You're taking a picture of like the mountain, like look, Catalina
Twin
Island.
Harbors
Like,
there.
what does that have to do with
You can
anything?
see the
We're talking
picture
about
from the shore
the
of
curvature
Santa Monica.
of the Earth.
What about the video I posted where there's 2 minutes of a guy zooming in from farther away than you guys are saying, and there should be no Catalina Island at all.
Let me look at that real quick.
Oh, we could do the math on that.
From Santa Monica Pier, how far it was?
You can say your little observation, but I just posted a video with the alternative.
I got the video. I'm watching it now. What are you saying?
See, but here's the thing. It's like
You're saying exactly what I showed you.
Here's
from
the thing.
48 miles away.
Here's how.
Can you hear me?
What you would expect to see.
Here's the thing.
It's showing exactly what I showed you. See that?
Hear me out on this one. I'm not even gonna watch the video. Let's be honest. Like I'm not even gonna waste my time with the video. There's so many observations that people have shown distances that we should not see. So if you post a video that I can see it, I'm like, well, now I'm like, did you doctor it just to fucking make a point? Because like, if we have observations after observation after observation after observation of shit we shouldn't see, why don't you reconcile the shit that is on our side? Don't bring me another video that I've never that I didn't reference, that didn't come from one of us, didn't come from an independent observer. Give me a video that I've seen on my own. You know, make the Chicago skyline disappear, and then we'll have a conversation. Until then,
where are you based?
Chicago skyline disappear.
Do you have a place where you could go? Do you have a
and then
well, do you have a place you can go? I mean, I've been to Catalina and done it myself many times.
Skyline? That's not you can just disappear. I don't know where your video came from, nor do I trust it.
There's lots of videos of the Chicago skyline being hidden.
I'm going to trust you? I don't know who you are.
No.
I don't know.
So do an experiment.
I don't know how you make your money. You think I'm going to trust you?
Do an experiment,
Tony Hawk.
The Great Lakes.
Do an experiment, Mick. Wait a second. He said do an experiment. Mick, you didn't know what an experiment was when we first discussed this.
But you're saying that experiment has to have an independent variable, a dependent variable, and a control.
Yeah, I'm not saying that.
And you... Okay.
Penn State, Colorado State, the Institute of Physics, the National Science Teachers Association, they're saying that.
Let's say my independent variable here is my height above the ocean.
Height is not a viable independent variable because it doesn't cause anything, Mick.
But your changing position changes how much you can see of an object.
Independent variable is your cause. Height doesn't cause anything, like depth doesn't cause anything.
Height changes your view position.
No.
It will change what you see.
It doesn't cause anything, Mick.
It's a variable which is tied to a result. There's a direct correlation between the height and what you can see.
Correlation is not causation, Mick. And height is not an independent variable, Mick.
Seriously?
Yeah, height isn't an independent variable.
Well, what is independent?
Time. It has to be something you manipulate and then you see a change.
No, it has to be your cause. Not only it has to satisfy. Shut up for a second. It has 3 criteria it has to meet. Number 1, it must first exist. Number 2, it must be able to vary and manipulate it. Number 3, it is your presumed
it seems very definite. Very definite.
I'm out of here.
You are able to manipulate height because you're able to give the variable height different values dependent on the angle.
Are you listening to me? It had to satisfy 3 criterion, clown.
It's a variable. Basically, you vary the input.
Clown!
You do a different experiment, you take
Clown show!
Let's see if it hits all 3 criteria.
He just won't shut up.
Let's see if it hits all the 3 criteria that we've spoken about. So the first one, height. Is it real? Discuss. Is height real?
It's real. It's a real variable. Something you can change. And it has an effect. When you change the height, things change.
You clown! Let me ask you a question.
Stop calling him a fucking clown. Stop insulting him. The fucking behavior here is goddamn ridiculous. Shut the fuck up.
You clown.
I'm a fucking mod here.
You're a clown
shut the fuck up. Stop.
Yeah,
fuck you. I'm a goddamn mod here. So shut the fuck up. Stop insulting.
Okay, so listen.
It's goddamn ridiculous.
Let's do it the other way.
This is the Wild West.
Yeah. Fuck.
Yeah. Height is an independent variable. Thank you very much. I appreciate that. Clown.
Fucking children, shut the fuck up.
The output is how much of the island you can see. So that's the dependent variable.
You see what you've done.
The mathematical relationship that you can measure.
What's your naturally observed phenomena?
What?
See what you have caused.
The hiding of islands behind the horizon.
What's the horizon?
Persuaded by these
It's
guys.
the edge
What's
of
the horizon?
It's the.
What's the horizon?
It's the edge of the ocean.
No, what's the horizon? Is it the
Just telling you what the horizon was.
I suppose
told you where the edge
of the sphere.
Edge of a sphere, yeah, that's a
Not
good way of
actual,
putting
though, is it? This horizon. It is the limitation
Sure
of
seems
your
to
view
be.
when you observe across the plane of the Earth. It's not
Why is
actual.
why does the definition say apparent? Why does it say apparent
Which definition?
of horizon?
Probably they're saying apparent because refraction is a factor.
The line at which the Earth
it's not
the line
actual.
listen, the line at which the Earth's surface and the sky appear to meet. Appear.
Yeah, that would mean it's because it's
I guess
not actual.
someone cut out there,
not
but
because of
did they say
refraction.
appears to meet? I mean, they don't. They appear like they're meeting, but they don't actually meet. Obviously, one is just obscuring the other.
Yeah, that's why they call it apparent, Mick. It's where the sky appears to meet the ground. It never does.
Yeah,
That
of course
means
it
it's
doesn't.
apparent, Mick.
Hey,
Yeah, of course.
Can I ask?
Obviously.
The air does not
I'm
touch
dying
the
to
ground
ask
now.
this question
Fantastic.
before he gets banned again. Mick, do aliens exist? Yes or no, please.
I don't know.
That's.
I have a question.
Go on.
Is level curved?
Let me do that, chocolate. That's my.
Oh, I'm sorry, Bev.
Not even had a chance to go yet.
Bev, get in there, get in there. Go ahead.
Hey, listen, anyone that wants to ask Mick, since he's our guest here, a question, like just speak up and so we know who wants to ask.
I'm going. It's my turn.
Give it back.
Okay,
get it.
I want to ask Matt. Do you want to ask a question next? Matt Philosopher?
Yeah.
Need some more lube?
No, wait till Bev and then you go next, okay?
Put him on the list.
All right, yeah, I'm good. Go.
Sweet Mick, you still here?
Don't forget the KY.
Yeah. No.
Right.
We're going to get onto the level being curved.
No, just the reason I invited you here and the reason you came onto the thread.
All right, yeah.
Is like, let's take it right back to basics, right? We want to know about the curvature, right? So my thing is, I'm trying to get people to give us the best method they have for measuring the curvature of water level in a canal.
Yeah.
A mile long, let's say.
That's too short.
Why?
There's very, very little curvature over a mile. You need to do about 5 or 6 miles.
No, how much curvature is there? Your calculator?
7.9 inches.
1 mile.
Yeah.
It's not a lot. The drop over 1 mile is only 0.66 inches.
0.66.
Yeah, that is 7 inches, isn't it? Yeah.
Oh,
so 0.67 feet. 0.67 feet.
Okay, so that's noticeable, like, isn't it?
It's hard to see.
So what would your... No, I'm not asking you to do it or anything. I'm asking you, what would be your method
that's a good
measuring the curvature of said water level in a canal?
I would use what's known as the Wallace method. And the Wallace method uses raised targets. It's something that Jeranism did in Beyond the Curve at the end of Behind the Curve, the documentary, which you've all seen, I imagine. And basically what you do is you set 3 targets up. One is the camera, one is in the middle, and the other one is at some long distance. And you get them as high above the waterline as possible, but you make them all be the same height above the waterline. And then you look from the camera through the middle target to the end target. And you will see, if you've done it right, that the middle target is above the end target, which shows that the water is raised up in the middle.
Would you not, like, call a surveyor and use a level?
You could do, yeah.
Yeah. Do you think that would be a little bit more accurate than setting things?
Essentially, it's doing the same thing. Essentially, it's doing the same thing.
Looking or actually measuring.
Well, no, that's what surveyors do. Essentially,
they measure stuff really accurately.
Yeah,
they do.
So then, how do you handle the discrepancy when people measure across 25 miles and measure from
drop
from their
in water level?
The laser.
Yes, 0.04 degrees of drop. Of the horizon.
Of what? Of an apparent location.
No. Stop. No horizon. We're on water level in a canal.
Yeah, so
we're not going to the horizon. You don't need to do that.
Yeah.
You just have the best method for determining the curvature in the water level.
That's then exactly what I said then. You would set up these targets high above the water so you get above any refraction or minimal refraction.
Yeah.
How high above water?
Then you see where the line of sight from the first target to the last target intersects the middle target.
So
and you'll set up like a
datum. The datum you are using is going to be your sight.
I think Jedi was asking how high above the water because refraction is obviously to you guys a big deal. So we want to make sure.
No, you don't need refraction. There's no refraction in when we're measuring the level of the water.
The reason why I'm asking how high is because the higher you get off the surface of the Earth, you're increasing the radius value. So, for example, if you have 3 lasers, one foot above the surface, one, pardon?
Enough to make a difference. It's like a thousandth of an inch.
It will eventually, with altitude, start making a difference.
But
especially, hold on, I haven't finished. If you're presupposing on a curved surface, your target is going to be angled away. Also, if you have a low target, a mid target, and a higher target, because of the speed of light, having to traverse a longer distance across an arc, you wouldn't necessarily notice this speed of light change or the time that light would take to get to the top target because you've increased the distance between the two. Keep doing this with altitude, then that's exactly what you should find on your ball. And increasing the time it takes light to get from the laser to the target, and the target is curved and angled away over a distance of an arc.
We're doing 12 feet all at the same height. So if it was flat,
I want this one now. I want this one now because you're saying that we're on a ball. So if you increase the radius value of that ball, then this demonstration would take into effect. Correct? You will be able to prove your curve if you could demonstrate with altitude it took the lights longer to get from a target, which was further away because it's on an arced tangent, right?
Yeah, you could do that, but that's not a very easy thing to do. Like we're talking about an easy demonstration, like which you can do if you've got a 5 mile long body of water. You set up these targets 12 feet above the water surface, and you look along them, and you see that the middle target's raised up.
What would your datum be, though? Like in order to measure a curvature or a drop or something,
the water surface.
The what?
The water surface.
And I call
the water surface is level, being
because the ground's going to rise up as it goes out.
It smounds like a lot of bullshit going on.
What you're measuring,
that's perspective coming into play. So the object in the middle is going to look like it is risen up anyway.
Dude, did you not just hear what he said?
What did I just say?
The datum that you are using to determine drop is a level.
It's the water level.
Is the water, yes, which is horizontal.
It's level.
Yeah. Thank you.
No, it's level. Which is not horizontal, it's level. Sure. Different things.
There we go.
Yeah,
There's two types of level. There's two
types of levels. What?
Yes.
What, the real one and the fake one, right?
No. There's true level and there's apparent.
The one you can see and the one you can't see, right?
True level,
true level, and then the one that they
I've
say.
done construction since I was a kid. Level is fucking.
There's the one you can see and the one they say is curved.
In construction,
the one you can see, and the one they say is curved that you can't see.
Construction, apparent level and true level are pretty much the same.
You haven't lifted a fucking hammer in your life, by the way. I can tell by.
No, they haven't. Anyone who talks like this hasn't had a job.
I own a lot of hammers.
I can show you a hammer.
I don't believe you, bro. By the tone of your voice, you've never lifted a hammer in your life. I'm a worker.
I've got a hammer.
I probably have more hammers than you do.
And I'm a worker. You've never lifted a level in your life.
Can the real level
I own like 5 different levels.
Doesn't matter if you own them. Do you know how to use them?
Yeah.
In order to say that level is curved, you have to prove R, which you failed to do tonight.
We're talking about like what water.
Bullshit is what we're talking about.
Water's always right.
It's gonna be relevant.
I can hear by the way these guys' voices cracking. They're fucking just feeding us bullshit, man. I could already smell the bullshit coming out of them, bro.
Think my voice is cracking?
I know it is.
No,
Mick,
he's the professor.
I don't think.
Hold on, guys. I was laughing about the hammer.
Really sharp ears can hear. People that are lying or just too dumb to realize they don't know what they're talking about.
Vagabond.
Vaga. Give it a second.
Don't you think that's a bit hypocritical?
We all know. We all know.
Insults.
We all know. Whatever. You don't know what you are. I don't know what you are.
You broke up though.
I don't know what you are. I don't know what you are, but you're one of them, and you know you are.
I'm a retired video game programmer. I program Tony Hawk's Pro Skater.
So AK,
yeah, that's not all you are.
Your fucking life.
What programming language?
That's not all you are.
Video game programmer.
Hold on. What language you use?
Oh,
guys,
I retired.
Anderson Cooper, he's just a reporter, guys. Anderson Cooper is just a reporter.
What programming language you use?
I do actually have a lot of hammers.
He is a programmer. He is a programmer.
What programming language you use? That should have been like right off the bat. You should have been like, "Oh, I use C++, use C, use C Sharp."
You broke out. We use C++ in programming video games. I mostly program in JavaScript now, though. If you look at the refraction simulator link I posted, I'll post it again. You can do view source on that, and it will show all the code.
We don't need your simulator. I'll just play Skyrim.
You out of your fucking mind, bro? I'm not gonna waste 30 seconds on that shit.
I have a question.
Killing your own stuff.
What happened to Fallout 76, Mick? Damn.
Mick worked on it. That's what happened.
Hold on. He said he used C++. What was one of the
things Mick for 76?
Hold on. What is one of the things you use in C++? Main things.
What do you mean? What do I use? I programmed in it.
To release.
Get him.
That is probably the only true thing about him is that he programmed.
Hold on. No, I haven't heard a legit answer on developing right now. I'm a developer. I develop in C Sharp, but I know some C++.
C++ you use new and delete, or you can use malloc and free.
What is it called when you release resources? What is it? What is a deconstructor for that?
You're freeing the memory, so it could be a dereferencing, and it could be garbage collection. But it depends what you're talking about. There's lots of different ways of doing these things.
All right, so you give me the garbage collection. All right, what are pointers?
You're breaking up there, so
what are pointers? No.
He's questioning
He's verified. We know he's a programmer.
How do you know? What are
I like talking about programming.
Garbage collection is easy. One of the easiest things you can figure out. What are pointers?
Pointers?
Just ask him what's a stack.
That should have been a 2-second answer for you right there.
Buffer overflows?
No, sorry, you're cutting out, so I can't hear the question. So, can you repeat the question?
You already repeated a question.
I hear everything.
You just repeated the question.
No, I was asking you if that was a question.
Buying time.
Okay. Now you had the time to look for what is pointer.
You have the guy in his ear explaining.
What?
Yeah, your programming skills are very.
I can't hear what you're saying. Why don't you type it in the chat or something? Because I have no idea what you just asked me.
Yes, because you're gonna search and look it up.
I've got a website called Cowboy Programming. It's cowboyprogramming.com, and I've got loads of articles I've written in there about programming, and they're all really complicated and technical. So if you doubt my programming abilities,
don't make it real, bro.
And if you want, you can go and look at the credits for Tony Hawk's Pro Skater 1, and I'm listed there as the lead programmer.
My God, I could hire a fucking writer to write me a fucking article with a fucking neurosurgeon tomorrow, bro. Doesn't make me a neurosurgeon.
You could go to
You're asking me like, I don't know, high school level questions like, what is a pointer?
Exactly. Exactly. So this should have been like, oh, dude, the pointer is this and that.
No, I know what a pointer is. Like, I started programming it in Z80 or 68K, well, later 68K, and a pointer then was just one of the registers, like one of the address registers in 68K. It's a location of a variable in memory.
Order this now.
Yeah, but where's the
address? You finally looked for the answer, did you?
Yeah, bro. But where's the curve?
I know what it is.
He knows what it is. We know that you're good at programming and manipulating stuff, and you can show it on your simulator, but you're not really, because you can't, list the variables. Like, you're just gonna give us a simulator.
I'm telling you the variables. The variables are they're right there in the simulator. But the temperature gradient would be the one that you'd want for doing an experiment.
Yeah, but where's the curve at though, bro?
How come water is always flat in video games?
It's just the easiest way of programming it.
Or is it because
would be way more complicated?
Yeah, because
it's because it's the easiest way of programming.
It would be a little weird if you programmed it with curve, right? Because
it would be complicated. It would be hard to do.
It would be pointless.
Not real.
Yeah, if you want it to look like it does in real life, when you look at the water.
It is actually programmed with curve in things like Microsoft Flight Simulator or X-Plane.
How does it find its own level?
I've been tracking the
simulator, it's not what you think
with a lump in the middle.
It's like saying, how does a pendulum find its own level?
No, it's not. It's like asking how does a fluid find its equilibrium. That's what they do.
Because if it's in disequilibrium, then it moves towards equilibrium. That's just
it doesn't have a big lump in the middle, does it? I think that's what it means.
It doesn't have a big lump in the middle. It's a sphere.
Water curve? How does a body of water at rest curve?
By being attracted towards the center of the Earth by gravity.
Gravity. Here we go.
Gravity.
So how come gravity? So how come no scientists can demonstrate gravity and replicate it?
I've heard that word.
You can demonstrate the effects of gravity.
Sure, no, but they can't. They can't demonstrate what they're actually claiming. It only works at a planetary level.
Excuse me, Hollywood. We really wanted to give Most Mad the opportunity to ask a question as well. We seem to be veering off again.
I have to be going soon anyway. So
next up.
Can I have one question?
If Matt doesn't want to go ahead.
Are you familiar with that?
Sorry, he must be AFK.
Let's give Mick a little breathing room. How are you doing, Mick? You all right?
I'm fine. This is all fascinating stuff.
Yeah, it's all. Yeah. Okay, good. Professional.
I understand that people are passionate about their beliefs and they get angry sometimes. Not a problem.
Who's getting angry?
All right, next.
I heard a few raised voices.
Get angry?
Cool as a cucumber.
Yeah.
There's some people who just yell all the time, so it doesn't necessarily mean they're angry either.
I just don't like liars when I figure them out.
I'm angry.
Oh yeah, I'm angry.
Does someone have a question?
Once I figured out this thing was a lie, I'm furious. So anybody that comes in here, they better have their shit correct.
Waterball, go ahead and ask your question.
Hey, sorry, I was my phone got frozen.
There he is. You good? If you got a question, go ahead, man.
Yeah, are you familiar with the heliocentric?
All right, go ahead, James.
I have a question, if that's okay.
James. Hang on a minute. No, James is going.
Mad philosopher, please. Mad philosopher, please.
All right, so Mick, you're obviously aware of everything that happened post 9/11, correct?
I wouldn't say everything, but I'm familiar with things. Yes.
Right. Sorry, I guess I should have reworded that question. Everything, like the wars that have been fought since then.
Yeah.
Since we invaded Iraq, Afghanistan, Libya, Syria, all of them.
Against it.
Right. Well, I'm asking. So, do you know what those countries were doing prior to 9/11?
They were just sat there with a bunch of oil.
Right. No, that's not actually correct. That's not all they were doing. Each one of these specific countries, the ones that have been invaded post 9/11, all back their money all of those countries backed their money in gold and silver, and denied central banking in their country. It denied backing their money with the U.S. dollar. Since then, every country that we've invaded, Iraq, Afghanistan, Syria, Libya, all.
Someone cut out the.
He broke up.
Hey, James, we lost you.
Oh, sorry. Since then, all of these countries have backed their money in gold and silver, in U.S. dollars. They no longer back their money in gold and silver, and each one of them have incorporated Rothschild central banking. So, I guess my question to you is, how the fuck can you turn a blind eye to all of this shit and not see how evil the Federal Reserve and these Freemasons, the Rothschilds, all of them are, and you just go to all of these conspiracies trying to debunk them instead of seeing all of the evidence right in front of your face?
Good question, and I'd be happy to answer it. I think the reason I don't turn a blind eye to it. In fact, I think that things like that, the corruption that's endemic in the American system and their foreign policy, is something that we really need to look at. I mean, I might not agree with all the exact details of that link.
What do you think about it? Don't say we need to look at. Sounds like a political statement. What do you think about it?
You're asking, like, why do I debunk? The reason I debunk is that I think people need to focus on things that are real. I don't think the flat Earth is real, and I think people spending all their time. I know
you need to focus on things that are real, but you keep reifying things that are not actually.
Yeah,
real.
wait, this is
doing that.
Because what I see myself doing is I'm kind of like a force multiplier, for want of a better word. If I can actually help a lot of people not spend their time on nonsense,
well, then
they'll be spending their time on real news.
Wait, hold on.
Who are you to dictate what is nonsense and what is not?
Yeah, what's related?
The genius of the group.
This is related.
Obviously, it's what I personally decide to focus on.
Are you,
for example, like the flat Earth?
Save us.
Hold on. Do you not see this world,
my friend? Are you the intellectual that can save us?
Hold on, let
Megabon,
finish.
I'm trying to help.
Help who?
So then, do you not see this world organization, this world secret society or world government trying to establish itself? Do you not see that?
I don't think there's a single organization. I think there's lots of people with their own self-interests. There's lots and lots of corruption. There's lots of powerful people who are doing things for themselves.
Cool. Under one banner. They're all doing a bunch of things under one banner. Do you not? I'm asking you, do you not see that?
You think the Chinese are all doing the same thing? You think the Russians and the Japanese are all doing that?
Yes.
Yeah, bro. This guy just doesn't have the balls to wake up, bro. Fuck it.
Have you looked at the Forbes list of billionaires?
Forbes.
Dude, that everyone that has trillions in private.
I thought you were busy with important things, not Forbes.
Well, so look at them. Look at the variety of people that are billionaires. There's over 1,000 people in the world who are billionaires, and they're very, very different people.
Publicly billionaires.
Well, yeah, but that's all we have to go with, isn't it? So if you're just imagining things, that's just something I can't really comment on.
It's not
but what we actually see is that people who are in power are very variable. There's lots of very, very different people, and they all have their own interests at heart. So there's obviously a lot of corruption. There's a lot of problems, and that's what we should be focusing on.
All right. So wait, real quick. This is related to Most Mad's military kind of thing that he's talking about. So when we went into Iraq under the presumption of weapons of mass destruction, what's your opinion on that? Because you're like debunking stuff. So like at some level, so like what's your opinion on all the weapons of mass destruction?
I think that they basically made up a case for going into Iraq, and that they essentially lied about the weapons of mass destruction by just exaggerating evidence that really wasn't there, like the stuff about Colin Powell said about the labs really wasn't. So
why can't you imagine them doing this at a different scale, a different subject? Why can't you imagine them lying to you? I can imagine them doing it about other things, dude.
Was that a conspiracy though? Was there weapons of mass destruction? Was that a conspiracy?
People, I think, conspired to, modify the evidence to make it seem like there were weapons of mass destruction. Yeah.
But the whole Iraq thing started with a secret conspiracy. You know that, right? The Sykes-Picot Agreement.
I'm not familiar with
the whole geopolitics. The Sykes-Picot Agreement was a secret agreement with France, Great Britain.
It's secret. How do you know about it?
What was the Ottoman Empire decided that they were gonna divvy up Iraq. This happened in the 20s, right? So this
makes sense. I mean, they were doing that type of thing back then.
Yeah, so the current Iraq war is a base. That is the basis of the entire war.
The Middle East is completely fucked by the
all that stuff.
The colonial system basically just messed up Africa and the Middle East. So it's
but that was a real conspiracy. That was a real conspiracy. I mean, you can Google it's called the Sykes-Picot Agreement.
I mean, there's lots of real conspiracies.
Oh, I'm just glad you admit it because you believe in a conspiracy theory.
Yeah,
you believe in 9/11 was a conspiracy among
I wrote a book.
19 hijackers. It was a conspiracy of 19 hijackers, right?
Well, more than just 19 hijackers. There would have been a lot of other people. There's like who financed it. Then there was the organizational things. So yeah, there was a lot of people involved. So the conspiracy.
Well, I'm just saying the official story is a conspiracy theory.
Yeah,
is my point.
Yes, I'm not sure.
Calling other theories a conspiracy theory is just saying just a different conspiracy.
There's a difference between a conspiracy and a conspiracy theory. I mean, a conspiracy theory is just essentially, in the scientific sense, a hypothesis. If you want to get scientific,
I believe in the lone wolf theory of 9/11, like Lee Harvey Oswald. Like there was just one person flying all 3 airplanes.
That's just silly.
I mean, I know it's silly. That's the point.
So why are you saying that?
Because when the government says it's a conspiracy, people believe it. When they say it's not a conspiracy and it's just some lone nutter, they believe that too. Like, you just believe anything that comes across the television set.
I didn't believe the weapons of mass destruction thing.
Well, it came across the television set that it was a big lie. But
I didn't believe it.
If the New York Times didn't out that, then everybody would just believe there were weapons of mass destruction.
Well, you're going to go to Iraq and find them for yourself?
Well, they could just put them there.
You can actually
find them.
You can measure the curve of the Earth yourself. It's hard to do things in geopolitics for yourself.
May I just ask a question? May I ask a question quick? This has come from one of my friends that's just messaged me. What's your opinion on Jeffrey Epstein? Did he kill himself? I mean, considering we're talking about conspiracies. Just a quick one.
I think he probably killed himself.
You sure he's dead?
Good. Yeah,
he might have been allowed to kill himself, and that's about as far as I would go in terms of conspiracy there. But I don't think he was murdered by someone coming into the cell and strangling him.
And what about what about his overall setup?
I think he was a bit of a perv.
The broken hyoid bone.
That broken hyoid bones happened quite commonly in older people with suicide strangulation because it gets more brittle with age.
Well, I've seen
I got a message
forensic pathologists with a total of 50,000 autopsies between them say they've never seen it in a suicide.
I don't know, but I've looked at a bunch of
unless it's a height, you know what I mean, like 16 feet, something like that. Not the 4-foot bunk.
There's been scientific studies that predate this by decades that show that the hyoid bone is commonly fractured in suicides, just by regular, hanging from a bunk bed type suicides.
Well, thank you for your time, Nick. Thank you for answering.
Cool. Can I have my short question?
I should also say the hyoid bone wasn't the only bone that was broken.
Well, I'm not familiar with anything other than that right now. I could look it up, but
there was three. The hyoid bone was fractured, and the vertebrae underneath that had 2 fractures, and the cartilage had lateral tears in it.
The people who actually performed the autopsy say that it was consistent with the suicide. Now, the Epstein family hired another pathologist who attended the autopsy, and he is saying that he thinks that it might have been a murder.
Where's the video?
Yeah, Michael Baden.
Footage?
Conflicting opinions.
Real.
Any what?
So the independent one is saying it might have been a murder, but the one that's got paid by the government decides to say, yeah, it was.
No, the one who is paid by the family is the one who is saying there's something suspicious. The family have already said that they think that there's something suspicious going on. So they're paying a pathologist, and he's giving them an answer that conforms to their suspicions. Now, does that mean that they've influenced his opinion? Are they going to fire him and get someone else if he doesn't give them what they want? Who knows?
Well, Cyril White, who's a famous forensic pathologist, saw the autopsy report, and he says that it's more consistent with murder than suicide.
Well, perhaps you should do a survey of all the different pathologists. But
well, yeah, that's why when something like this happens, you have a coroner's inquest, right? And then you get a jury of people to judge the evidence to determine whether it's a murder or suicide. That's what we used to do in this country. Well, we'll see if it happens, because I seriously doubt it.
It seems like the family is kind of heading in that direction, but I don't think they would win such a case because they don't really have the evidence to back that up.
Well, it's not really winning. It's getting people to look at the evidence. I mean, from one perspective, I guess, but it's not really a win. That dude's still dead, suicide or murder.
Yeah, but then they can sue the government and bring down people in power, which would be pretty impressive.
Why was the photo of his body not him? It was somebody else's body.
No, it was him.
Yeah,
so
but
the photos look very different in different situations.
Why did you recognize any birthmarks?
You're comparing it to photos from 10 years earlier, and also he's dead.
His left ear was showing. You can compare it. You can compare it to his left ear.
The blood flows down to the lowest point of their body. It's called lividity, I think, because you get all this pooling and purpleness.
How do you
when someone lies on the side,
without even questioning it?
I'm questioning.
You're not even open. You're not even open-minded. You never thought about it. You just automatically. You're like.
Well, no. The reason it seems like I'm not thinking about it is that I've spent an awful lot of time already thinking about it.
That's pretty weird.
Like I was on.
Is your default position to support the official story? Is that your default position?
No, it's not. My default position is to go with whatever I think is best supported by the evidence.
I don't think you've actually seen the evidence. You haven't seen it.
Yeah, but what I have seen is it doesn't really suggest murder to me. There's things like the cameras being switched off or the guards sleeping on the job and things like that. Yeah, you can say that's very suspicious, but that's just something that's been happening constantly at that particular prison for the last 5-10 years or so, because they're grossly understaffed. It's a federal prison, and the federal prison budget has been cut, and they've got more prisoners there than they should have. All the prisoners.
Okay, well, name one instance. Name one instance where a person has committed suicide like that, and everything has been, all the cameras from that location has been.
That prison has only had about 3 suicides in the last 30 years, and I think a very small number of actual suicide attempts. So
okay, he wasn't just any normal prisoner, was he? He was an extremely high-profile prisoner. This was an extremely rare case. So I get what you're saying if it was just another bloke coming through the prison system, but it was not. So, I mean, that's why what happened is highly suspicious.
I can certainly see that, yeah. And I think with hindsight, he should have been put on some kind of more full-time suicide watch. But then what if those guys
fall asleep? But what if those guys?
He was essentially. If he was put on a proper suicide watch, they've actually got much more rigorous checks and balances.
Yeah, but then those guys can fall asleep.
Plus, I say the doctors fall asleep.
Any guards can fall asleep.
You're making hypotheticals.
We got 3 theories.
Before he got moved into the cell where he committed suicide, someone did try to strangle.
We got conspiracy theory, coincidence theory, and incompetence theory.
So someone
You're going with the incompetence theory.
Supposedly,
I am going with the incompetence theory. Historically speaking, incompetence happens.
It's hard to make an argument against the federal employee not being incompetent.
Federal prison, and it was very underfunded.
Okay, look, basically, the end result is here. If Jeffrey Epstein went into a court trial, they had evidence and would have subpoenaed, or at least tried to subpoena, Prince Andrew, who was one of the main people involved in this situation. So whether Epstein killed himself, was killed, or was relocated, that's the reason that he's gone now. He couldn't go into the courtroom. It would have opened up too much information on Prince Andrew.
Possibly, quite possibly.
It's not quite possible. The main woman testifying in this trial is the lady that's living in Australia. She was the one that was in the first initial case that was actually abused by Jeffrey Epstein on his yacht. And they've got the photographs of her with Epstein and Giselle Maxwell, or whatever her name was, the co-accused or the co-charged in this case. I mean, it's blatantly obvious why he had to go.
Okay, well, I really have nothing more to add on that. I think he probably killed himself. Maybe he was allowed to kill himself. I think it's unlikely that he was murdered, and that's
Wait, how did he kill himself? With what?
He hung himself with, I believe, a blanket. Or
and you know how thin those blankets are. Tissue paper, dude. There was nothing to kill himself with, but you think he killed himself.
No, he was in a standard cell at that time.
Yeah, no. There was nothing. No, he wasn't in a standard cell. No, there was nothing.
They said he tore the blankets into pieces and made a rope.
Yeah.
So he weaved himself a rope in the cell with the cameras off.
You could actually a rope of tissue. Okay,
you could do that actually.
Okay, cool.
Nick,
but I don't know.
Have you ever stepped a foot inside of a prison?
Well, only in tours and things like that, like Alcatraz and Folsom Prison.
No.
But I've never been arrested or anything like that. Spent time in jail.
A fully functioning prison. Have you ever been in one? Okay, so the blankets in prisons, they are fucking thin. It would not be able to support Jeffrey Epstein's weight.
People kill themselves all the time with those blankets.
You just braid it up a little bit with a few things. Yeah, obviously people kill themselves in prisons. And they do it by hanging.
But here's the story though. We're talking about the McWest. We're talking about the official story, bro. Okay, so he hung himself with his sheets. Okay, now I'm telling you that those sheets are tissues. Okay, but you say that that's fine. You can hang yourself with tissues. Now, can you demonstrate this?
I'm saying that he hung himself with the sheets, so I don't know how he did it.
And I'm telling you that the sheets are tissues, okay? And you think that people can hang themselves with tissues.
Okay, hold up.
I'd have to.
Hold up.
I'd have to see the actual sheets.
Is it possible that he was told, can you threaten a man like that? Hey, end your life, or we're gonna do this to whatever, your family, or.
Possibly,
is it
but
possible?
I think he knew what was coming down the line and he decided to kill himself.
So when are you going to decide to kill yourself?
Hey, Hollywood, chill out, man.
What if they do that to Mick and he's going to do that? I don't know. What if that's that's how they? I don't know, man. I'm just possibility. I've already told people.
They do it to me.
I've already told people if I get suicided, don't believe it. I've already told people if you get a letter with my fucking handwriting or something, don't believe it. I've already said that. So it's possible to anyone, dude.
I got a flat Earth challenge.
I'm still interested about aliens, though.
What we ought to do is do 200 proofs in 200 hours, and every hour on the hour for the next 200 hours, pull up the 200 proofs and debate them. One by one, each one gets an hour's debate.
Well, any other conspiracies or theories?
Yeah, I really have to go, so if you got any last questions, then speak now.
I have a question.
Thanks.
If that's okay.
Thanks for your time. Yeah.
My question would be, what do you think people's criteria for evidence should be? So when you see a claim and some substance presented for that claim, how should people look at that substance and decide whether it holds grounds?
Well, good evidence is evidence that's verifiable and testable. So if you can verify, repeatable, testable, verifiable. It's the three criteria of evidence. But verifiable is probably the most important one. But then if you got reproducible, that kind of verifies it naturally. So things like, I don't want to get into a big argument again, but like the observations of Catalina is evidence that is verifiable and repeatable, and you can test it. You can do things like change the where you view Catalina from, and you can go to Catalina and measure it. No, it's not every day because the weather is sometimes quite often actually you can't see it, but on a clear day it's visible with the naked eye. So yeah, if it's those things, verifiable, repeatable, testable.
Mm-hmm. All right, thank you.
Anything else?
Thanks for coming by. I just want to get that out there. Right. Thanks a lot. We appreciate it.
Yeah, thanks. Step by again.
Maybe some other time. And yeah, if there's anybody who wants to have a more extended one-on-one discussion about this type of thing, I do have a podcast, and I would like to talk to people, like more varied people than I have been talking to. So if someone was interested in being on my podcast, maybe have a quick look at it. It's called Tales from the Rabbit Hole. TFTRH. Yeah, and just send me an email if you would like to be on there.
The inverse is also
just say rabbit hole.
We've got one of our members here, Dr. Science. He does Flat Earth Initiative and Friday Night Fights. So it's a more structured sort of debate. So that also might be.
It doesn't have to be a debate.
No. I know. I'm just saying it's a more structured format where
it's actually kind of a chat. Really, I like talking to people about where they're coming from and why they believe what they believe, and how their opinions change over time. Yeah, things like
I have a question for you. Have you ever thought of going to SLAC up in Menlo Park and going into the Stanford Linear Accelerator and look at that structure, which is probably the flattest structure in the universe, I would say. And you could do some tests in there, kind of go from the reverse angle. Now you have something you know is flat, and see if it then comports with the reality of curve or straight.
Well, I mean, if you know it's flat, then it would be flat. So I'm not sure what test you could do.
You get the plumb line at the ends that won't be, right?
Well, at each end it would be the same. Well, no, they wouldn't be. They would diverge from each other. But you could do that on the surface.
Be parallel, wouldn't they?
Right, and then the other thing
they would
one way.
But you don't need to have a flat surface to do that. You just need two lines that are some distance apart. But the problem is, how do you measure this angle? Which you can actually do. You can do it with good surveying equipment on buildings. You can see that
just measure the water level. Just measure the curve in water level. It'd be easy.
That's a good point. Let's do that. Wallace experiment.
It's the same inclination that you'd have for the Nile River, right? We're talking about 8 inches, every 8 inches every.
Inclination for a river. Well, that's what rivers do, isn't it? That's what water does.
Downhill.
It finds its own level, doesn't it? It keeps going until it.
No, it doesn't find its own level, actually.
It actually flows down to the ocean, Zanuck.
It finds stability.
The inclination is the same as that building.
It's called sea level. Have you ever heard of it?
Yeah, and the sea level is curved all the way around here.
It's not. Level's horizontal.
Dude, how can water be curved? How can water be curved?
Okay, relax. Let's fight the flat Earth.
Nick, the other question.
I'm going.
The other question. So there?
All right,
I'm going now.
See you later.
All right, Mick.
Nice try, though.
Zanuck, be quiet. Zanuck, he says one.
Last question.
Nick's trying to leave. Come on,
the last question. You guys have had the whole 2 hours.
Last question. Go for it.
Well, I haven't said anything personally.
Yeah, but we have a little relationship, Nick. We actually worked on your curve calculator and added one little bug on it. Remember that a while back?
There's a few people who did that, but
anyway,
thank you.
what about looking at mountains? We're looking upward, getting away from the water refraction. Again, I like getting away from this refraction element and look at the angle of those peaks versus the horizontal to see if that comports with reality as well, or what they should be for how high they are and how far they are away.
You can do that. It does require a little bit of bit more math, for want of a better word, working out the angles and things. There's some very good examples though. I think like the twin sisters or the three sisters. What was it called? In Oregon.
Yep.
Mount Hood.
Mount Baldy, and then what's the other one over there?
Yeah, there's. I'll just post the link.
11,000 feet, and then you're at sea level at some point, looking up at that mountain, saying, "Okay, does that have the right angle for how far?"
It's actually the best thing is to be on the top of a mountain, looking across the tops of other mountains at distant mountains. And I posted a link of that type of thing.
Right.
But it's essentially a very large-scale version of the Wallace experiment. But you do have to kind of accept what the height of the mountains actually are,
right?
Which not everyone can accept, because it's all based on numbers.
That's a great picture, by the way. Yeah, a lot of people here actually accept the altitude indicators and the air density measurements.
They just did the world. They just did the world record.
I don't.
326.
I don't.
Who are you talking for? A lot of people.
I accept measurements of altitude. I don't accept the model.
So when you basically in a helicopter and the altimeter says 1,000 feet, you don't think it's correct?
I believe there's an error within a certain range.
All right, so I think I've answered that question. But
What's going on?
Pineapple.
Put something on the bot. Yeah, what do you fancy? Send me a link to put on. Will do. What's it doing?
Could you play it from a timestamp? See if that'll work.
Could try it. It doesn't normally work though, or from certain times. Yeah, we'll try it though.
Confidence in the things that I know. I have enough wisdom to see the logic will be shown. I got one chance, showing you what I got. I got one chance, show I'm confident or not. Self-evident reason, deductions and conclusions, and the fools are running away. It's not what you say, it's only what you can prove. You better watch your step, you better mind your P's and Q's. You got one chance, show me what you got. You got one chance, show you confident or not. Don't get caught in the matrix of all of these fakers. Society spinning, and I'm just here living on the ground. decisions and conclusions, logical rethinking, and the fools are running away. You're flipping over backwards to show me where you think you are. Your model dictates that you never see too far. Shrinking in the distance, you can do fuck all with an angle, and the fools are running away.
And we are live. Welcome, everybody. It's Free for All Fridays. So we've got a fair few people in, but well, it's free for all. So, anybody want to talk about anything?
Yes, me.
Well,
me.
Oh, go on then.
Me. It's Bev's birthday today, everybody.
Happy birthday.
It's really embarrassing.
I'm trying to get away from it. All right.
Let's sing him a song.
No.
Not tonight.
We've already had that today. It was cool. Skeptic came in and he actually got a cake to me, and he's eating it right now. He's him and his family. That was quite good, that earlier. Yeah, thanks everyone. 1 year older.
Actually, it's just your delivery day, Bev. Your actually birth date was the day of conception.
Way to complicate things, John.
I wouldn't know that, John. That's not one of the things you normally ask, is it?
Yeah, go figure that out.
You deny your connection to God if you claim your birth date as the date of coming out of the womb. You're alive for 9 months in there. So it's just your delivery date. I'm not trying to ruin your birthday, Bev. I wish you the best. You know that. Just tell Kevin to shut up.
You can do that. You're allowed to do that on Friday, John.
How you doing, Kevin?
Good, man.
Good.
Yeah, Kev's asking me to turn on Super Chats. No. But I might do soon. You never know. Hopefully not.
Super chats are hardly worth it because YouTube takes most of it anyway. And it's giving them revenue, which is just like, no.
So, it's been a pretty eventful week, I'd say. And it's still not finished. The FE Dogma Twin Tangent saga is still going on. Blue Marble's trying to work out how to make it even more simple for us to understand, even though there's about 8 different versions of how people deal with putting 2 tangents on. Some of the latest ones are quite hilarious. And I did just get another message from Blue, so I will just I'll get that and put it in the chat. So
how many tangents are on your birthday cake, Bev?
I don't. I've got like a wheat allergy or something, so I can't actually eat any cake.
No, I'm just talking. I was wondering how many tangents are on that birthday cake. But I'm sure you don't want to say.
Oh, toothpick tangents. I suppose you could. I suppose you could. Seeing it's his birthday, you could make them candle tangents.
The candles, you know, the tangents.
Candle tangents. 51.
Yeah, you did miss that, John. I mean, Skeptical did come in and he baked a cake. He baked a cake for Bev, but him and his family ate it. And the cake was geometrically approved.
Yeah.
Oh, okay.
Yeah. The candles made a triangle with only 180 degrees. I mean, I don't know how Skeptical would have done otherwise, but you know, he did a good job there. And I think the cake itself was square. I think there were 490 degrees. on the cake.
That's great. I'm sorry.
Yeah, it was good. No, it was really good.
Yeah, I was impressed with that. Thank you very much, Skeptical.
You deserve it, Beth.
Yeah. Right, let me get this latest Blue Marble, because they're writing essays to me. I don't know whether you can read that.
We don't actually have to listen to his voice, though, do we?
Well, I don't know, unless we've got Redman.
Read it, Redman. Read it.
One wrong move, and you'll be banned up out of here. I'm driving.
Yeah. Right, so Blue Marble says at the beginning, Blue Marble Science, sorry, I can't, not just Blue Marble, but Blue Marble Science. We are going to do a thing about people with science in their name. There seems to be something really strange about them. It's like they're trying to make up for something by putting science in the name. But Blue Marble Science has been commenting about the twin tangent challenge of FE Dogma. And he said, after the plethora of explanations provided by dozens of people, which are all individually different solutions, because obviously you can't have two tangents on one line, they still refuse to grasp the simple idea, instead opt to ridicule normal intelligence. He thinks globe geometry is normal intelligence, as somehow being absurdly wrong. I would really like to know what motivates anyone to display this level of sheer ignorance, as it were an accomplishment of some sort, right? So he's talking about ignorance of the globe geometry. Well, yeah, nobody's explaining it. They just keep saying, we don't understand normal geometry. So I say, did you not find it strange that you all have different solutions to FE Dogma's LIGO twin tangent on a horizontal challenge? The new globe geometry being invented is amazing, isn't it? Will the comedy start soon? That's me asking them, because they're all saying they're laughing and whatnot. 2, I've never read this before. Blue Marble Science says, that's just a lie. That's not what FE Dogma did. What I find strange is the fact that none of us can figure out a way to dumb this down far enough to allow you to grasp it. Pitiful, to be honest. It is pitiful of the globe side that they can't manage to simplify a very simple thing to make it understandable to anyone. I can't understand it, and I'm pretty sure everybody around here can't understand what the globe geometry is going on about at the minute. He says, I know one thing for certain. The education system has clearly failed. That's good. At least he knows it, right? We know you're a flat waterer. MSL if you like that better than earther. Mean sea leveler? Mean sea... He's wrote that. Because he has to do something. It's definitely not flat water. That's ridiculous, Blue. If you like that better than earther. Just call me Bev. I'll be fine. What? But it's a shame that your planar geometry affliction doesn't allow you to at least try to understand how spheres and tangents work. It's horribly simple basic stuff. The comedy has already begun, by the way. Everyone watching this is having a great laugh. At your expense, I might add. Well, if that's makes me the comedian, I'll be happily obliging. I'll take this show on the road, Blue, if you want me to. Maybe try listening instead of try thinking. The thinking part isn't helping you.
That's just an attempt to get you emotionally, Bev, those words.
Yeah. Yeah, do you think it'll work?
No.
I'm liking my comedy routine. I really am. going to take it on the road. And also, because of Blue, he says the thinking part isn't helping you. We were talking about this the other day. I'm thinking of opening up the Try Thinking College of Thought here on YouTube for anybody that wants to join. Just got to come and have a chat. Maybe try thinking a bit. And we'll go over this stuff with the tangents. But, I mean, I don't want to go over it. I can easily go over it with anybody, the tangents. I mean, it should be simple enough. You can't have two tangents on one line. Especially if it's a horizontal line. Or any straight line. So what's everyone think of that? I've got some more as well. They've been on at us all day. Really. Who's this one? This is Hex. Hexaglobular. Everybody knows Hex. Sounds like a little bit like Kermit the Frog. And he's given us some absolutely wicked Globe Dictates videos. So Hex says, Bev goes out strong in the first 5 minutes, displaying his model affliction and inability to understand simple concepts. You absolutely can have a line with two tangent points on it. Now this is model affliction, because he's just trying to sort out an answer. So he says you can have a line with two tangent points on it. Take a circle. Draw two lines tangent to the circle. That gives you two tangent points. Now, draw a third line between the two tangent points. Hey presto, you now have a line with two tangent points on it. Or more commonly known as a chord. So Hex is Hex is having two tangent points by drawing a chord. And then he says, right? Genius. He says, of course, that line isn't itself a tangent to the circle at either point or at all. But both tangent points are on that line. That's the same distinction that Bev fails / refuses to make regarding FE Dogma's video. See, it's all about FE Dogma's video. He's drawn a straight line, A to B, and he's put a tangent point at A and a tangent point at B. And then he's labelled the line, horizontal line. Inventive, though. I mean, like, if anybody isn't quite getting this, this is the most inventive the Globe Gang have ever been. They've always had everything dictated to them. But for this, they can't go to a textbook. Because there is just no geometry to deal with this. FE Dogma's obviously just made a mistake, but he can't back down. He has to still be correct about it, and this is where we're going. So he says, that's the same distinction that Bev Fails refuses to make regarding FE Dogma's video. In it, line AB is a tangent at point A, but at point B, it's just passing through or stopping without being tangential to anything. So it's not tangential to anything at B. An added complication is that two lines aren't even tangents to the same curve. That's an added complication for who? Probably for X and the Globe Gang. An added complication is that the two lines aren't even tangents to the same curve. AB is a tangent to the 529-foot elevation curve. BC is a tangent to the 533-foot elevation curve. Brackets. I think it was. This is where the comedy starts, Blue, if you didn't know. The comedy starts when the Globers have to start redefining tangents. We've already had toothpick tangents. We've had extensions of radius circles enveloping the old tangent to make a new tangent. We've had drawing chords to develop two tangent points at the end of it. What else is there? Where else can they go? I don't know.
You forgot a tangent to there, Bev.
What he's trying to do here as well. Sorry, go on. Go on.
I say you forgot Jose's tangent to the ashtray, tangent to his globe. Go ahead.
You can have tangents anyway, yeah. Hey, that was Jose. But what he's done is he's got a tangent at an elevation point. And that's all they are. They're just points. The elevation points. They're the point where that elevation was taken. And it's just the height.
I think that he didn't realize that tangent point is where a line is touching, not intersecting a circle. Only touching, but not intersecting. So this is the only way how we describe tangent line. Because if we intersect this line, this is no longer tangent point.
Yeah, I think the mistake's been made by the Globe Gang. In the 2 years, 3 years, 4 years, I think we were saying today, 4 years since we've been here, they've just dealt with the geometry that we deal with by saying we don't understand it. Now it comes about that FE Dogmas set them a challenge. They don't know what to do. They are literally making shit up. But I don't want to stop them because this is what the Globe model does. This is where the Globe model gets most inventive at these times, because all of the Globe Gang that's around here, individuals of the Globe Gang, all imagine that they know what the Globe needs from this. So this is where globe geometry is going to be made. And it's got to happen. It has to happen. And we've been watching a few just recently. People go over the edge. I don't know whether I've got any more of these comments. They've been quite interesting today. And here's another one. That's doofus. Point B is tangent point for the line BC. Also a tangent point for the line AB. See this? That's FE Dogmas. That's the FE Dogma defense. Just draw a circle on the side of it. Extend the radius out through AB. Let me see if I can find that.
On this picture, we have one line, which is tangent line, and the second, AB, is not tangent line. Sorry.
But it is that I'm calling this one. There you go. Look, it's pretty much exactly the same. the FE dogma defense to his own challenge, the twin tangent. He hasn't said where he's going to put the tangent at A yet, though. In that,
it doesn't matter how they describe this. On that picture, last picture, line BC is tangent, and line AB is not tangent. Simple.
It's just an extension of the radius, isn't it?
Yes, it cannot be because it is intersecting. So, and any extension will intersect. But at line BC, you can extend this line how long you want, and it still be tangent on line because it will not intersect.
Yeah, that radius and the line AB would be perpendicular to the line BC.
Yes.
As a true tangent is, always. But yeah, that is, so in these particular defenses that they've got, the FE dogma defense is just drawing a circle on the side. Whereas Wally and Rumpus, I think, are going for the toothpick tangent, the extension of the radius of the original circle. That's what Hex was saying. Hex said here, the line isn't tangent to the circle at either point.
So we will end with Wally's film, short film.
Yeah. Yeah, so in the initial one that Hex says, he says you could just draw two tangent lines and then draw a line in between them, right? That's the third way, I think. But then he does go on and say that they're not even tangents to the same curve. So that goes against this circle that he has here with two tangent points. So Hex seems really confused. He's got two competing ideas in his own head.
Yes, and he needs two tangent lines. Mm-hmm. And he, as I remember, he just wrote it that he is drawing one tangent line and then at the second point, second tangent line, and then he is making this chord line.
Yeah. Yeah, but then later on down here, he says an added complication is that the two lines aren't even tangents to the same curve. So he did put circle here, but he seems to go against that here. So I'm sorry, Hex. That's not allowed. That's absolutely ridiculous. But I mean, it is a different one. Throwing them out there for the globe model guys to have a go at. So we're up for that. So there's three different methods. Toothpick tangent, the FE dogma defense, just draw a circle on the side of it. Just draw a circle wherever you want a tangent to be. That's what Ruhif does as well. Ruhif says infinite tangents along that line. You could just roll a ball on it. Hex is in the chat there. He says, I'm not the one who's confused. I'm giving two examples and Bev is conflating them. Yeah, two completely different examples, Hex.
Examples of how to, I don't know, be dumb. I don't know.
Globfuscate,
yeah.
Yeah, because this is LIGO. This is a line, a straight line. That's it. How can you have two different solutions? One involving a circle and two tangents, and another one involving two different curves.
I wish we had a little drum sound bite where you could do, say, misplaced concretedness.
Sheer fantasy.
They will get more inventive, though, hopefully, because they have to. I mean, it does seem ridiculous to everyone, and their best defense is just saying you don't understand, which we have already predicted. And I have experienced the you don't understand a fair bit, and they're right. I only understand geometric proofs that say whatever FE Dogma did is impossible in reality.
No question about it.
Mm-hmm. That's the simpleness of it. I mean, I do understand that, and it's very, very obvious. What I don't understand is why there are a group of guys that can't see this. Well, their model affliction is what stops them from seeing it, and the fact that it's a paralogism.
Good afternoon.
Hey, Rob.
Can I just say something real quick about that? When they say we don't understand, that's all they say. They don't actually elaborate and help us to understand, because they know that we do understand. They're just saying that to make us think we don't understand. But we clearly do.
No, what it is they have their own model. They've all made their own globe model, right? Which isn't based on anything in reality. So when they come up with their solution, it's for their particular model. Now, they cannot explain it to somebody else because somebody else has a different model and they're going to do it to them. So it's much easier to come over here and tell us we don't understand than try and explain it to one of their globe friends. Because they are definitely not getting together as globe team and working a way out around this. Because they would come to the conclusion that FE Dogma shouldn't have drawn it as he did. Because that's like a reality drawing where he just draws tangents and it's obvious that that's what he's doing. FE Dogma should come for a chat. And then he can explain to everybody that he's just drawing circles wherever he wants. Because that's where it is. It's all in the meme. It's all in the words. You've just got to say globe and push this stuff out there. And it'll have to fit on the globe. Well, with geometry, it just doesn't. It's provably doesn't. Definitely not doing Euclidean geometry. Go on.
I was just going to say, I wonder if he knows that we have a song, shout out Buster, You Don't Understand.
I think so.
That's how many times we've heard that, my friend. There's a song about it. But trust me, we do understand. Sometimes we understand your model better than you.
All of the time we understand the model better than them. Because we can relate it to Euclidean geometry and see where the differences are. They can't. Because they don't even know Euclidean geometry to start off with.
As I remember, back into 2016, all discussions between flat earthers and globe earthers started with a long explanation, and flat earther had to explain in detail to Globers how their model should work and what is impossible on their model, because they didn't understand. So this is very, very old. They don't understand their own model.
It can't be understood.
Of course.
Yeah.
Because this is full of contradiction. You cannot understand contradiction.
Yeah, you can't have a model based on fallacies, contradictions. It just doesn't work. But I mean, that's what they have to. It's what they have to live with in their mind. Contradictions. That's why most of them are diletheists. Blue Marble Science is definitely a diletheist.
Oh yeah.
They all are. I don't know why Blue's talking about differential equations. Just come and talk about the actual geometry, Blue. We know you haven't got any. It's ridiculous to think you can outsmart yourself with fucking calculus when we're just simply talking about straight lines, the logic, the simple logic of it. It's ridiculous. Would you like to come and have a chat, Blue? Would you like to come and have a chat? It is my birthday. Pop on over. Come on over with George. No, George is banned. Bring your team over. Get FE Dogma. I don't know who's the best second in charge. Who is the best globe geometer? Has Blue ever said? Ruhif said Charles. Math.
I don't even think Charles wants to have anything to do with this.
I know. I
don't blame him. Yeah.
Could do with getting FE Dogma though involved in it, because he's caused a bit of a stir. Even Rumpus did the extension of the circle, whereas FE Dogma threw a circle on the side. They're two contradictory results. I get the. Perhaps we should leave this on screen to prove that's where FE Dogma puts the circle on the side. Like Doofus. Jeff Doofus. Almost as though they've all been teaming up together in the background to come up with more ridiculous answers to try and confuse people.
It is confusing when you draw a picture which is not relevant and it is not related to this problem. But some people may think that this drawing is somehow related to the problem. It isn't at all.
You know, Blue, we're not running from anything. We initially said that FE Dogma put two tangents. He put one at point A and one at point B. Well, if you look at this picture here, look what he's done with the point B in order to get two tangents. It's shocking. You've got Wally making, drawing triangles. Well, not drawing, sellotaping set squares on top of yoga balls. And you've got FE Dogma just putting a circle on the side. I said that's shocking. Somebody doing that to poor Wally. You're treating him like the I don't know.
You'd think they'd use their imagination, put another circle on A, no? Try to get away with it like that. But
well,
no.
That's FE Dogma. He's doing that.
Yeah.
Like he left Rumpus. Rumpus did a presentation at Blues where he just drew another circle a bit bigger.
Yeah, over the other circle, yes. Concentric, yeah.
So you've got Wally and you've got Rumpus that are, like, making a tit out of themselves. Blatantly. Showing how much of a sham it is putting two tangents on one straight line. Because what they do is they make two different circles. Well, FE Dogma's just put another circle over here. Completely different.
But they're not creative. They should have taken that one line and put one circle on one side, one on the other. You know, like those old weights.
Yeah.
The balls were stuck on. There you go. You couldn't even think of that. Damn. Of course, it would still be wrong, but, you know.
Let me see. I might be able to do a quick one of those if I... Oh.
Maybe this is their way to make a preponderance of evidence with contradictory evidence.
Well, I think somebody did send a comment to me like that. Blue was saying, look, there's loads of people that have told you that you can have two tangents on one straight line.
Yeah, so they are creating preponderance of the evidence, even if it is contradictory to each other. But I think they can live with that.
Well, I'm guessing so. Oh.
He does have good one-liners, though. I'll give that to Blue. He has a comedic... he can do comedy.
Let's see. Yeah, I've got a... Just sorted it. Oh, come on. There you go. Like that. Do you reckon I see that?
Now you're talking,
That's
bro.
it. That's how you do it.
Now you're talking. There you go. At least be creative in your craziness, man.
That's the FE Dogma defense.
We got to do it for them.
There you go.
I need third at C, please.
No, you can't. You don't need another tangent at C to prove your point. You just need two tangents, one at A and one at B.
There's your double tangent for crying out loud.
That's how you do it.
We got to do it for you. Damn. Even this we got to do for you.
Did say to him at the beginning, you just draw two circles. It's dead easy. Put a tangent like what Ruhif says. Is you can have a tangent, multiple tangents, infinite tangents all the way along. Like he rolling a big circle all the way along there. Everywhere it touches along as it's rolling along is called a tangent point. Just roll a circle. It's dead easy when you've got a straight line. That's right, Blue. Here's another defense for you. Look, of course you can have two tangents on a straight line. Just doesn't fucking fit your model, does it? Doesn't help you.
And if we use it, I want royalties. If you use that one's ours.
No, that's the FE Dogma defense. It'll go down in history, I'm telling you. I hope it will do anyway. FE Dogma, LIGO, twin tangents on a horizontal challenge for the globe model. All you've got to do, in order to keep your model, is justify the 2 tangent points. One at A, one at B. Boom. However you want to do it. As long as you come out of it at the end with a firm belief of your model and the 2 tangents on the same straight line, you're fine. But it's only for the globe truly committed. It's like a final challenge, isn't it? Do you reckon? Is there a stronger challenge? Is there like the geometric challenge for the globe model?
The double roundabout tangent line. It's like a road with 2 roundabouts.
I think it should be. We could do it and sort of set it out as a challenge. You don't need to do with the elevations. They can be researched by the person that's up for the challenge. You just have the horizontal line from A to B and a horizontal line from B to C. Perpendicular. Challenge is tangent point at A and a tangent point at B. Boom, go. How do you do it? FE Dogma's not explained it. He's done some writing in a YouTube comment. But FE Dogma said that you can have 2, yeah? Yeah, I know. We've seen. Hex, yes. You drew a chord. And FE Dogma put a circle on each end. Just drew a circle there. We know. I don't understand why you guys are getting so all feisty about it. So, I don't want to play this twin tangent. It is free for all Friday, so I don't want to be standing in anybody's way. But if anybody wants to come over and explain the how they would try and do it. I mean, if you want to come over and try and imagine you had a globe model, how you would do it to fulfill the FE Dogma twin tangent that LIGO on a horizontal line. You could try drawing it out, get a compass and work out how you do it. See, if it's not possible in Euclidean geometry, but obviously you're not going to be using that with the globe model, are you? We did go over watch a video last night. Here you go. Has anyone heard of Mr. Cheswick? And did you know that Mr. Cheswick had a debate last night?
If you want to,
well,
if you want to call it,
I think he would want to call it that.
Wait a minute. Mr. Cheswick, isn't that the guy that used to make the flat Earth songs that were making fun of flat earthers?
Well, found out at the end.
But he's
he
actually
makes
he's kind of a flat earther.
Well,
yeah, he's been around a long time making music.
Yeah.
Yeah. Once you see the reality of this world, you don't go back to globe science.
Yeah. Don't watch that video page. Do not watch it. Not because it's on Fight the Flat Earth channel, but it's just that if you like Mr. Cheswick for his music, then don't watch the debate.
Or if you're on blood pressure medication, don't watch the debate.
There are some people that just shouldn't debate.
Yeah.
And if you'd like to practice, I think this is where you should come. Not only for knowing which arguments, the good and the bad arguments, but the tactics, the methods, the plays, let's say, all of that, they're all known here. That's where we sort of specialise in the art of the debate. So please, just come and have a chat. That's all we do. We don't debate. We just talk to each other. But there is a lot of experience round here. And Mr. Cheswick, please pop in. That was sad. Really bad. It'd have done better to have watched I Can Science That's video on how to make a better flat earther. Because I think he fell into every one of the traps. It's like it's like he watched I Can Science That and thought, I'll have a go at all of those. Yeah, Hex. Yeah. See, he's put 2 tangent points on the line AB because he's drawn 2 different circles. 2 different curves completely. Yeah, we understand. It's not how a quadratic function works. You can't just restart it. You won't be able to match it up in reality. It means you're fucked. It means you've just unproved your model. Cannot be. You can't just restart a quadratic. Sorry. Numbers do not match up. Cannot be done. You cannot have 2 tangents on one line and get the mathematics to fit. That's why everybody's struggling on the globe model. Proved wrong. Which is the oh, nice guy, Jeff. Nice. Which is the line? Where's AB? He's done D. Can everyone see that?
Yes, I can see. It doesn't make any sense. Straight lines.
I was just going to say what paper said.
He's trying to give us the D.
Yeah.
Wait, where did D come from?
From the sky.
You got it wrong, SC.
The A is the center of the circle, is it?
Put me straight, Redman.
It's all of the above. That's the D.
The points are B, C, and D. There you go. We're talking about A, B, C on LIGO with a horizontal line and a tangent at A and a tangent at B. Woohoo! Like, where does B, C, and D come into it? At least label this one B, C, and D, then we know what the fuck's going on. Wow. Would you like to stop tossing out strawmen and red herrings and talk about LIGO elevations and why they aren't collinear on a flat MSL line? No, we're talking about A to B, a horizontal line, which I don't think has ever been addressed by anybody yet on the globe side. The fact that he has put a horizontal line from A to B and a horizontal line from B to C with a tangent point at A and a tangent point at B. Pretty simple. Oh, there you go. A, B, and C. Are they both horizontal then? Yeah, there we go. He's not in the chat here, is he? No. Just talking from the chat. Text chat trolls. So we're going to have to be dealing with that. I don't know who... Does anybody know who Night Sky Jeff is? Is he the representative of the new globe geometry?
I have no clue who he is.
He spoke the other night, I think.
Yeah, but he's rolling his sleeves up, isn't he? Hey, hang on, lads, I'll take this.
Yeah, he came in here as an ambassador for some other guy yesterday.
Yeah.
He had never heard about the twin tangents before yesterday. So he is definitely fresh.
So which one is the where's his toothpick tangent?
Yes, he's replicating Wally's film.
Yeah.
He's just replicating this.
Correct me if I'm wrong. Both B and C are above the circle, and A is below the circle.
It's the way it looks.
Yeah.
No, this is 3D. This is 3D picture.
Okay, so A is touching the circle.
Yeah, but there's only A that's touching it. Yeah. And B and C are both above.
Floating.
Yeah.
Yeah.
Toothpick tangents. Yeah, well, if you've got a toothpick tangent at B, then you have to have a toothpick tangent at C. You're right, you've got 3 tangent points now. He's just developed them.
Wow.
A is on the surface, B is above the surface, and C, yeah.
How can you call them tangent points in any way?
Can't.
Exactly.
So B's not a tangent. He's going to say, Jeff will tell us that B's not a tangent.
C is where most of the earthworks took place, I imagine.
4-foot slope.
And B.
Well, it looks like he's got a bit of a slope on both of them, but
yeah.
Can't have a slope because they're horizontal.
Uh-huh.
Right.
This is
can we not crowd Jeff? Like, I would like to try and get some answers from him before he gets taken into the weeds with everybody, and he can just answer whatever he wants then, and we never get an answer. What we need is B a tangent point or not? That's the only thing we need to know, because there's it's a twin tangent challenge for FE Dogma.
According to last drawing, we have only at A tangent point and nothing more.
That's supposed to be representative
the Highlander. They could only be one.
Yeah. This is supposed to be representative LIGO as well, right?
I think so, yeah. I mean, this is more of a representative of their model of LIGO than FE Dogma, and he's drawing a ball on the side. Right? Now, these guys, Wally and Night Sky Jeff, are making a good go at it, right? They're really trying hard. Whereas FE Dogma, the guy that started the challenge off, this is a bit of a poor effort, really. You've got Night Sky Jeff and Wally really trying hard to do this, but unfortunately they're dealing in 3D Euclidean geometry and they're setting themselves up for a fail. Yeah, I don't know. FE Dogma does have A and B on a horizontal line. Is he coming back or not? No. Night Sky Jeff's gone.
And their insistence is still that those are tangent points.
Well, see, FE Dogma did the video a year ago. And it's only since we watched it that all of this stuff has occurred. So that stuff's been sat in the video for all of that time. Nobody else spotted it.
Nobody addressed it.
So, as yet, I'm unaware of... I've not had a chance to talk to anyone about it. Obviously, you heard the conversation I had with Blue. Blue, we're talking about the geometry of the horizontal line with two tangent points on it. That's it. That's all we're talking about. Once you can address that, we can go on to the further. But that needs to be sorted first. That issue, the basic geometry, two tangent points on a straight line. It's impossible in the world of geometry that I know. Unless you just draw two different circles, but I was under the impression that it was meant to be your model. And there's only one of them, unless you don't have two models there, that you could just move them around. Conceptually, or like for reals. Maybe that might be it. It's just a make-believe model that you can move around and use wherever you want. And if that's the case, let us know. That's good. As long as we know the rules that we're playing with, that you can just make up shit wherever you want and just inject it at any point wherever you want. And then say, oh, I don't have to answer that. You don't understand it. But hey, it's just me. I've been around here for a bit. I've never really had a proper answer from anybody for any of the questions I've ever asked. Yes, Hex, you just draw 2 fucking circles. That's the only way you can do it. The only way. Toothpick tangents are globe model geometry. It's not Euclidean. You're going to have to come up with a whole new set of geometry laws to get away with the toothpick tangent. It's very inventive. But it doesn't make the tangent, well, it doesn't make the line a tangent at point B at all. And then again, when you have both lines as being horizontal, that's an extra challenge, because then I think you have to justify horizontal as well. You have to change the definition of horizontal, tangent, all sorts of stuff. Yeah. I know Blue Marble and the Globe gang, they're upset. And don't worry, Blue, not a flat earther. So your model's not at stake to a flat earther. I don't want to come and take your model off you. I don't want a model. I just want to try and get an understanding of how the geometry works. I know how geometry works in reality, and I know how the basic concepts of Euclidean geometry work. And what FE Dogma has done is impossible. But I'd just like to know how the globe model deals with it. Let us know if I'm getting it right. You either draw 2 different circles, a circle wherever you want a tangent point, or you invent some way of extending a radius, and like this is in 3D reality. You have a ball, a 3D sphere, the spherical object, and then somehow extend the radius past the circumference, i.e. a toothpick tangent, which is it is a new thing to me. I didn't even know it. I bet most people didn't even know about toothpick tangents, but they've just been invented just recently because of FE Dogma's twin tangent challenge. Very inventively by Wally, the number 2. And that's why, if anyone was doubting why Wally is the number 2, it's undoubtedly because he has the ingenuity to do the toothpick tangent, and there's nobody else that could have done that. Hex says that horizontals, the definition of horizontal doesn't need changing. It just fails to realise that horizontal is not universally parallel. But that would need it to be change its definition, because horizontal is parallel to the plane of the horizon. All of them. Which means all horizontals are parallel to each other. Geometrically, of course. provably within mathematics and geometry. Only Euclidean geometry, actually. Some sort of a straw man. Not what F.E. Dogma drew. And I'll put it in here. I'll put it on screen for you, Blue, what F.E. Dogma drew. That's one of the ones that F.E. Dogma drew. And then that's the other
Anybody
one
there?
that F.E. Dogma drew. I put the A and the B and C on it.
When was this recorded?
Contradictory, Blue. This B here doesn't seem to have a circle on the side of it, like he drew here. Look, he drew that circle there, but didn't do it here. Really weird. In fact, I might see if I can get that on the overlay one on top of the other. I'm going to plug my charger in. Anybody else want to talk about anything? I'm just going to try and see if I can overlay this. Oh, that's good, Saragaki. Lastly, remember that your faculties of reasoning and argumentative powers will be sustained and matured by a course of mathematical study. It will enable you to distinguish that of which is solid and useful from that is which is, what's that? Specious. And flimsy. Spacious.
It's like specious.
Specious. Yeah. So that's a different word. Flimsy. Gold from tinsel. Truth from falsehood. That's mathematics, Blue. Come on, put your maths up to the test. It will prove truth from falsehood. We can with mathematics. Just come along, Blue. Send your best.
Do we have spacious math, Blue?
That is
it must
good,
be how they get them triangles greater than.
But specious means superficially plausible.
Yeah, no way up.
Superficially plausible. I like that.
I'll give you a spacious truth.
Actually, it looks like specious means superficially plausible, comma, but actually wrong.
Yeah, that'll do.
Interesting.
Yeah, that's the point. It's been associated with the word flimsy. It's not solid for you to build a foundation on. It's just some flimsy.
Spacious, extra room for bull whenever you need it. You have extra room there.
That's a good way to say it.
So you agree with that?
Superficially plausible.
Jesse, you agree with that?
I was just stating the definition. I don't know what we're calling specious, but that is the definition for the word specious.
Have you tried the FE Dogma Twin Tangent Challenge?
No, and I just got back from work, so I just missed it.
Wow. You must know LIGO, though.
I have heard you talking. You asked me about that yourself, actually, the other day.
Yeah. It's one of those, we're calling it sort of a challenge, isn't it?
What is?
The challenge set out by FE Dogma.
I'm not familiar with FE Dogma's challenge.
Okay. There you go. LIGO. Have you heard of LIGO?
That I have.
The straightest thing in the universe. Right, he's got a horizontal line, like LIGO, from one end to the other, corner station. Right, and he's got a tangent point at point A, right?
Oh, you showed me this a week ago, I think, or something, a few days ago, and I hadn't gone and looked, but at your...
He's put it on fucking YouTube. Wally, we told you not to do that, man.
At your suggestion,
unbelievable.
I did go get the as-built drawings, and that's what it looks like he did. He just took the blueprints, and that's where he got all those numbers from.
Yeah, but the challenge is the tangents. He's got a tangent point at A and a tangent point at B, with A to B being a horizontal line and B to C being a horizontal line. The challenge is, how do you do that? Geometrically, how is it possible for you to have two tangents on one straight line?
So what exactly am I looking at here? The northwest arm and the southwest arm. Are you saying that the two lines are at right angles to each other?
No, the two lines are at right angles to each other. It's LIGO.
Okay.
The problem is you've got a line going from A to B, which is the straightest thing, right? The concrete pad. It's dead straight. He's labelled it horizontal. So you know it is a dead straight line. Now, at point A, he has a tangent point. And at point B, he has a tangent point. How? How do you solve that? That's the challenge. The FE Dogma LIGO Twin Tangent Horizontal Challenge.
And so your question is, how could B be one tangent when the other B was not the tangent? Am I understanding you correctly?
He's got a tangent point at A and a tangent point at B. How is that possible? That's the challenge. That's FE Dogma's challenge. He's put it in a video. All it is you have to sort that mentally. I've done it for myself. Everybody here has already done it for themselves. How do you manage to solve that? Is it a puzzle? It's not really a puzzle. How to challenge the FE Dogma's set?
All right, let me look at these pictures here, see if I can figure out what you're asking.
I don't know if I should just let that one slide.
It's quite easy, right? Everybody understands the FE Dogma twin tangent challenge. I think it's good. See, as far as I am aware, the Globe Gang have never really engaged geometrically with us at all. And like, hats off to you, Wally, but should you really have put that on YouTube? Should I we get that? I'll get it for you guys and put it in get Wally a few views. I didn't know you'd put it in the here you go, guys. This is Where's Wally's video coming in the chat if anybody wants to go and watch it. Wally's going to show you how what FE Dogma has done exactly is impossible on the Globe model. At least the 3D Globe model. And you will see, for the first time, looks like Jeff sort of reinforced it here as well with the toothpick tangent. It's locked in. Jeff's done it. Look at that. Boom. Ah, see. Look at that.
Wow.
Don't look in the chat because you might find out.
I guess what I posted inspired him, huh? Yeah. I thought they'd do that. Just move the line over. Doesn't work like that, dude. Sorry.
I'm going to have to get this one because, Jeffy, thank you very much. Save that one. He's got 3 though, right? Triple. Jeff's gone for the triple. He's on 1 extra. Triple tangent. I'm saving that. But, yeah, in case anybody wants to see, in case they missed it, there you go in the chat.
He added some circles.
Jeff.
If you noticed.
Yeah. He's got like little nipples, hasn't he?
This is too good, man. Oh,
so Jeff has gone with the triple tangent. Added 1 for good measure. Thanks, Jeff. Wally should be good. Wally might be making adding that to his video. Seem to have ditched the toothpick tangent. I was hoping for that. I like the toothpick tangent.
No, Wally posted it.
Yeah, I know, but Jeff with his nipples and those circles.
It's just as ridiculous.
Yeah, but the toothpick tangent was a good idea. Like seems like Wally's invented the toothpick tangent, and then Jeff's come along and
I spoiled it for him.
Yeah, he's just sort of ripped it off, and I don't know whether this Jeff's one's gonna take off more than Wally's toothpick tangent.
Well, that's not nice.
2 different lines. Yeah, look at it, Blue.
That's not neighborly, like stealing somebody's idea.
Yeah, the 2 different lines. Actually, there's 3 lines. It's triangle ABC. But only 2 of them are actual physical straight lines.
Do I see 3 radii as well?
Oh, yeah. But then you'd be talking Euclidean. Wouldn't you? 3D balls. One tangent point on each line, but you've got 3, Blue. There's a tangent point at each end of every line. You've got 3 lines, A, B, C, and at each end of those lines have all got tangents on them. Even Jeff has drawn it. Blue. How can you not see that? It's like you are blinded to it. Tangent point at A, a tangent point at B, and a tangent point at C. So line AB has got a tangent point at A and a tangent point at B. Line BC has a tangent point at B and a tangent point at C. 2 tangent points again. Line CA has a tangent point at C and a tangent point at A. That's 2 tangents again for that one line. It's pretty obvious.
Sometimes people don't want to get. Sometimes people don't want to get topped, so that Rumpus is tangential points.
Yeah.
And now we got tangent points.
How many tangent points does LIGO have, Blue?
3. It's got to have 3 there. Jeff's drawn it. And 1 at A, 1 at B, and 1 at C. You've got an extra one.
That would be 3, right, Blue?
That's good. 3 tangent points.
Trifecta LIGO.
I mean, who'd have thought that FE Dogma's twin tangent point would end up getting a triple tangent? And do you know what that means? If you've got triple tangents, you've got triple nutsacks.
Oh no.
Yeah. The old triple nutsack. A maneuver not attempted. Yeah, this is the first attempted to see whether they can get away with the triple nutsack.
Danger Wilco.
It's like seeing the gymnast, right, waiting to go up, and it's like a first attempted. Here he is.
Triple pike.
Jeff Night Sky. A new entry into the arena. It's attempting to pull off a triple nutsack.
Triple nutsack reverse pike. And you see the judges ranking it. Ooh, that was a nice entry. Little splash.
Well, I don't know who he is. I don't know if anybody else knows who he is, and we can't have him just coming in here. Imagine all of that time that Wally's spent in here. It's like nearly a year. Typing day after day, spending hours here doing that. And in comes Jeff Night Sky. Night Sky Jeff. Jeff. You reckon Jeff? Sounds familiar, doesn't it? Who else was called Jeff? I remember there's a surveyor on Twitter called Jeff. Did a fair bit of work with Plumb Bobs. A Plumb Bob surveyor, he was. I don't think we should allow Jeff to come in. We'll have to have words with Wally, see whether Wally's okay. Because Wally did the video first, so at least Wally's got the claim to fame with the toothpick tangent. Dated as well. Please save that video of Wally's. I've downloaded it. I got it at an early copy. Straight to Discord. Exclusive. As Jesse, what do you reckon, Jesse? Which way are you going to go with it?
I'm not even sure what question you're asking.
The twin tangent challenge for LIGO. Would you triple up? Would you? Can't really call it doubling down, like Jeff. Jeff's added I don't know. We call them nipple tangents. He's added little bits. You know where Wally did the toothpick tangents.
And I'm not familiar with Wally's toothpick tangents.
He's put a video in the chat. Did you watch it?
Maybe I need to watch that.
It's only a really short video, but I think you should. Because this should be... I don't want to sway you, though. I mean, FE Dogma did just draw a circle on the side. Wally may be taking it into extra realms that it's not needed, but hey, he's put it in on YouTube, so he's going with it. I'll put it in here.
How they can... This is like a twin drop. They don't even see it. Not only do they have two tangents, they have two drops. One from A and one from B.
Yes, of course, two drops, but it means two tangent points. So, sorry, you cannot go around this.
At LIGO. LIGO has two drops.
Have you ever heard of FE Dogma, Jesse?
You always talk about it.
No, have you ever heard of him, the guy, FE Dogma?
I think I've just heard you guys talking about him.
Okay. So, do you think it's a good idea to put two tangents, one at A and one at B? Bearing in mind, his name is FE Dogma. And he's put a tangent point at A and a tangent point at B. And he's labelled the line horizontal line from A to B. And his name is FE Dogma. What do you think the FE stands for?
Frequently enhanced.
Probably. I would say so.
Yeah.
Because if it was that other one, you wouldn't be supporting him, would you?
Well, why don't you show me some of his work so I can tell you what I think of it?
There, he's put a tangent point at A and a tangent point at B. Have you never watched the video where he did it?
I'm not sure. You got a link?
No, we went over it. It may be on the thing. Blue Marble did it as well about a year ago. It's an old video.
Well, let me ask this then. Are you saying that he's saying that a single straight line has more than one tangent points on its axis?
Yeah, he put a tangent point at A and a tangent point at B, at LIGO, one of the arms. Now, B is the corner point, so it is common to both line AB and BC. It is the common point, the corner point, B.
And you're saying it's not possible for it to be a tangent point for one of them and not for the other?
Well, you can only have one tangent point on a straight line, can't you? That's the thing about tangent points.
But there's two straight lines, so why can't they each have one?
AB is a straight line.
There's no rule that both have to have their tangent point in the same spot, unless they're on a plane.
It's a tangent point on a straight line, right? Two different tangent points, one at each end of a straight line. Now, how do you
say that again?
justify
wait.
it?
No, back up. It sounded like you just said that there are two. Oh, I see what you're saying. There shouldn't be, but he's saying there is what you're saying.
Yeah, he's labelled it in his drawing. He has. He's also labelled the lines horizontal lines.
And explain to me why you couldn't have two lines at right angles to each other, which do not share a tangent point, but they share an endpoint.
Well, because you can only have one tangent point, can't you?
Yeah, but those two lines are at 90 degrees to each other. They don't run in a straight line with regard to each other.
No,
So
but the line
it's two
AB
lines.
is a straight line. And he's put a tangent point at A and a tangent point at B. Right, B is the end point of the line AB. I'm pretty sure I've had this conversation. Sounds like fucking deja vu. Pretty sure I've had this conversation with Blue. Can I point out again that this video is from a guy called F.E. Dogma. Right, and he's labelled a straight line with a tangent point at A and a tangent point at B. Now, I don't know how much geometry you did at school or at college, maybe university, but you should know it's impossible to have two tangent points on a straight line. Unless you have two different circles. Now, how do you, I may have given it away there, helped you out a little bit. How do you deal with it? Remembering that it's from a video from a guy called F.E. Dogma.
Frequently excitable? I'll go with that. Although, I mean, I'd rather discuss the issue rather than a name of some guy, right? Why do we have to keep going back to that? But let me ask you this. If you had a line, like you were talking about toothpicks. So let's say we had some toothpicks. And you've got a beach ball. Do you have beach balls over there? Like these inflatable toy rubber balls that you play in the water with?
Like we've got Wally's done a video. Have you seen Wally's video yet?
I keep asking.
Please
for it.
have a look.
Posted.
I've put it in there.
Oh.
In the live chat. It's in there now. I'm going to click it.
You guys need more Wally.
Everybody can see it.
Explain LIGO tangents.
Which one is that? The Stark Otter one?
Super easy. Barely an inconvenience.
Yeah, Stark Otter takes LIGO tangents to a whole new level. And the elevation drawings as well. Which is what he has there.
Discord lets you upload an 80 megabyte file. That's cool, I guess.
Yeah, up to 100. Got a good Discord server. I quite like Discord for doing that. Best for presenting. And chatting, obviously, and you can play games and show all your screen. Do all sorts of stuff. But you can see that he has marked on the screen in a green, he has a tangent point on the northwest arm. And then at the other end of it, he's got another tangent point. I mean, these are LIGO arms. I know it looks ridiculous. And I didn't do these elevation profiles. And why do you think he labelled them horizontal? And then Wally's drawn a picture like that. Can you imagine? I can't.
Yeah, I mean, if you just take a toothpick, plop it on a basketball, it'll have a tangent point. Now take another toothpick.
The toothpick,
lay it across the first one.
the toothpick will have a tangent point.
It's that kind of toothpick.
The standing up toothpicks, the one like Wally's done.
I don't know what Wally did with a tooth.
Have you watched the video?
No, it's downloading.
Why haven't you watched the video?
I got slow internet. It's downloading, man. I clicked it. It's downloading.
You can just press play. You don't need to download it.
Huh? No, it's just the only option I had was to download, and so I did it. But it's downloaded. Let me play it.
I'll get the picture. Buster got the picture for it. Tangent point of B.
Oh, is that the toothpick you're all moaning about?
Moaning about it? I said saying it's very inventive. A toothpick tangent. He puts point B at the end of a toothpick. So that's the toothpick tangent that he's talking about. That's how Wally solved the problem with a solid sphere. F.E. Dogma just drew a circle on the side of it. How do you solve the problem? I think F.E. Dogma's trolled the shit out of you, really. Especially by drawing a circle on the side of it. But hey, Wally's very inventive with the toothpick.
So I don't see what the problem is. That second line, it's the end which is perpendicular to plumb is at a point at the other end, at the end of the other line, which is not the first line's point of being perpendicular to plumb. They obviously. Let me ask you this: which end of the second line is perpendicular to plumb?
Which end?
Yes, which end of the second line?
The plane, or the whole plane. A, B, C is horizontal. So all of the perpendiculars to that plane will be parallel. Right? So where's the perpendicular? Horizontal plane, perpendicular, vertical. What tool do we get to establish a vertical? A plumb. All the plumbs to that horizontal plane established A, B, C will be vertical and plumb. Perpendicular. All of them.
So tell me about the B end of the first line. Is it
where
at right angles?
That's where he put a tangent.
Is that line at right angles to plumb?
Is that the B that he put a tangent on? Yeah, just to make it sure that we know what we're talking about. Is that the point B where he has a tangent point? F.E. Dogma placed the tangent point at point B. Are we talking about that point B?
This is so simple and you're not getting it, and I'm not sure why. Maybe you're just pretending for likes.
Why
I don't know.
can you not answer that question? At point B, he has a tangent. Are we talking about point B where F.E. Dogma has a tangent? Are we talking about the corner point of LIGO?
That's what I'm asking you. Is the B end of the first line perpendicular at right angles to plumb?
The horizontal line, AB, that has a tangent point at A and a tangent point at B, you're asking me if that horizontal line, AB, has a perpendicular at B. Is that what you're asking?
Well, not exactly.
Okay, please, Jesse. Clarify your question.
Okay, let's look at just the first line.
AB.
AB is point A of the line at right angles to plumb.
I haven't got a clue. Where does it say that? Well, he's labelled it a horizontal line, so yes, perpendicular all the way along that line. If it's a horizontal line, like FE Dogma has labelled it, then yes, perpendicular, plumb, all the way across, I would say.
That's not the question I asked. Why won't you answer the question I asked?
What was the question you asked?
Is the A end of the first line at right angles to plumb?
The A end, right angles to plumb?
Yes.
Yeah, the entire line is horizontal. Yes.
No.
Yes, Jesse. It is a horizontal line from A to B. So, perpendicular to any point along it will be plumb. Now, did that answer your question for you, Jesse? Or can you not understand?
Well, no, you didn't, because I'm asking...
Holy shit.
Yeah.
Go on, answer your question. See if somebody else can answer it for you. Go on, ask somebody else.
Me ask somebody else, or somebody else ask me?
No. You've asked me 4 or 5 times. I've given you a very comprehensive answer 4 or 5 times. Please try and ask somebody else. I'm going to keep quiet. So is there anybody else willing to answer Jesse's question for him? Because he doesn't seem to understand what I'm saying. Go on, ask your question again, Jesse. Let's see if anybody else can answer it.
Okay. According to Dogma's presentation in the triangle and all that stuff, whatever, is the first point of the first line, in other words, A, is that line at right angles to plumb at that end?
That would be
You cut out there.
affirmative.
Okay. And within Dogma's model and claims, is the B end of that first line also at right angles to plumb?
That would also be a yes. Affirmative.
No, I mean in FE Dogma's model, because that's what we're talking about in his claims.
That's what he claims, isn't it?
No, it's not. He
Is
shows
that not what the horizontal means?
Not in his
Is
model.
that not why he put horizontal there? Are you going to say at the other end, it's not perpendicular to vertical?
It's not perpendicular to plumb. That's the way. Look, it's drawn. Look how it's drawn. He shows.
He's drawn them both horizontals. AB horizontal, BC horizontal.
But he's shown level as curved. Do you see?
I wouldn't bother. I wouldn't bother about the curved bit because he's put 2 fucking tangents. One at A and one at B. It's impossible. Forget about the fucking curve. Now.
Well, it's not impossible on a curve.
What's not impossible on a curve?
It's not impossible for 2 lines at right angles to have separate tangent points.
Really?
Really?
Wally seemed to struggle, didn't he, with his little thingy? He had to do toothpick tangents. How do you resolve the inability of having 2 tangents upon a plane or straight line? That was the question to you at the beginning. How do you resolve it? I know you've just said it's not impossible, but how? Go on.
I tried to explain and you cut me off. I'll try again. Let's say you had a beach ball and you take a toothpick, or do you do pickup sticks? A little, like they're longer. It's like a long straight matchstick. You lay a long matchstick, onto a ball. It's got one tangent point, right? Now, take another matchstick and lay it on that first toothpick, but at right angles, so it forms a cross or a plus or a T or an L, any configuration where they cross at right angles. That second toothpick, or that second matchstick, will also have a tangent point. But it does not have to be at the same point that the first toothpick's or matchstick's tangent point is.
It's at the corner point, Jesse.
I beg your pardon?
It's at the corner point, isn't it?
Well, they each line has its own tangent point, and there's no reason to expect that the two tangent points have to be in the same spot, because they're two different lines in different directions.
No, it's one line, A, B. I don't know how you can separate A and B from the line A, B.
Because the second tangent point is for the second line, not for the first line. They each have exactly one.
AB is a line, though, isn't it? And he does have a tangent point at B.
Yeah, AB is a line, but it's a separate line than BC.
But B is also part of AB. I've been over this with Jesse.
That's where the lines cross, but that doesn't mean that either one of them has to have a tangent point there.
But FE Dogma has labelled A and B a tangent.
Well, he's labelled A the tangent for one line, and then he's labelled B the tangent for the other line. He did not label two tangents on one line. He gave one tangent to each line.
Which means you have to have two separate circles or two separate curves. Not the same one at all. Completely different, right? It's impossible to have one straight line with two tangents to the same circle, isn't it? Impossible, Jesse.
Well, that's because the Earth is a ball, according to his model, to Dogma's model. And yeah, a ball has two curves, one in each direction.
Wow,
Didn't you know that?
That's
Did you hear what you just said?
A ball.
You were laughing at your own answer. That sounded like you were laughing at yourself for a moment there. Sorry.
A ball is not flat. That's a disc, like say a dinner plate, a flat dinner plate like disc, like a pizza. That, yeah, you couldn't have.
Jesse, whoa, calm down, calm the mind. We've just got two straight lines. This is LIGO. We've got like an X and a Y. That's it. That's all we're dealing with. No need to go off the rails. It's like FE Dogma shouldn't really have set this challenge for you Globers, especially being FE Dogma. I mean, wow. Imagine that, having is he a flat earther? Setting a challenge for you guys and you struggling so much with it.
No, we're not struggling. You just don't get it, my friend.
You're damn right I don't get it. He's got two tangent points, one at each end of the same straight line. I can't get it. It's impossible. I know that. I know it's impossible. The question was to you, how do you try and resolve it and make it possible within your framework of your model?
I mean, it's simple, but you don't understand the 3D spatial geometry. You don't realize that two lines at right angles could have their tangent points at any place on each one of them in different places from each other and still cross each other. It's basic geometry, but that's it works, but you're not mentally grasping it, and I don't know how to help you with that.
It's impossible. Yeah, I did. So I told you it's impossible. It cannot be done. That's why I'm enjoying this, because I know it's impossible, and I know that you're trying to work some way out how to do it, but you aren't coming up with any solutions, Jesse. Words are just blotting out of your brain, right? There's no solution to it, and you're going to keep trying. It's going to be fun.
Well, yeah, you gotta use the definitions that Dogma's using, and then maybe it'll make sense.
Well, Dogma just drew a circle on the side of it.
I don't know anything about a circle on the side of anything. But if you take the tangent points to be the one point on the straight line that's at right angles to plumb.
Yeah, I've got a picture here. Now, when Ruhif saw this picture, he just said it wasn't relating to LIGO, but it was how FE Dogma decided to put the tangent point at B. Do you agree with that?
Let me try to figure out what I'm looking at here.
Yeah. It's I feel sorry for you as well. FE Dogma should be here doing this. I don't know why he's not. But he's made Blue go through it. Now you. I don't know who else. Wally's got Wally drawing things. He's got Rumpus doing presentations on blues.
It's like Blue is taking in all the stray cats, with the exception of Rumpus. Rumpus has been around forever, but what's up, Blue? Are you feeling sorry for
Jesse's mopping the floor with Bev? Carry on, Jesse. Keep going. Blue was loving this.
Sure.
See, FE Dogma just drew a circle on the side, but I'm not too sure. Ruhif said this wasn't LIGO. He wasn't trying to represent LIGO with this. He was just explaining how you could have a tangent point at B.
It's funny how they're laughing at us and they have toothpick tangents. It's hilarious.
At least we have tangents.
Yeah,
actually, Jesse, that was I saw that smile. On which geometry? Because tangents are definitely Euclidean geometry, right? Aren't they? The 3D solid spheres. Is that what we're talking about? Or are we talking about Euclidean 2D circles with tangents, straight lines?
Well, can't you divide a sphere into...
Jesse, which one are we talking about right now? Which ones? Because you were laughing. Which circle and tangent are we talking about? Are we talking about tangent planes or just tangents to circles?
I don't know what you're talking about. I don't even know what you're thinking.
Okay, well, which geometry are you using? Would you wanting to be using Euclidean geometry or non-Euclidean geometry? Spherical geometry. Take your pick now.
Well,
because these are our fighting tools. You obviously know I'm going with Euclidean geometry. You were laughing about tangents. I'm going with Euclidean geometry. Which geometry are you using, Jesse?
Testing 1, 2, 3. Okay.
Don't answer it, Jesse. Go on.
Well, you cut me off so many times. I wanted to see if I could get a word in. I don't know. I can get the tests in, but I can't get the words in. But anyway, can't we slice a sphere in half?
In Euclidean geometry, yes, you can.
And then look at it as just a circle, and then
in Euclidean geometry, yes, you can. Is that what we are doing, Jesse? Are we using Euclidean geometry? Just so everybody knows that's listening. So we can all be sure we are using Euclidean geometry with circles and tangents, like everybody knows.
So why can't we slice the Earth in?
Hello.
Okay, never mind.
Are we using Euclidean geometry, or do you not know what Euclidean geometry is?
Well, my friend, my kind of rule is when you cut me off that many times in a row, it means you're interested in talking to someone else. So thank you, sir.
Once you don't answer enough times, Jesse, it's time you fuck off.
Yeah, he asked a very pointed question 5 times. You avoided it 5 times.
And that wasn't the first time that's happened, Jesse. So, yeah, okay. Thank you very much.
See you later.
Another one bites the dust. Nobody can actually go through the FE Dogma twin tangent challenge. I think he's done a good job for the flat earthers, really. I'm not too sure why the flat earthers haven't picked up on how good a work he's done for them. So if anybody else wants to come and take the FE Dogma twin tangent challenge, I think we should go with the which sort of geometry we're using from the beginning, really, just to make sure that people actually understand the geometry that they're using. We should put that Plato's Academy, shouldn't we?
Basically, yes.
When the banhammer starts cutting you off every time you're trying to say something. Jesse, you've still got your mic open. The banhammer, what are you talking about? Shocking, Jesse. Yes, let's move on.
What diagram is Blue on about?
Oh, I don't know. He's telling his friends somewhere that he has a way to make this all clear. But as we know, Rumpus has gone with the 2D circle extension of the radius. Wally's gone with the toothpick tangent, which is the 3D version of that. All talking about Euclidean geometry, might I add. And Rumpus and FE Dogma have just drawn circles wherever they want to make a new tangent point. And Jesse didn't even know what the line was. He couldn't even understand that A and B are at each end of the same straight line. And that FE Dogma had put a tangent point at A and a tangent point at B. Jesse didn't even know that B was part of line AB.
Yeah.
It's a terrible thing. But the FE Dogma twin tangent challenge is... Don't know, it's a tough one for the globe model. Rather ironic that he did the video, right? Because, I mean, he is called FE Dogma, and to hear these guys not say it's impossible, you can't do it. Why would they do that? Why? Ask yourself, why would all of the globe model defenders be scrambling so hard to defend a guy that drew a line from A to B and labelled it a horizontal line and put a tangent point at A and a tangent point at B? Why would they be trying to defend it if the guy's called FE Dogma? not wanting to say that I'm into conspiracy theories or anything, but, you know, it's worth asking yourself, isn't it? I'd say we should offer this up as a challenge. We make a video of exactly how tough a challenge this is. Could the model be at stake if you take the FE Dogma twin tangent horizontal line challenge? Can you come out at the other end with the globe model intact? Is it possible? A few simple steps.
Negative.
Yeah, well, no, I'm saying, do you think we'll be able to develop a test based around FE Dogma's video to be able to present to people just with the line A, B, horizontal line, tangent point here, tangent point here. Boom, there you go.
Very easy. Yeah. Tailor-made tangents, we'll call them.
Drop from horizontal, as they say.
Yeah. Isn't that weird? A drop from horizontal, but then it goes back up again.
But it drops from both sides.
I'll never forget the first time I met you guys. We went through the Ballers Canal.
Yeah, I was hoping to get take somebody through that sort of thing, because maybe Jesse might want to go through the 12. I mean, it might be better to start off at the simple groundings, then we can have a simple understanding. We know we're all coming from the same point of view.
It does set a
genius. The Ballers Canal. That's genius.
It does set a pretty good baseline, you know, the 12.
Yeah. Because it does seem like we are not really understanding all of we are not of the same understanding, obviously. Nah, I didn't play. Look, he's there. He's here on the screen. Look. Ooh. He's not booted or muted. He's just here. But nice try, Blue. Do you want to come in and help him out? We'll go through the 12. Blue's just making stuff up. It's all right.
Jesse's just trying to gather his thoughts.
Yeah.
He found himself in a pickle.
Would you like to, we've got like 12 steps of understanding, Jesse. Like, they're really simple to go through, just so we know that we're on a similar footing.
What's the first one?
The first one. Well, let me get it. Let me sort this out for you.
You see, there might be hope for Jesse, Blue. Unlike some of the more seasoned ones.
There you go. And okay, there you go. Oh, wait a minute. There you go. Okay, can you see that? Don't be put
Where am I
off.
looking?
In the.
Where am I?
I'm sharing my screen.
Oh, let me bring it up. I see it.
Okie dokie. Now, these are very, very simple. 12 steps to t-shirt logic, we call it. Straight line is right. A right line is that which lies evenly between its extreme points. That is, without curvature in any direction, being the shortest path between those 2 points, never deviating from that path. Not a concept, but a fact of reality and basic logic. Would you agree?
I think you've given me a definition, so I don't know how I can disagree with the definition if that's what it defines.
It's a straight line.
Okay.
It's a pretty comprehensive idea of a straight line, right? But that all of those points have been put in because we've had to.
Understand.
Okay, so that's definitely a straight line. Next step. Plane. Superficies, plane surface, is that which has only length and breadth. Those 2 dimensions, length and breadth, make this a 2D conceptual surface on which plane geometry is based.
Okay.
The 2D plane obviously does not enter the 3rd dimension.
Fair enough.
Okay. Next one. Euclid's Elements, Book 1, Definition 10, perpendicular. When a straight line standing on another straight line makes the adjacent angles equal to one another, each of the angles is called a right angle, and the straight line which stands on the other is called perpendicular to it.
Okay.
As stated, axiom 11, all right angles are equal. Therefore, the lines must be straight.
Okay.
Perpendicular to a plane. Euclid's Elements, Book 11, Definition 3. A straight line is perpendicular or at right angles to a plane when it makes right angles with every straight line meeting it in that plane. Book 11, Proposition 6 states, if 2 straight lines be at right angles to the same plane, then they shall be parallel to one another.
Got it.
Okay. It's basic. Geometric basic. Now get real. Vertical. At right angles to the horizon. Perpendicular. Upright. In mathematics, it is a plane position or a straight line.
I think that it is a plane, comma, position, or straight line.
Mm-hmm. You agree?
Yeah.
Not just a straight line. Horizontal plane. Parallel to or in the plane of the horizon. At right angles to a vertical line. In mathematics, either measured or contained in a plane parallel to the plane of the horizon.
Okay.
Agreed? No problems?
There are situations where where not all of those definitions would apply in all usages. Okay.
The horizontal plane.
But from the viewpoint of an observer in a location, then yes. assuming we're talking about his location and his horizon and his plumb.
Jesse, can you just sort it out for Blue? Did I mute you?
Did I
mute you?
Not yet.
There you go. Sorry, Blue.
But I was worried it was going to happen.
But we didn't. You didn't send Blue a message to say that you were muted or anything, did you? Because
No.
Blue seems to be thinking in the chat there that we muted you. He's telling everybody in the chat that we muted you.
Oh, not yet.
Why would he be doing that?
Nothing to do with horizontal, you idiot.
Why would
horizontal
Blue be
is
talking
defined
about...
by being perpendicular to the vertical.
Fucking hell, Rumpus.
Don't talk about
Jesse,
horizon.
This is
Rumpus.
sadly surprising that Rumpus comes in to do this.
Get a grip, Jesse. The horizon has nothing to do with horizontal. Do not agree to that. Thank you.
What?
You came in to
Yeah,
straighten
get a
JC
grip,
out.
Jesse. Holy shit.
Jesse, there's no need for you to be coerced or anything by Rumpus. It's just Rumpus. Don't worry about it. This is just a definition we're going through. Cartesian axis. I mean, you can go and check it. Check a mathematics definition of horizontal if you don't believe us.
You see how triggered he got, Jesse? To a simple thing.
I think we got to the next one, did we? Horizontal and vertical geometrically are perpendicular, with horizontal being the plane and vertical being perpendicular to it. They both have a common factor being the horizon, which they are either parallel or perpendicular to. Would you agree with that?
Let me read this one again here. Horizontal and vertical geometrically are perpendicular. Goodness, who wrote this? What book and chapter and proof was this?
What?
Yeah, you're quoting Euclid before, right?
Yeah, that other one was, yeah.
But who wrote this? Where
what's
did
up
this
with
come
it?
from?
With the words, where did the words horizontal and vertical geometrically are perpendicular? Is there
Yeah,
anything
who wrote-
wrong with that?
Well, I'm just asking. Have
Have you got a better
who wrote
spelling,
this?
or what is it? Semantics, or what?
Well, I just want to know who wrote. I
That
want
was
to know.
Euclid's cousin.
Yeah.
Oh, it was twice
Spiro.
removed.
Yeah.
Twice
Yeah.
removed. Okay, Euclid's cousin
Euclid's
twice.
cousin Spiro, yeah. What does it matter who wrote them?
I'm just asking, because you had Euclid mentioned earlier and his various proofs and axioms and whatever you call them.
Yes.
But this one didn't have a credit that I saw. I was curious.
No, it's just all right. I did it.
Oh, okay. You know, somehow the grammar struck me as being
Well,
being used.
how would you say it then?
I don't know that I'd
Horizontal
do any better.
and vertical. Oh, you don't know how. Oh, sorry. Sounds like me then. Good. Horizontal and vertical geometrically are perpendicular.
With horizontal being the plane and vertical being perpendicular to it. They both have a common factor being the horizon, which they are either parallel or perpendicular to. So from the perspective of somebody at a certain location,
From a perspective of anyone at any location, I would add.
no, I'm telling you what I'll agree to. I'll agree that for a person in a location, from their perspective, that for them, horizontal at that location and level will be perpendicular to plumb or vertical.
Okay, well, I will give you what you just said, but I will also give you any person in any location will also have the same thing.
But I'm not agreeing that plums are all parallel in different locations. Nor am I going to agree.
Nobody said that.
Nor am I going to
agree.
All
we're just saying is this: are they both perpendicular or parallel to the horizon? Anyway.
From the vantage point of that observer at that location, looking at his horizon as seen from that location. But I don't necessarily think we can draw from this that it's correct to infer that someone else's horizon or horizontal or perpendicular will be parallel, or plumb will be parallel if they're on some other location on the Earth. I'm not going to agree that all horizontals in different locations are all parallel to each other.
That doesn't say that, does it? It just says. Can you read it again? I mean, does it say that all horizontals are parallel to each other? At the minute, we're just building up an understanding of what horizontal and vertical are. And all that says is that horizontal and vertical have a common factor of the horizon. They're either parallel to it or perpendicular to it. Verticals being perpendicular to the horizon and horizontals being parallel to the horizon. And I know Rumpus has just come in and said, don't agree to it. But I mean, like, have a look at the definitions for yourself. I mean, don't think that I'm writing this down to try and coerce you into anything. Go and look for yourself to see, see if horizontals do have a relationship to the horizon or not. I mean, don't be coerced by Rumpus.
No, it's not him. It's that you and I actually discussed this the other day, and you posted a number of different definitions that you had grabbed off the net, and other people may have been posting them. And one of the definitions, which was not you quoting yourself, actually said that horizontal was, parallel to the horizon and perpendicular to plumb at a given location on Earth. And so that's what I'm saying.
Okay, well, I agree with you that at a given location, but I would say at any given location. See, I don't make a specification of that. I would say at every location, any and every location. So can we just go ahead with that, right? Because you do go with a specific one, that being where you are. Where I am, it would also be perpendicular and parallel. Right? And wherever Kevin is, and Emma, anyone, right? Anyone and everyone. So can we carry on to the next bit?
Well, so long as I'm not agreeing that one person's level horizontal plane is going to be parallel to another person's level horizontal plane in another location.
Just perpendicular. Just perpendicular at the minute. Horizontal and vertical geometrically are perpendicular.
Perpendicular to plumb in that location. So
okay,
that's what you get.
Wherever, yeah. Always. At any point. Got reference frames.
And I'm also not agreeing that a horizontal plane is level in all locations. As I've said many times before, a flat horizontal plane would only be level at most at the tangent point.
Mm-hmm. We're just going through horizontal and vertical at the minute. We'll get to the bit. No need to jump the gun. This is this 12-point step, right? So next one, reference frames, horizontal and vertical. So in reality, horizontal and vertical are the reference frames we use as our baseline. Any inclined plane will be measured as an angle to one of these reference frames.
I cannot agree to that.
You can't agree to that?
No, because a lot of times when we measure an incline, we're referencing it with reference to sea level. And
an
until
incline,
we can
reference to sea level. No, it'd be rise over run, horizontal distance, vertical distance.
Right. If you're driving a truck up a road and you're
Horizontal
gaining
and vertical.
and you're gaining 1 foot every mile,
Mm-hmm.
that's measured relative to sea level, right? Mean sea level?
Well, that 1 foot would be a vertical and the 1 mile would be a horizontal. So therefore, in reality, horizontal and vertical are the reference frames we use as our baseline. Any inclined plane will be measured as an angle to one of these reference frames. You've just said there, to measure the slope, you would need a horizontal and a vertical. So there you go, proved. They're the two reference frames you're going to use.
But in reality, we don't always necessarily use a straight reference frame when measuring an incline. Because we don't always use a plane when measuring an incline.
Rise over run.
We use sea level.
Rise over run you'd use, though.
See, this is also...
Please explain then. Sorry, I may be putting in. Please explain by what you mean your incline. Tell me exactly again.
Who is this? Is this page also you quoting yourself?
Quoting myself. It's just I wrote some words down.
Okay, so it's not from Euclid's book. So in reality, horizontal and vertical are the reference frames we use as our baseline. I mean, it depends on what we're doing. If we're building Lego, then yeah, it looks like we do use a flat horizontal plane, but it's not level at all locations. If we're talking about a road that's gaining so many feet a mile to get up over a mountain, we're talking about referencing it to sea level, which may be curved, in which case we're not using
sea level
a plane.
Curved. No, just a point. It's an elevation point, right?
Well, yeah, I don't.
And all the elevations are actually on the vertical datum. So you would be using, if you're talking about elevations that are on the vertical datum, you are obviously referencing vertical. So I think you would be once again agreeing that that is one of the reference frames that we use as the baseline, the vertical datum. Elevations.
The thing is, according to the surveyor's manuals, the vertical datum is based on a geoid of some sort.
It's vertical. Read it again, please. Like, in reality, horizontal and vertical are the reference frames we use as our baseline. So if we use the vertical datum, that is us, in reality, using the vertical as a reference frame. It is exactly what is wrote down there, is it not?
I'm not sure what you're getting at.
I don't know what you're arguing against. You're trying to tell me that the elevations that we use, reference to mean sea level, the vertical datum, seems to go against me saying that in reality, horizontal and vertical are the reference frames that we use as our baseline.
Maybe we could do this. Could we change it to say that in reality and in a strictly rectangular coordinate system, then vertical and horizontal are reference frames we use as our baseline?
Do you not use vertical as the reference frame, as the vertical datum? And why do you have a problem of me saying that vertical is the baseline of us using for the vertical datum? Like, what's up?
Well, you're trying to slip in some false definitions at this point so you can then tie it up to prove something, or to pretend like you proved something at the last step that isn't true.
No. These are just the 12 steps so we can have a clear understanding of what we're talking about. Do you not agree that a vertical datum is part of the vertical reference frame?
I don't even know what you mean by that. Do you have a definition that says basically what you wanted to say here, but that's by someone other than yourself that writes on the topic?
Is somebody else, anybody else in the room?
No, I mean like
having a problem with this.
Rumpus might be.
Doesn't seem like there's anybody else having a problem with it.
I'm not.
Does anybody else understand why Jesse might be having a problem with it?
I think he's worried about his model.
Already? We're just talking about vertical and horizontal. It's obvious that they are the reference frames we use. Can you think of any other reference frames that we would use instead of vertical and horizontal?
I think he wants to use a curved line instead of a horizontal.
But he doesn't know what it is. Don't be leading him. He wouldn't know what to call it or anything, would he? How would you use that as a reference frame, Jesse?
You can't.
You're not trying to slip in some sort of a curved axis somewhere. What would you call it?
Well, so how about we just say that in a strictly rectangular coordinate system, then horizontal and vertical are the reference frames we use as our baseline.
Yeah, it does say at the top there, Cartesian axis, X, Y, Z. Surely you've heard of them in mathematics. Yeah.
Okay, we can move on then.
Yeah. So we are of the understanding that the Cartesian X, Y, Z coordinate system that everybody knows, vertical and horizontal, right?
We can use those terms if you like.
Okay. Ooh, good.
Horizontal is a dangerous term, but because you're going to slip it up to mean things that you didn't just define later.
No tricks. No tricks. Plumb bobs and perpendicles. That's another song for you, Buster. I need a perpendicle now. That's a little bit easier.
Perpendicle?
Yeah. Maybe you might need some backing singers. Maybe Tina.
Yeah.
Perpendicle. Right, a perpendicle is anything hanging down by a straight line. A plumb bob is a tool for establishing a vertical reference. This is used in reality daily by many people. A vertical line is a straight line. I tried to keep it as simple as possible.
I'll definitely go through.
Oh, who's that?
It's just me.
Oh, you've got bad mic.
Do I got bad mic?
Feedback. Yeah.
Oh shit! I'm sorry.
Okay. Oh yeah. Are you okay with them?
I'm okay with the vertical line being a straight line.
Yeah.
And a plumb bob is a tool for establishing a vertical reference. You're kind of... That's a little mushy. You're kind of quoting, or not mushy, but like ambiguous. You're quoting yourself again here, I see.
Quoting myself. I was writing some words down. A plumb bob is a tool for establishing a vertical reference. Right? Can you think of some other wording? How would you want to word it?
A vertical reference?
Yeah. What you do is you hang a plumb bob, right, when you're building a wall. And you refer to that as a reference when you are building the wall. Just as a practical example of how to use a plumb bob.
Okay, I see what you're saying. It can also be used to transfer a horizontal location from a higher to a lower position.
On the vertical datum, you mean? The elevation along that vertical datum. Because that's how you notice a vertical change, is an elevation change, right? Along that vertical datum.
Well, I think we can agree that a plumb bob string is vertical and straight.
Okay. Perpendicle. That's an old school word.
Yeah, I never heard of that.
I know. It's a good one, isn't it?
Yeah.
I didn't make it up. Right, here we go. You might have a problem with this one. Level. Level is a straight line on a horizontal plane. A level is a tool for establishing a horizontal plane of reference from which vertical distances can be measured. An instrument for determining whether a surface is evenly horizontal. From Latin. Can you do that one, Essie? Libella, is it?
Libella.
Libella. Balance. Level. That balance thing, I think, is the key.
Right. So
this is normally where certain model afflicted people come to a bit of a halt. Let's say.
Right. So basically, you're saying that a straight horizontal plane is level at all points.
Yeah, level is a straight line on a horizontal plane. Yes, level is horizontal. Yes, that's what I'm saying.
Right. And see, that's where you get in trouble with the definition. The definitions of horizontal is because in some cases it's used to mean level, and in some cases it's used to mean flat or straight. And so that's where you can prove one definition and then you switch to the other definition and pretend you proved the first one. And obviously, until you can explain this so-called optical phenomena, which you mentioned the other day, which causes the water to appear to drop away from a laser beam at the rate of 8 inches per mile squared, then obviously I can't accept that flat is level at all points.
Nobody said
that. That a straight line or a flat plane is level at all points. It would be level at the tangent point.
Whoa. Okay. Time out. Calm the mind. Let's have a breath. We just say there's no mention of flat in this at all. Just a level is a tool for establishing a horizontal plane of reference. Which it is. Right?
I'm going to go with saying that a level is a tool for establishing perpendicular to plumb.
Okay, well that's the next one, perpendicular. So that's a straight line, because we've just dealt with perpendicular. Perpendicular is two straight lines, and as we've just done, plumb, vertical, perpendicular to it, horizontal. Boom. Yeah?
Say it again.
You said perpendicular to plumb.
Yes, level is perpendicular to plumb.
Okay, now, perpendicular, as we went over a little bit earlier, is two straight lines. And if
perpendicular
plumb is a straight line, a vertical, which we just agreed to, a straight line, perpendicular to that would be another straight line at right angles. Now you just said level is perpendicular to plumb. So level is that straight line that is at right angles to the vertical. Therefore, horizontal.
See, you're assuming that a straight line of significant length is level at all points along that straight line.
No, I'm just assuming, like you said, perpendicular. That's all. We went over perpendicular and what perpendicular was earlier. Two straight lines. You just said level was a straight line.
No, I said level was perpendicular to plumb.
Yeah, you just said it again. It's a straight line.
No, that's you saying it.
No. You said perpendicular.
To plumb. No, perpendicular is a straight line.
Mm-hmm. And plumb is a straight line.
But level is not a straight line.
Well, why did you just say it was perpendicular to plumb? You just said that.
Well, level being perpendicular to plumb does not mean that level has to be a straight line just because plumb is a straight line.
But go back over perpendicular.
If it's perpendicular, it is.
That Glober is crazy.
Straight line is perpendicular or at right angles to a plane when it makes right angles with every straight line meeting it in that plane. Perpendicular, when a straight line standing on another straight line makes the adjacent angles equal to one another. Each of the angles is called a right angle, and the straight line which stands on the other is called perpendicular to it. Two straight lines. So can we at least agree that it's a straight line? Level is a straight line, whether you think it's horizontal or not. But I mean,
well, I will agree that a straight line can be level at one point.
Okay, like the vertical and horizontal being perpendicular.
See, you started out with this rectangular coordinate system with no concept of the direction of down. But see, now you're working in the direction of down, which is outside of that rectangular coordinate system.
No, it's plumb. We just did it. Vertical. We just went over that. That was the last one. We did just go over that. Plumb bobs. Plumb bobs. You agree
anyway,
the vertical is a straight line. And then we've got here, now you've said level is perpendicular to that plumb, and that's a straight line. And perpendicular is a straight line, so level must be a straight line. Level is a straight line on a horizontal plane.
I'm sorry, that does not logically follow.
Well, it doesn't logically follow. You've just said it was perpendicular. Go on, try again then. See if you can convince us.
The best you're going to get from me is that a straight line can at most be level at one location, and a plane, a flat plane, can only be level at most at one point, and that's the tangent point.
Well, when I buy a level, a tool, I know that all of the points along it are level. Not just one point, all of them.
You don't know that. You assume it, but you don't know it. How do you know it?
It's a level, I bought it.
I mean, obviously, it's within a very, very small error, but you don't know that it's actually level. You don't know that if you were to somehow measure level at different angles with an infinitely sensitive instrument, you wouldn't find out that they were actually at different angles slightly.
What was at different angles? The perpendiculars.
Let's say your level was 1 mile long. Okay.
Okay. Like let's say like a water level, like a canal.
Well,
let's say we've got a stretch of canal 1 mile long with a lock at one end and a lock at the other, right? A water level. No.
I'm talking about a bubble level, a carpenter's bubble level, like you got in the
1 mile
picture there.
long carpenter's bubble level.
Yes. Well, I don't care. We can make it 2 kilometers for you.
You'd be better off with a water level. It'd be a bit more practical. Are you sure you don't want to go with the water level?
Well, we're going to go with both of them.
I am trying to sell the water level. I quite like water levels. But go on, carry on.
So if you had a 1 mile long carpenter's level that was straight, you don't know that it's actually level along the whole length of it. You might suspend that above a canal and find that the canal actually curves compared to the level. So obviously, if there's an angle difference at the ends of your 1 mile long carpenter's level, then how can it be level at the ends?
The water curve, would it drop away?
What if it does?
The water. The water drop.
Right, that's what my observations That's what my observations seem to be telling me that. And the best answer you have to that is there must be some optical phenomena, even though you have no evidence that there is or that it would act like that.
So do you think then, if you were to put that level out, the water would drop away from it?
That's what my observations are telling me would probably happen.
You know how? Do you know how water flows?
I don't think he knows what drop
That's
is.
what I just typed. Wouldn't the water be flowing?
Oh, don't give it away. Do you know how water flows, Jesse?
I'm talking about stationary water, non-flowing water.
Yeah, but you just said there's a drop. How could it be stationary and have a drop in the distance?
Well, I said a drop compared to your 1 mile long carpenter's ruler.
A straight one?
Correct.
Like a measured vertical drop?
If you were to set a rectangular coordinate system on the surface of a sphere...
No, just the side of the canal. We've just put a level along, and we've got the water that you say there's a drop. Would you be able to measure that on that vertical datum?
Compared to a rectangular datum?
No, compared to the level that you've just put out, that's a straight line, and then you said the water drops. Would you be able to measure that difference between the level that you put there, the one that you made, the 1 mile long level, and the water that you said would drop away from it? Can we measure it?
I believe we could. Obviously, I don't have a rigid 1 mile long ruler, so I'm using other things. But as far as I can tell, we would be able to measure a 2-inch drop at each end of that 1 mile long ruler.
Sorry, a 2-inch drop at either end.
Correct. If the center of the 1 mile ruler is sitting right on the water surface, not above, not below, just skimming, just touching it, then I'm saying it looks like we would measure a 2-inch drop of the water at each end of the ruler.
What about if you were at one end? What about if you start your ruler at one end?
And had the ruler level?
Yeah. I thought that's what we were doing anyway.
Well, I'm saying
Can you put it at one end?
The ruler is level in the middle, but if we move the bubble on the bubble vial to the one end of your mile long ruler, or your mile long level, and you level your ruler at that one end, then the other end would be 8 inches above the water surface.
Okay. Can we move the bubble to the other end?
Yep.
What would happen then?
And if we re-leveled it, so it was level at that end, then that would become the tangent point, and then the other end would be 8 inches above the water, or the water would be 8 inches below it, whichever way you like.
Wow, double drop and a fucking hump. Well done. You started with a hump and then you did a double drop. The nutsacks.
Where did the tangent come from?
That was good, that, wasn't it? Has anyone ever seen it that quick? Hump.
No, you got to double drop pretty quick.
Nutsack. No, he started off with the hump.
Yeah, he had the two inches, and he went to the no, it's 8 inches.
8
both
and
ways.
8 double nutsack. That was fucking quick work. That we're getting good at this. I take a bow. Do you not think that's fantastic, Jesse? Or I do. I think the mind tricks that your brain just did then, whether you were aware of it or not, fantastic.
I'm not sure what mind tricks you're talking about.
No, I think you did it to yourself. You started off with a hump, right? And then you went to the other end of the same stretch of water and you had an 8-inch drop. And then you went to the other end and you had another 8-inch drop at the other end.
What's the problem with that?
It's impossible. You live in
Why is that?
Fantasyland?
I know you believe that's impossible, but how can you demonstrate to me that that's impossible?
Because the water level is obviously horizontal.
Oh, self-evident.
No. There's tests you can do.
Oh, the carpenter's water level.
No, that was your test. The carpenter's water level. You just did a big mile-long stick and moved the bubble.
Oh, that's what
that's
I'm
all
telling
you did. All you did was move the bubble. I didn't hear you move the level at all. You just moved the bubble.
No, you weren't listening. I very clearly said we move the bubble and re-level it at that end where you move the bubble to.
It's the same level.
Mm-hmm. It's the same water.
But when you level a carpenter's level, the bubble level vial is in a position, and that's the position that you're actually leveling.
No, you're leveling. You know how to extend, how to make a longer level.
I use a 2x4, straight one.
Yeah, just get a straight edge. Any straight edge, as long as you want, and put the level on it. Hey presto. Longer straight edge. Pretty much like LIGO. You know, if I would say if you had LIGO and that was 2.5 miles long, that would be your straight edge. You'd just be able to put the bubble level on it. Anywhere. Won't change. But that's just me, you know, my understanding of it.
Well, I don't know
how
how
we go out and make any extravagant claims of level. So what do you say then?
I say that a straight line or a flat plane will at most be level at one point, and that is the tangent point.
Okay. So how would you reword this statement? Level is a straight line on a horizontal plane. How would you have a go at rewording that?
I would say that level is perpendicular to plumb.
Straight line.
And plumb is a straight line.
Yeah. And well, it's a horizontal plane then, right? It's basically, a horizontal plane of reference.
No.
Yeah, perpendicular. Well, plumb is like a straight line. So that means 90 degrees to that line is like completely all the way round. It's a plane. That's why horizontal is a plane established from that one vertical. That is in reality how you establish a horizontal plane, isn't it? That's why horizontal planes are always perpendicular to vertical. Not because mathematics or, you know, like just because it's wrote down in a book. It's just because it literally is. That's why they wrote it down like that, because horizontal and vertical have this relationship of perpendicularity.
See, and that's the definition where you're saying horizontal is level, but if the Earth was curved, then that would require horizontal to be curved, right?
Sorry? Horizontal
You just said,
isn't curved. I didn't say that.
But what if not all plumbs are parallel? Then horizontal, if horizontal is level at all points, then horizontal could not be flat. It could not be a plane. It wouldn't be a plane unless it's flat, right?
Well, that's what horizontal is. It's perpendicular to vertical.
Well, your definition is not working with the reality that I'm observing when I go out and measure the deviation between the path of light and the path of water surface.
Okay, so what would you call it? Horizontal then? Can you...
Like I said, it's a word that's been used by a lot of people for a lot of things to mean a lot of different and sometimes contradictory things. And
what, horizontal?
Yeah, one definition says horizontal is a plane.
Mm-hmm.
And another definition says horizontal is level at all points.
Yeah.
And my observations are showing me that level and a plane are not the same thing. A plane is not level at all points, according to my observations. So we're not going to get past this until you can show me how my measurements aren't showing me that the Earth has non-parallel plumbs.
What
if that makes
measurements
sense.
have you got?
Well, I've measured the water drop from distances of from 1.5 miles to 105 miles.
You mean an angle? You've measured an angle.
Never mind how I measured it. I measured it.
Is it an angle that you have measured?
Look, you don't understand how angles actually could
Jesse,
measure height.
Please don't answer whether you don't understand. Is it an angle that you, Jesse, have measured when you say you've measured something?
I used angles in the process of some of my measurements, but not all of them.
Okay. The angle being measured from an uncalibrated tool.
Well, that last measurement I made was just a telescope looking at two lights that are in the telescope, and the lights were all exactly 48 inches above the surface of the water.
Okay. Is this because you're struggling with the horizontal? It's just we were at level is a straight line on the horizontal plane, but you seem to want to redefine. Is it the level or the horizontal plane that you want to change? Is it just the horizontal? So could we say level is a straight line on a plane? Would that be okay?
No, level is perpendicular to plumb. And
which would make it at least a straight line. But because of the relationship of vertical and horizontal, that would make it a perpendicular to a plane.
No, a straight line can be level at most one point, and that's the tangent point.
Which straight line? We're talking about vertical. We're talking about the plumb bob.
No, a horizontal straight line can be level at most at one point, which is the tangent point.
What tangent point? It's just perpendicular, right?
Well, it's only going to be perpendicular to plumb at one point, according to my observations.
What's only perpendicular to plumb at one point? Because you do realise that perpendicular is the relationship of one straight line to another straight line. So, where's your point? What you talking about? I'm missing it.
That
Isn't
you are.
A point on a vertical is just a vertical datum.
Yeah, like an elevation.
So can we just go with level is perpendicular to plumb?
Yeah.
And
sort of what we were saying anyway.
And a straight line and a plane can be level at most at one point. And
every point.
I can't agree to that. My observations tell me that is not true.
Every point is perpendicular to, like you said that earlier.
No, I didn't.
What, that everywhere you were, vertical and horizontal are perpendicular.
Oh, for different observers or at different locations. With
wherever you are, you Jesse, wherever you are. You can have that plumb bob And you can walk along and there will always be perpendicular to it. Wherever point you are at. Always. Anywhere. And perpendicular to that straight line will be another straight line. Since you've got a plumb bob that establishes a vertical, perpendicular to that is a horizontal plane.
No, that's what I'm saying, is as you travel with that plumb bob, it becomes out of parallel to its original starting angle. And so as you travel, perpendicular to that plumb bob is forming a curve, not a straight line.
Oh, no, perpendicular is a straight line, though.
Perpendicular is an angle. Perpendicular is 90-90.
Yeah, but those
Plumb
two
is a
straight
straight
lines that make the 90, because in order to make an angle, you need two straight lines. Jesse.
I don't know. You could have the angle with respect to a curved line, a curve. I mean, if it butted up to a curved line, like if you balance a toothpick vertically on a
curved
soccer
line?
ball.
Where's this curved line coming from?
Well, I'm telling you, when I measure the height of water or the height of
On
the
vertical
flashlights.
datum.
So I had those two flashlights at exactly the same height. Imagine that was a flat, level, horizontal plane. I had two flashlights right at that plane and the camera right at that plane. The light goes in a straight line from the camera, or from the flashlight to the camera, and it goes in a straight line from the other flashlight into the camera. How could one of those lights, which is on the exact same flat plane that the camera is, and the other light, how could the one light appear drastically higher, even though it's on that same flat plane?
Is this a Cogdis reaction?
No, it's until you understand that, you're not going to be able to sell me on this claim that level.
So it was the level bit that you stopped at. Is this your bridge?
Well, you're saying that
strange, isn't it? It's level.
That all points of a straight line will be level. A straight horizontal line will be level. And my observation is that that's just not true. Unless you can show me a demonstrable phenomena which is causing light to somehow bend in a way that causes that one flashlight to appear higher than the other.
So we come to a stall here for level. You're unable to have level as being a straight line on a horizontal plane, but you want level to be perpendicular to plumb. And just so happens that perpendicular to plumb is a horizontal plane. And earlier on we went over the definition of perpendicular to a plane, and that seems to be the fitting of a perpendicular plumb to a horizontal plane. It's tough, I know.
Well, you can have a horizontal plane that is perpendicular to plumb at one point. But according to my own observations, if you leave that plane in place and then deviate from that point of the plumb and hang another plumb, it won't be exactly perpendicular to that flat plane. So how can you say that it's level at all places if it's not perpendicular to plumb at all places?
It is. You said it's perpendicular. The geometric implications of perpendicular. Don't think you understand. And when I say that, I really, truly mean I don't think you understand what perpendicular is, or the geometric proofs around it, surrounding it.
But see, all the geometric proofs in the world and all the fancy definitions don't change the fact that I look out at two flashlights that are exactly both at the same height as my eye. They should be on the same flat level plane, and one of them appears significantly higher than the other. As long as you are skirting around observable reality, we aren't going to be able to move any farther on here with a claim that you're a nice guy. You know what? I really like interacting with you, but I gotta tell you, I can't just disregard what I've seen with my own eyes just because you say so, right?
But dude, we're going over the basics just as an understanding, and yeah, we've not got to the end of it, and this is literally to sort of show how easily it is to communicate through geometry and an understanding, practical understanding of how the space is described in reality. That's as far as I'm going with this. That was my idea of doing this. So what would you say the definition should be? But you have just said that level is perpendicular to plumb.
Yes, level is perpendicular to plumb.
But which actually says that level is a straight line on a horizontal plane. It's the same thing. They are identical. It's just that I used a few more words.
Well, let's see. How could we move on? Obviously, I can't agree that a straight line could be level at multiple locations because my observations aren't working with that just yet. Could we... maybe this will work. I will agree that a 1 inch long straight line, or a 1 inch long horizontal line, is, with my equipment, indistinguishable from being level at all locations. Does that make sense?
Are you sure? 1 inch?
Yeah.
Right.
Yeah,
so you could definitely tell with 1 inch. You could have like a half-inch shared straight line segment, and we could then extend it to like 1.5 inch. And we could probably do that indefinitely in every direction, and therefore end up with an infinite horizontal plane, exactly like we started off with. Yeah.
No, I'm saying if you'll let me, if you'll let me go with saying that a 1 inch flat horizontal straight line.
Why do you only want an inch?
Well, because I have no way to measure whether or not any point on that is not level. Okay, we can say for the sake of discussion that a 1 inch long horizontal straight line.
You ever heard of a water level?
But see, we can't use the shape of water to measure the shape of water. That's circular.
We're not measuring the shape of water. We're just trying to establish what level is. And even though you seem to be saying it is perpendicular to plumb, which means exactly the same as level is a straight line on a horizontal plane, exactly the same thing.
Well, that's where we're at. I'm not going to agree to an infinite length horizontal line being level at more than one point, but I will agree to, for all practical purposes, a 1 inch long horizontal line being level along its full length.
Okay.
So far as
I think we're done with this then, Jesse. I don't think we're going to get past this. I think you have hit your particular bridge.
Yeah, observable reality is a bugger, isn't it?
No, not really.
Well, yeah, but I observed those two lights.
Understanding of what that is, it isn't difficult at all.
I personally observed these two lights.
I tried. I got all right, didn't I? How far did we get through?
Now you did a good job, Bev.
Okay, clean up. So, if anybody else wants to come through, I mean, there's not much reason for me to try and explain the test to you, Jesse, if you're struggling to understand the basic concepts of how we actually understand our reality.
Yeah, unfortunately, your understanding doesn't explain observable reality. And that's what I'm dealing with, right?
What, the vertical and horizontal, perpendicular?
Yeah, but, I mean, these two flashlights...
That is obviously observable reality.
Well, that's a construct, actually.
What, vertical
a human
and horizontal?
construct.
Horizontal and vertical are observable in reality.
So then these two flashlights and my camera were all on the same horizontal plane, right?
I don't know, Jesse. It's your test.
Well, let's just say...
all you've done is just come with some pictures. I mean, you cannot agree that perpendicular to plumb is the relationship of two straight lines to one another. Those straight lines being vertical and horizontal. You struggle with that. There's a block somewhere. Something that happens.
Yeah, I saw those lights that were both 48 inches above the water appearing at different heights.
I think it's more to do with a model myself.
Well, let's say a person did do this experiment, and that is what they saw, because I did, and it is. Why does that have to be model affliction? Why can't that just be me doing an observation?
The problem is that we were talking about level being perpendicular to plumb. And your diversion has gone to some lights that you've seen. Rather than you face the level being perpendicular to plumb.
So when I look straight at the firelight, we can agree that that was a level. If I drew a line, that would be a level line, right? Straight from one end to the other light at the other end, right? And then, but if I wanted to look straight at the middle light, then I have to look up. So which one is level? Which one is a level path? From me looking at the far light that's at my same height, or me looking at the closer light that's the same height? See, they're not the same level. Which is level? See, you see the paradox there?
You have a paradox. No way. How did you get that one? Explain it to us again, please. I was just making a brew for myself. Please explain the paradox. I missed it. I like paradoxes.
Hey, I actually drank a quart of water while we were talking, and there's some consequences for that, and I'll be right back.
Okay. You did just say you had a paradox, right, guys?
Yes, he did. He said that these lights, if he would draw the straight line between these two lights, and he would put some third light in the middle of them.
Higher.
If it were on a level, I think it would be higher.
Yeah,
so
higher,
he's creating hump in the air, I think.
Yeah.
Maybe I am wrong.
He started off with the hump before when we were doing the original straight line thing. He starts off with the hump every time.
And by the way, he didn't notice that you cannot have perpendicular to curve because you cannot have the two 90-degree angles then.
Mm-hmm. He knows that. He said it's perpendicular to plumb. Level is perpendicular to plumb. That most people will say that. It's a mind trick. Something happens in the mind where perpendicular stops being perpendicular, but they can still keep it as perpendicular. Model affliction.
Yes, but he said that he can measure angles, but if he realizes that he can measure angle, so he should realize that you cannot measure angle on curved surface.
I'm back.
Okie dokie. Making me brew.
So is that like a coffee brew, or is that like a craft brew?
No, a cup of tea.
Oh, wonderful.
So, can you explain the paradox that you have? Please.
Yeah, let me try. Well, so I guess it's about the two flashlights that were 48 inches above the lake, 1.22 meters above the lake, and the observer, the camera, that also was. When I point the camera straight dead at the far light, we would agree that that line formed between that light and that camera is a straight horizontal level line, right? Both ends are the same height above the water.
Oh,
and it's
can
straight
we assume that we've got a professional surveyor with fully calibrated equipment, and these are all on the same? Are we going to say elevation?
There's no surveyor and no surveyor equipment in this thought experiment. It's just
the same
an
altitude.
Observer, the same, exact same 48 inches above the surface of a calm lake. Calm, non-moving lake.
All at an even altitude.
Yes, 48 inches above the surface of the water. The observer and the far light are exactly 48 inches above the surface of the water.
Okay, I've got it. I've got a mental picture of that, yes.
Okay, perfect. That would form a straight, level, flat, horizontal line, right?
Well, if it's a line, I don't know whether you'd want to be calling it flat. You might be showing your model affliction there, but it's just a straight line.
Well, flat is straight, or straight is flat.
Straight line is just a straight line, though. There's no need to over-embellish it.
Okay, a straight line.
Yeah.
All right. Then, let's say we place another flashlight halfway between, and it's also exactly 48 inches above.
On that straight line.
Yes. Or could we move it over just to like 50 millimeters so that it doesn't block the first light?
Hey, it's your test.
Okay. So we place another light right in the middle, but also 48 inches above the water, just like the observer and just like the first flashlight. Now the observer notices that we'll see that second middle light will actually be significantly higher in his view than the first one. So he points his binoculars up a little bit to look straight at the middle light. So, but the middle light is also 48 inches above the water, as is the observer. So that line would also be a straight horizontal level line, right?
Don't know you got what you binoculars.
Would it like a
or are you just using those measurements that you've made? If you want to establish a horizontal, I think I'm pretty sure I told you this the other day. I'd, if I were you, preferably use a tool for establishing a horizontal, not a ruler for measuring vertical.
But would a straight line between the observer and the middle light be level and horizontal?
Geometrically, are you drawing it? Because that's all I'm doing. Like, I really think they're really geometrically. So you're saying you've got 48 inches vertical. 3. Yeah?
3 points, all 48 inches above the surface of a calm, stationary lake.
Okay. So that's a straight line. And then 48 inches going up vertically.
Correct.
Yeah, I say, like, geometrically drawing it, I'm pretty sure everybody else can do that too. But what is it that you're saying?
So the fact is that the observer will have to look up a little to be looking straight at that second flashlight that we put in the middle.
I thought you said it's on the water.
What's that?
You said it's on the water.
They're all 48 inches above the water.
Right, okay, and you say one of them has to look up.
The middle light appears slightly higher, significantly,
Higher?
but slightly higher than the distant light. Yes.
Higher.
Yes. That's the picture I
Are you
showed.
saying, yeah. So the center, the water in the center is higher.
Well, that's what it looks like. I'm not sure what else would make that flashlight higher.
How does but not the water. How the water can't go up, can it? I've never heard of that before.
Well,
is that a globe thing?
You having never heard of it before doesn't really make it not so, of course. But if
so the water is going up.
It must be. That's the way you said you have to look up. Water doesn't do that.
You think the water's going up?
Well, I mean, I placed a flashlight 48 inches above the water in the middle of the run, and it appears higher. So you tell me how it appears higher. How can
it can't actually be higher because water doesn't do that, right?
How can light in the distance appear to do something? Are you really asking that question?
Yeah. Sorry.
Over water? Over water. You're not really asking.
Appear, and he still doesn't get it. He keeps saying appear.
Sugar cookie, you sound like dead low.
I put a light over water at distance, low level, and it appeared to do something that... What? Please say that again.
That again.
Yeah, he's going for the hump.
I know you got to get there.
At least an optical hump.
You could make that argument.
Would you commit to saying at least you're going for the optical hump?
Well, I would need some evidence that there is an optical hump.
Would you be assuming that the two lights at either end were level and the other bit was higher, was also level? And when you have the two, one at each end, is that like level or is that like dropping down like you said earlier?
I'm not sure I'm following your question.
Well, earlier you said that the water drops away from the horizontal. So where would you put the horizontal in relation to those lights that you've got there? Because you said the middle one's higher. Would that make the horizontal across the other two?
Well, I think that's what I'm asking is if they're all on the same plane, a line between any two of them should be level and horizontal, and yet they're at different angles. And so how can two different angles?
You can't be doing this for horizontal, right? All you've done is measured 48 inches vertically. You can't be seriously considering this as a test for horizontal, can you?
Well, a line between any 2 points which are equal height above the water, that line should be horizontal and level, right?
Is that what you're doing? You're getting some lights and you're measuring 48 inches and you're doing a test for horizontal?
Is that an argument from incredulity?
No, I'm trying to work out what exactly it is that you're doing.
I'm showing that horizontal and level and flat or straight are not all the same thing.
Horizontal and level and flat and straight are not the same thing. Well, like I said earlier, straight and flat aren't the same thing. Right? Definitely.
Right, but...
Okay, so that's that one sorted. What about horizontal and level? And straight, actually. Horizontal, level and straight. We can say horizontal and straight. They are the same thing, aren't they?
Horizontal has two common usages, one of which is straight but not level except at one point, and the other is level at all points but not straight.
What, level at all points but not straight? Horizontal is straight, right? Did you say it's not straight?
Could we avoid using the word horizontal? Are there other words we could use?
No, vertical and horizontal are the reference frames we have to deal with. We are not taking horizontal off the table. But did you just say it can be straight and not straight? That's definitely something that needs to be looked at.
There's two different definitions. There's two different usages for the same word. Believe it or not.
Go on, give us definition. Give us definition 1, please.
Can I try to add something here? If what
no,
he's
no,
saying
wait,
is,
no, please,
just for clarity,
no,
just for clarity.
please.
Okay.
Jesse, definition 1 for horizontal, please.
From what dictionary?
Well, the one that you just said just then.
I don't know where all the definitions are. I just know I've seen people using it to mean a lot of different things.
Okay, so what was definition 1 that you just gave us? I didn't catch it.
I'm not defining it. You're the one that needs to define it, but you're the one that's using it.
You said one was straight, and then one was not straight. What was the defining factors that made one horizontal straight and one horizontal not straight? What was that? I missed it.
May I?
Please.
Okay, so when we say that horizontal is parallel to a person's horizon at a certain location on Earth, then we're not saying that that horizon is parallel to the horizon of somebody somewhere else on Earth. That horizon would curve, it would change angle depending on where you were, compared to someone else's horizon at another location. And in that case, we're saying horizontal is level, not necessarily flat. And the other usage is like they used it for the LIGO thing, where they said horizontal is flat, but it's only level at one place.
Which one's the one that's not straight? Which is the horizontal that's not straight?
The one that's parallel to the observer's horizon.
But parallel is straight lines, right?
Okay.
So the one you're saying, the one that's not straight is the one that is defined as being straight. That seems a little bit contradictory too.
Yeah, it's a word that's has very inconcrete meanings, and that's why that's the one word that you build your entire argument off of, because you can shift its meaning kind of back and forth and in and out and up and down, trying to prove one definition and then switch over to the other definition and use it in a way it's not.
Who has? I only have one definition of horizontal, definitely. And I also only have one definition of level. They are both exactly the same in my definitions. Like, I'm not confused. I don't swap and change at all. Seems like you do, though. You seem to have two different definitions of horizontal somehow.
Well, see, you're grouping them into one and making the false assumption that certain observable reality doesn't exist. When we try to look at these lights over the lake, we have to realize that horizontal and straight and level aren't all the same thing.
How are they different?
Well, so back to the 3 points above the lake that are 48 inches above the lake. If you drew a line between a straight line between any two of those points, that would be a straight line. In your assumed reality,
Jesse, you sound confused. Are you sure you want to be trying to do this? You sound like you're just trying to make it up, freestyle it. And I'm not too sure it's coming off. Is anybody else having any of this?
Of course they don't.
Yeah, I mean, I posted a quick video in chat just for you, Jesse, and I think it might. I don't know if it will help you, but it might. So, and it's actually a video that Bev posted a while back.
Okay, what was the timestamp after the hour on that?
I can't tell.
25.
Okay, I was distracted in VC, obviously. Sorry to all of you who were responding to me in the text, and I was just busy with the VC. I have a one track.
Yeah, just take 45 seconds. There's not really any audio to it.
Okay, yeah. I have a one track mind, and the rare occasion that it tracks.
I posted a screenshot of Axiom 1 earlier. I feel like that may be quite relevant to the discussion right now, personally.
Wow, I had to scroll down a lot to get to the bottom. You guys were busy. Okay, it's downloading. Do I need to hear the audio?
I doubt it.
I don't think so. I think it's just mainly some wind noise and stuff like that.
Okay, cool. Because I have a USB headphone set that actually has the microphone, which I use for Discord, but actual videos play through my analog speakers, so I don't actually hear, when I have my Discord headphones on, I don't hear movie sounds.
I got 3 hours 20-ish, something like that, on the timestamp. I'm gonna have to go back if somebody wants to go and check it. Pretty sure Jesse did a bendizontal. He defined it, I think.
Let's see. So I'm looking at the one from Sugar Cookie at 325, or at something 25, and it's a video 0.mov.
I think that was the first video I ever made, you know. Oh, the first test I ever did.
Okay.
You've got a guy here. Do you know Das Oven?
No.
He's Do you need any help?
I just started watching the video. We've got 2 camera tripods and a builder's level, right?
Yeah. Sugar cookie.
So what am I looking for here, exactly?
There you go, sugar cookie. What's he looking for?
It's cameras sighting past a builder's level on 2 tripods.
Mm.
And it's level according to its little bubble.
In the center.
Right.
Yeah. But that's the only place it's level, is it?
That's what seems to be the case, although I have no way to check for level at that distance, at a couple feet. That would be a very, very small amount of change of level.
Seems to be sighting something through it though, right? Or, past it.
Yeah, looks like it.
What do you reckon that is?
Looks like clouds to me. But there might be a hill in them clouds.
Could it be the horizon over there?
I can't really tell. Is that water out there? Is that a city, or what are we looking at, actually, I guess is my question.
You're looking at the horizon, right? I'm guessing.
It's hard to tell.
Hmm.
The clouds or the horizon or the fog bank, or I don't know.
But I mean, it doesn't really matter, does it? Because it's only level where the bubble is. So looking in the distance doesn't really matter with one of those tools because it's only really level where the bubble is, right?
Well, thanks for the video, Sugar Cookie. It's nice, but I'm not sure what I'm looking for.
Yeah, I wasn't sure if it was actually going to help you, but it should.
May I explain shortly?
I'm all ears.
Yeah, go on, it might help him.
Because if you said that you have 2 lights and in the middle the light would be higher, then you are creating chord line through the earth or water. And on this picture you can see that this horizon is below, slightly below, as it should be. So in your model, this level should dip down to the earth, through the earth, and it doesn't. It disproves your claim about 3 points with hump in the middle.
Oh, not at all. I had to tilt the telescope down slightly to point it straight at that light 3 miles away.
Point it down?
Yeah, I had to point it down.
So it wasn't up then? Why did you say it was up?
I said the middle light appeared higher compared to the far light.
He said the guy had some binoculars and he had to point them up.
higher. First he started out pointing them at the distant light, and then he had to raise them slightly to point them at the near light, the middle light.
Can you draw this for us? Elevation profile.
Well, if I drew something that would cause what I saw, then I would have to draw a curved lake, and you wouldn't like that.
No. If you draw it, then we'll all get an idea, clearer picture of what you're talking about. Can you please draw the elevation profile of what you're talking about, and then we can all get a grip of it? Because I think you said higher with the center one. But if you draw it out, elevation profile, I'll be able to see whether you actually mean higher or not higher. I'm pretty sure that you said look up.
Well, look up from the first light.
See, I said, give us a picture, give us a drawing. Just a quick rough hand sketch.
So you mean just so you know, like, where the lights were in the observer, or...
Yeah, like an elevation profile.
Like a orthographic side view?
Yeah, elevation profile. That's what I call them, I don't know.
So an elevation profile shows the contour of something compared to something. In other words, usually it's the height of land above sea level over a certain path or distance.
Oh, I thought of it. I thought of an idea for you, Jesse, if I could, real quick.
Sure.
In that video of the level and looking at it from one end to the other, can you imagine that each of those ends is a flashlight in your experiment or test or whatever it was? And then does that give you, then at that point, when you look at it from that perspective, does that help?
I'm not sure. To me, it seems makes more sense to do it on a lake where you can measure the height of your 3 points carefully off the surface of the water.
Yeah, I don't know. I can't figure out how to help you.
Yeah, did you see the picture I'm talking about that I took?
With the crosshairs
and the two lights and their reflections in the distance.
Yeah.
Okay. Did you see the one with the telescope leveled?
No.
Okay, it's an awful picture, but it's the best I got. Okay, I tagged you in the text chat. That's with the telescope leveled, like your guy in the video with the level. If you had been sighting past the carpenter's level, that's what you would have seen. You would have seen both lights below the carpenter's level, but the further one quite a bit more below the carpenter's level.
So it's down, it's dropping down.
Yes, but that measurement did use the instrument's ability to level, so you might want to complain about it being not calibrated for that picture.
So what is it you're saying? The middle one is higher?
It appears higher.
Yeah, obviously. Now, do you think that the water in the middle is higher?
Well, that's what I'm asking you guys. If it's not,
absolutely
then what's
not. No, the water level is a horizontal plane. There's no hump. There's no drop. It's horizontal. Now,
so why?
What is it that you think? Now that you've asked us, or asked me particularly, I don't know, you can ask anybody else if you want.
To me, this is pretty good evidence that not all horizontals are parallel.
Hump. Which horizontal in there isn't parallel? What do you mean?
Well, let's say I were to tip the scope down a little bit so the crosshair lined up with the bottom, or with the farthest light at 3.1 miles.
Mm-hmm.
And that should be a horizontal line, a horizontal level line from the observer to that light, or from that light to the observer, since
That
that's
black
the way
line
the
that goes horizontally across the your crosshairs. That's what you're talking, is it? That horizontal?
No, I'm talking about the path taken by the light from the flashlight to the observer. The starting and the ending point are both 48 inches above the water, and so that would be a straight horizontal line, right?
So if you put that black line, the one that's horizontal, the crosshair, over the light that you're talking about, then you would have a horizontal there, right?
We would have established a horizontal from the observer straight to that light.
And then we could move it to the other light.
Right, and then
then that would have that horizontal.
Right, so we've got two horizontals
that they would both
that
be
are not
parallel. No, they would definitely be parallel. On the screen as well, the crosshair, it always will be parallel, right? One position of the crosshair and the next position of the crosshair will make those two crosshairs parallel.
Oh, you mean in the picture?
Yes.
On the screen?
Yes.
Yeah, that's of course, but that's not what I'm talking about. That's just a visual effect in the scope. It wouldn't need that there. You could just point straight at one light or the other light. But the point is, how can both of those lines from the observer to the far light and the observer to the near light, how can they both be level if they're at a different slope?
Are you saying you've got horizontals at different slopes? That's what your conclusion is?
That's what it looks like to me.
Reductio ad absurdum.
I mean, have you got another explanation?
That is a reductio ad absurdum, that right?
I'm not going to agree to that.
Horizontals that are sloping differently.
See, I told you it's a paradox. Either they're not sloping, or they're not horizontals, huh? Or they're not level.
Or you're just looking at lights through a telescope.
You do realize you just agreed to the crosshair in the picture. When you move it, they're still parallel.
Well, of course they're still parallel, but that's on a different axis. That's irrelevant. I'm talking about the line.
On a different horizontal axis. Is it? What are you talking about?
Yeah, you're just doing red herrings now.
Don't think so.
The point is, the crosshairs don't even need to be there for this. They just happen to be. But you could just look with a no crosshair telescope straight at the lower light, and you're not looking at the upper light. You have to move the telescope up to look straight at the apparently upper light. And yet, they're both at the same level above the lake.
So the crosshair that you don't need to be there, we're looking at because you need it there.
No, it's just there. I could have used a camera that didn't have it, and we wouldn't be talking about this red herring. But the problem would still be the same. Those two lights still appear at different heights when they're not at different heights, unless horizontals are not all parallel.
They're not at different heights though, because you said you measured them the same height above the water.
Right, they're the same height above the water.
All horizontals are parallel though, right?
I'm not agreeing to that.
Obviously. But I mean, geometrically, it is provable that they are. At least geometrically, right? Within mathematics.
Hold on a sec.
Am I in the? I don't know. It is my birthday. So
Oh, happy
somebody
birthday.
paid some dude to come round here and take the piss.
Happy birthday, Bev.
Thank you.
I'd sing you happy birthday, but I don't think anyone wants to hear that.
Yeah, thank you. Other people have already, so I've already heard it too many times. So, but thank you.
Nice.
That's why I missed here in voice only wrote in the chat to not disturb with that.
Thank you. This paradox thing is a bit too much, I think. I should have gone over the cog disc bit at the beginning, shouldn't I, with Jesse? I didn't realise how powerful it is.
Yeah, I forgot about that one. That was a good presentation.
Well, so I'm not sure where we go from there, Bev, but thank you.
Well, I can't even remember what I was saying, but I was asking you a question, and it appears that you've gone away from that.
Well,
go on. Sorry.
Oh, it's okay. At the end of the day, the lights should appear at the same height if they're on the same plane as the observer, and they don't appear at the same height. So that either means the water isn't straight, or the light isn't straight, or some heretofore undiscovered fact of reality. And so far, no one has been able to show me a demonstrable phenomena which would cause light to do this to me. So I think it's reasonable of me to consider that perhaps the water isn't straight until further evidence comes forth. How's that?
You think there's a drop to the water? I know. I got that.
There's some deviation between the water and the light.
You did say there was a hump as well at one point.
I mean, that just depends on how you look at it. It's the same thing with a basketball.
Well, that's a paradox. That's obviously, that shows. You've got a paradox. And it's a bit hard to resolve it, isn't it?
And kudos for spotting it yourself, you know?
Mm-hmm. Yeah.
It's hard for someone who denies a curve to resolve it. For those who think the Earth is curved, it's no problem. So it's a paradox for you.
Say that again.
Was that a reversal?
No, it was a paradox for you the whole time.
Don't think so. But like I say, we've just said horizontal. Where is the paradox? You just tried to hand off your paradox, haven't you?
Well, the paradox for you is that the straight line path between the observer and light A and the observer and light B, those two paths are not vertically parallel to each other. Otherwise, they wouldn't appear at different heights.
You're not even making coherent sense anymore. The vertical. The lights look at a different vertical.
Yes. How can one light appear higher than another light when both lights and the observer are on the same flat level plane? That is your paradox. You're saying they can, but you don't know why. And I'm saying I've got no explanation as to how they could be, and that it probably indicates that the water is curved, or at least that not all horizontals are parallel, and that not all plumbs are parallel.
Dude, you've got a picture of some light. That's it. In case anybody's wondering what we're talking about. It's these. Some lights. From this picture, you've decided that horizontals aren't parallel, or verticals aren't parallel. Like, what is it you're getting from this picture of some lights?
Well, I think it's pretty reasonable to conclude that horizontals are not parallel. And if horizontals
from
are
this
not,
one picture, from, well, maybe multiple other pictures, but please explain to us, or to the people listening, how we conclude that horizontals aren't parallel from this picture.
well, very simple. Because a line drawn between 2 points of equal height above the water, you're saying, is a horizontal line, correct? And so we have two flashlights at different distances. So if we draw a straight path from the far light to the observer and a straight path from the near light to the observer, according to your understanding, those two paths would both be level and horizontal because all endpoints involved are exactly 48 inches above the water. But it's clear...
Jesse, please don't speak of my understanding. Just speak of your own. I'm not so sure we're on the same path, let's say.
Well, how can I debunk your claims if I can't reference your claims?
What claims?
Optics are weird, dude.
What claims, Jesse?
You're claiming that all horizontals are parallel?
Well, we were going over the level, you know, the way to get there, but you got stumped at level. But even though you said it was perpendicular to plumb, which means it is a straight line on a horizontal plane, you couldn't understand. So if you don't understand what level is or a horizontal plane is, how are you meant to understand how they can be parallel to each other? Because we got to level and then you had a sort of a cogdice moment and you started pointing out that you've took a picture of some lights in order to explain level. But then it's developed into you proving with this picture that horizontals aren't parallel. Debunking mathematics of some sort. I don't know how you managed to do that, but I mean, bravo. Bravo.
Thank you. Thank you.
I'm sure you'll go down in history, Jesse. On my birthday, too. Stealing my limelight.
Oh, I'm so sorry, Bev. You should have said something earlier. I would have baked you a cake or something. Of course, I would have had to eat it.
Don't lie to him like that. It's his birthday.
Skeptical got me cake sorted anyway, thank you very much. And he actually did bake me a cake.
Yeah, not a theodolite cake either.
And he honoured me by letting his family eat my birthday cake. Does it trouble you, Jesse, that horizontals are parallel?
It doesn't. It does not trouble me that a horizontal is parallel to another horizontal at the same location on Earth. But my observations make it very difficult to accept that a horizontal in one location is parallel to a horizontal in another location, unless horizontal is not straight.
You just keep saying the same shit over and over.
Did you say horizontal is not straight again?
That was some words in my sentence, but it was not my whole sentence, nor was it the meaning of my sentence.
You said unless.
Well, sir, I think you're just quote mining me now, which is fine, but do you think we're going to move forward more on this, or are we just stuck in a little circle now?
Don't know. I think you hit your bridge ages ago. Level it was.
Well, we got a good distance after I hit my bridge, though.
Yeah, destruction.
I don't think we did, actually. Where did we get to?
Well, we did get to something that I've been wanting to get to for several days now, and that is looking at a good example of what very well may be water dropping away from level, from a straight level horizon that's level at the observer's location, dropping away from a straight line. And we had a good opportunity for all of you to help me understand how it's possible to see this. And there was nothing.
Rumpus is your man.
Well, yeah, he's just going to say it's curved. How does that help?
No, because he's got a test. Dropping. That's what you're after, isn't it? Water dropping in the distance.
I think what's he shooting? 6 miles?
Yeah. He's your man. Get him, get on his team. He's doing a video presentation. He's going to have cameras all over the place.
He's actually supposed to be using an auto level, which is not an angle measuring device.
Yeah. You'd be right on that.
Is he taking that to the Bedford? Wish I could be there.
He's even got a Dark Shark. A little water level sighting thing. Like you have. You might be able to have a word with him. Get on the team. You can tell him how to do that Dark Shark with a little water level.
What precisely is a Dark Shark?
It's when you use a water level as a sighting tool.
Yeah, when you line up the two ends of a water level and show that the horizontal is parallel with the water level horizontal.
Oh, so are you sighting across the ends, or are you looking at it from the side, the orthographic view?
You just look at it, don't you? You get a water level, and you look at one end from the other end. We did a few. Oh, there you go. There's the classic. A normal one. And the Solaris.
Oh, thank you.
It does say tubing and water not included. You have to get your own water level. I was thinking of doing like a mini one, like you could get it and just put it on your finger. Like a little gun sight on your finger. Do you like that?
Alrighty then. I am gonna see if I can catch up with some of these critics here in the text chat.
Well, have fun. And
thank you.
I hope you've enjoyed yourself today.
Absolutely. Thank you very much.
Yeah.
I hope I wasn't too much of a pain.
Thanks for coming. And I guess everybody, it's free for all Friday, so take it away for a bit. I want to eat some crisps and make myself a brew. What do you think about tonight? I don't know. I would say it's getting close to Alice in Wonderland, isn't it? In fact, not close, but...
Yeah, I mean...
I think we're in and we bought property.
Yeah, you know something is straight because you've measured it straight, but then you look at it and it looks funny. It appears not. Or level, I should say. Appears not. Appears, appears.
I am struggling with these lights because the first light was like 1.5 miles, and the second light was like 3 miles. So, with my understanding of perspective, if you have two objects on the same elevation and one is farther than previous, this one which is closer to you should be higher, visibly higher, because it is going down, for example, to horizon. So I cannot see any problem here, because the farther you see on the same elevation, the lower it is closer to horizon. It means it is going down in perspective. So I cannot see any problem here.
We could ask an expert builder that if you want to level something or make something straight, can we just look down it? Nobody. Rakia.
I don't think that's. I wouldn't think so. No, Buster.
I mean, I wouldn't.
Just look at it.
You just look down. Well, I mean, the stuff that I've done, I would never just look down something to line things up.
What would you do?
String lines, level, square, those types of things. And then once you've got it all set, like say posts or concrete, you measure it off of objective tools.
That makes sense to me.
Yeah.
We're in some strange times.
Strange time. Indeed.
It's interesting. It goes back to what we talked about yesterday, in a sense, with just changing the identity of the subject right then on the spot. How it's an instant contradiction. Also, right then on the same spot. And I had an interesting conversation today. Somebody said that, how would you translate this? He said, binary thinking is a fallacy. And to me, in general, I'm thinking to myself, like, but the identity, though, you have to be able to say this or not this. It's binary. That's the whole point. So,
yeah, excluding the middle.
Yeah.
Don't be bringing logic into this. Come on.
Is that my bad?
No, that's right, though, right? That excluding the middle is part of logical system. It's vital to it. It's one of the laws.
Yeah, that's the point, right?
Mm-hmm.
And he agreed to it. Perpendicular to plumb, to vertical.
Mm-hmm.
But then just say no right afterwards. Like, but no.
It's not like there's somebody somewhere has severed the connection from perpendicular and plumb. Saying those words, level is perpendicular to plumb, doesn't mean level is a straight line on a horizontal plane, apparently. See why I use those words at the beginning? It's genius. No, and nobody will disagree. Level is perpendicular to plumb. That's what everybody will say. They just imagine a curve that obviously isn't there. Not within the geometrical statement.
And by the way, if he was creating a hump, and to see the farther this light was lower, so it should be out of level, because he should dip down to create that chord line through this hump. So he immediately would go out of level with his level tool. This tool would no longer show level. If he
has an uncalibrated total station or theodolite.
Oh,
it's not an auto level. It can be adjusted, and it is not calibrated. So he did say he was just using it as a telescope. So don't be confused by the lines on it, because it looks like a theodolite. It's not.
Therefore, he cannot prove anything with that.
Mm-hmm. That's what I was saying. Like, you can't just take a picture of some lights and say that horizontals aren't parallel. It's a little bit silly.
So his example was pointless.
As always. And it was only to get away from the admitting that level is perpendicular to plumb, which means level is a straight line on a horizontal plane.
Yes, that I think that this was job of Rumpus. So he was aware that you are leading him to a trap. So don't go there. Don't go there. Don't say that. Don't say that.
Don't agree that level horizontal is parallel to the horizon, is what Rumpus said to him.
Rumpus must have been DMing him like crazy in the background.
Well, I think he wouldn't have listened to those. That's why Rumpus came in to give him his orders vocally. I mean, like, Rumpus doesn't come in here that often, does he? Rumpus obviously tried to intimidate him into some globe thinking.
And, well,
which I think's pretty, I don't know. It trying to influence somebody else by coming in and shouting like that.
Jesse, if I was you, I'd be checking your DMs. I'm sure they're pretty full by now.
Blue said he was doing really, really well. Slaughtering me or something like that.
Oh, yeah, making you look really bad, yeah. Yeah, according to Blue. course, I don't think he was watching the same conversation as us, but, you know.
I do. I think they are. Like, Jesse couldn't see that level being perpendicular to plumb is a straight line. Blue can't see that, you know, the basic statements that we've made and what they mean.
Yeah, the horizon's got to go. It's got to get sacrificed. Something has to go, so it's the horizontal.
I'm pretty sure Jesse horizontal, but definitionally, he placed horizontal side by side with horizontal, and one of them, pretty sure, was horizontal. Did anybody else hear it? I've got
yes,
it on the board.
you have to have this conclusion that he was talking about horizontal because otherwise his explanation cannot make sense.
Yeah, now I don't know whether that's I don't know whether that's an order or whether they're preparing anything, but I think the LIGO elevation profiles have forced them into a bit of a corner, and they're going to have to develop. I don't want to say it. I don't want to influence it. I want them to do it all on their own.
Sure, they're hard at work right now. All huddled. Blue Ops is going. It's going on right now, I bet.
Are you in Blue Ops, Jesse? Have you been given? I think you did, didn't you? You got in there.
I think
since last time. Blue Ops over at Blue Marble.
I don't think I've got an invite to that one yet.
Oh, have you not? Somebody dropped Jesse an
Is that
invite.
a Discord?
I'll give you an invite to Blues.
Yeah. Oh, I thought you'd have already been in there, Jesse.
No, I don't think so.
They'll love you over there. Star player. Rumpus does presentations over there. You could do some of yours. There you go.
There you go, Jesse.
Dang it. Still banned.
Tell Blue I sent you.
Oh, thank you.
Oh, I'm in. You're still banned.
Yeah.
Boo. I got in. Boo.
Who, you?
No way. Yeah, he's in there. Cheers, Blue. Take Buster off as well. Come on.
It's about time, Blue, you came to your
get
senses.
Buster off. What's Buster done?
Take Buster off, and then we'll come over and do a shindig. A group hug.
I'll play a song for you.
Me, Bev, Rakia, Mobius, Buster.
Do your new theme tune
for this occasion.
I'll sing at your next wedding.
Holy shit!
Sing you a theme tune.
Yeah.
Now that's an offer, Blue.
I don't typically do it, but I did put some words in there for, well, you know who. Maybe that's why I'm still. No.
Yeah, I can't.
Rakia will do the catering. He'll furnish the catering.
Have you guys got a surprise when we get our tests going? But I mean, you do have to have a bit of an understanding of geometry and what a straight line is. Even, equal.
Darn, I shouldn't have mentioned Rakia. That Blue, that I ruined everything. I'm sorry, Blue. I didn't mean that. Forget I mentioned that name.
Oh, Genesis is in the chat.
In which chat?
YouTube.
Is he?
Somebody held it.
Two points on a canal 27 miles long. Establish a chord. Really?
Oh, this guy's nuts.
Wazinski. Wow, look at this. They're going for it, aren't they? I'd be careful. Don't feed the trolls.
Don't feed the troll.
And if he establishes a chord, it means that he needs to deep down. So he is going out of level immediately.
Yeah. It's got a hump. And water doesn't do that. It doesn't rise.
And I am saying about a local level. So he is going out of level in his location, not overall level, Earth level, whatever. Just on this location, his device showing level would go off level immediately if he is creating chord line. And it doesn't happen, so it is impossible and absurd.
Lots of weird stuff going on in the chat. Discord chat, anyway.
Yeah, we've got some new members in, haven't we? Gets hot. It always does this sort of thing.
Yeah.
I don't know why as well. It always, when we talk about these really basic concepts, and I'm presuming it's got something to do with the twin tangent of LIGO challenge set by FE Dogma.
It is amazing how many people have tried to explain it on that side.
Yeah.
Or I shouldn't say side. Hate that word.
Yeah, it's just the amount of people that are willing to try and explain it, right? Most people go, we can't. Even my missus can't. And that's normally the end of the conversation.
Yeah. Even Hex said it. It's like, well, I mean, you could make 2 points from 2 tangents. But it'd be a chord. I mean, you know.
And then they go on to justify how you could do it, right? Rather than just most people. I like I say, when I say most people, I do. Yeah, I do. I mean, most people. The most people that I've asked have said, you just can't. But I guess they don't know the implications for the model when they say that, or most of them are those of us around here that have probably just dropped the model already, right? We don't have the model to cause a conflict, to give us paradoxes.
Well, just using the word, that word in the first place is crazy. To describe do you or do you not have a soundbite where Rumpus says tangent to a horizontal?
Yeah, absolutely.
Well, didn't he just say on Blue's show the other day that tangent equals horizontal, or was it the other way? I mean, it doesn't matter.
A tangent point is the point that it is horizontal in his mind, because that's the point on the circumference, isn't it? The tangent
but I
point.
think, if I'm not mistaken, on that video, he had tangent equals horizontal.
Mm-hmm.
But Yeah, it's just crazy the places they go to.
It was in its globe axioms.
Yeah.
Why would you switch
the
from like
rules.
months ago saying tangent to a horizontal, however that soundbite was the months ago, to now saying tangent equals horizontal? I don't know. I guess it's working out the problems. I mean, it's good though. Hopefully they'll solve it.
I think that they are going wrong way, because now they are saying that it is horizontal or vertical, whatever, at a point. It means that they don't need any more horizontal plane. So they are going out. They are throwing out whole this tangent plane, and they are reducing this to one point, which is nonsense, because if you have no horizontal plane, you haven't got any reference frame anymore. So this is
exactly
nonsense.
why we've been saying aporia. Can you go the wrong way when you're in aporia?
Anyway is wrong, so they can go anywhere.
Yeah, exactly.
It's a cul-de-sac. Emporia cul-de-sac. Can't get out.
Here we go. It's tangent to a horizontal. 8 seconds.
Ah, I gotta hear it.
Along the surface of the Earth, it always. You do know that the artificial horizon in an aeroplane will change angle as you move along the surface of the Earth. It always keeps you to a tangent to a horizontal.
But now he's got tangent equal to a horizontal. Well, anyway.
Yeah. Tangent to a horizontal. That was why I saved that one, because...
Classic.
Yeah. That's impossible, but, I mean, that's the string of incoherent babble that comes out of the mouth when they talk really quickly.
I think it would be Rumpus tactics, because this is a long time. He didn't change anything. This is his way of speaking, and I think it serves him well, because anybody, you cannot understand what he's talking about, really. So you can interpret this
Not just twat speaking.
as he can interpret this as he wants.
Somebody says the link isn't working.
Which link? To Blues?
No, for this place. There you go. Discord link sent. I might have to check that out. Jesse Gordon's put in the thing. Look, man, to Mike. Look, man, if I handed you a crystal ball and a match and said, here, glue the match perpendicular to the surface of this sphere, would you know what I meant? Of course you would. He's answered it. But Bev doesn't understand that. He's already made his mind up. Can't have perpendicular to a sphere. Jesse.
I mean, don't you know that, dude? Really?
Well, but if you're holding a sphere, there is a horizontal and vertical plane.
Only in your mind.
I mean, if you're holding a sphere, there's going to be a horizontal and vertical plane that cuts it.
Yeah, but you've only got a match and a crystal ball.
Yeah.
That's the only apparatus you've been given.
Oh, that's it?
Yeah.
No tools?
If I handed you a crystal ball and a match and said, here, glue the match perpendicular to the surface of this sphere. That's the
No
that's
samurai
the
sword.
instructions. Off you go.
That's
Boom.
that's ridiculous.
You gotta go find your own glue?
Do I have to find my own glue?
You can have some glue, no problem. You just gotta find that nice, perfect, perpendicular spot.
You ruined a nice
good.
crystal ball.
I don't have to go. Yeah, that's
Good
cool.
luck.
I don't have to go find my own glue then.
We'll give you glue, crazy glue if you want.
That's what I want.
I can glue you.
I've never been part of a group of people that doesn't understand any more than any right now. Come on. Surely y'all understand better than this. That guy's nuts earlier, whatever his name is.
Jesse.
Yeah, Jesse.
Well, I tried to evoke the Rakia, but he didn't show up.
Well, Rakia, it sounds like you and I were kind of on the same page because we started talking at the exact same time, but you said exactly what I was going to say anyway, so it was all good because he kept saying it appears over and over and over. It just didn't. It appears to be higher or lower or whatever.
You mean lights that in your own photo you have reflecting or in different positions over distance? Yeah. Nice one.
Look, man.
Yeah, I never said, but I mean, have they never heard of optical compression over distance? Mick West called it perspective compression.
It's just as normally perspective works. Things are going down. Like, for example, if you can see clouds on the sky and they are roughly on the same level above the Earth, but in perspective they are going down and even they are touching the horizon. But no one thinks that they are really going down. They are on the
I
same
wouldn't
level.
say nobody thinks.
Okay.
There are people.
Oh, maybe there are some globe perspective thinking people.
Do you think you could draw lines to them and say that horizontals aren't parallel? Because that's a bit of a stretch. I mean, for anyone, really. Jesse, have you... Oh, I see you seriously never heard of perspective compression. That's... I mean, it is primarily why we don't deal with the optics normally over distance, because perspective compression. And if you want to know what that is and how that works, then you look at the stadia lines. But obviously, there's a problem with level first. That's the main hurdle you have to deal with. It's making me brew.
Is it time for some model affliction?
Oh, a live performance.
Okay.
I mean, it seems like a little bit of a lull spot. I could liven it up a little bit.
Okie dokie.
Are we voting for Model Affliction or something else?
That'll do for me if that's what you've got ready.
I can do it.
Thank you very much.
All right, here we go. I wrote a song about it like Here we go. Is it a hump or a drop? What do you say? You've got to twist your words in every which way, because the model will always dictate what you do. Everybody knows that you got the model affliction blues. Is it a straight line or does it curve? You got twin tangents, but that is absurd. We all know that the model dictates what you do. Everybody knows that you got the model affliction blues. Model affliction. It's your addiction. That model affliction. It brings you so much pain. It's your ball and chain. Conflating curvature with elevation change has got your local distance just out of range. That old biggie is gonna dictate everything that you do. Everybody knows that you got the model affliction blues. It's your decision defending the model position. You just don't know the geometric propositions. That old ball, it'll always be illogical to you. That's why perpendicularity is a puzzle to you. Model affliction. It's your addiction. That model affliction. It brings you so much pain. It's your ball and chain. I've heard these arguments year after year. I'll just sit back and have myself a beer. Everybody wants to be heard. Nobody wants to turn it to zero. We all know that you got to be the globe earth hero. Or the flat earth hero. Globe earth hero. Globe earth hero. Take your pick. Everybody wants to be heard. Nobody wants to think though.
Thank you very much, Buster. World famous Buster.
Thank you, Buster.
You're welcome.
Model Affliction Blues.
I think there's some parallels with I got big butt, or I like big butts, and I cannot lie. There's definitely some parallels to that.
Really? That's the connection you made?
Yeah. Well, yeah.
Check this out. SE put hump or drop. Because that's your first line, isn't it? And them versus us. Put drop.
There could definitely be some sexual innuendos in that, for sure.
Choice has been made.
And you don't understand. That's it.
What a song. Shout out Buster. I think this definitely is my especially since it starts off hump or drop. I mean, come on.
I did add the twin tangents in there. I don't know if anybody caught it or not.
You did?
Yes, I noticed two tangents, yes,
Yeah,
at the beginning.
twin tangents, yeah.
Did it record it, Buster?
Well, it'll be on. You can go back and watch
It's on YouTube. We're at about 4 hours 38 at the minute, so tomorrow you want to go back 4:30 or something like that.
It's always different. The song is never the same twice.
It's always new verses and new bits fitting in and a current topic. It's brilliant.
Yeah, it's all right.
Yeah, meh.
Ooh, yeah, it's been a mad night again.
Birthday night.
I know. The Discord
right,
link's
happy
not
birthday.
working. I'll have to
How
sort
old is
that
it? Half a century? Is that how old you are now?
51.
What? Oh, you're over the hump.
Mm-hmm. Yeah, it's all downhill from here.
Just going down the drop now.
The slope that's measured optically.
Slope, blue slope.
I'm really struggling to see how we can even communicate with people, because you could show them the geometric drawing for it and they won't accept it because they've got pictures. So I really don't know where this is going to end up going. They think we're deluded. They think me particularly, I'm doing something a little bit strange. Thanks, Mike. Mm-hmm. Jesse's middle flashlight. That's all, Jesse. You can't just go to that as he's gone. That's all he's doing. He's going to the water. It's curving. That's the only reason that could possibly happen, is if the water's higher at the midpoint. I think he thinks he can see a quadratic drop.
If you're running your boat across that, you would get high centered on a sandbar.
What? Well, then why did they switch to all of their optics being an angular measurement? If they're so sure of a quadratic function, then why did it switch to angles?
don't know. It's a massive stolen concept wrapped up in it, isn't it? Like it. Yeah. I can't even imagine, because like I'm guessing, because you know a little bit of geometry and a little bit of the practicality, you can see like 2 or 3 steps further along. I don't think they can.
Well, I thought it was brilliant. You pointed out where the bridge was. I mean, that was where, I mean, wished we'd had that terminology the last like 4 times you went through the 12, you know, like,
yeah,
through, like, some people hit it at, what was it? One person hit it at the 3rd one.
Yeah. They're all putting a lot of faith in this thing from Jesse. Who is Jesse? Why do we now have people coming into Thingy talking about 48 inches above the lake as though that's meant to be something like a drop of the lake in the distance? Are you sure, guys? This is what you want to go with?
This icon is a theodolite.
Who, they? Them? No. It's us and them. Pretty sure that was Chunky Butt Boy. Chucky Brad Boy. Wasn't it they and them? Maybe.
They, them.
Mm-hmm.
Yeah, I remember something like that.
They and them, that sounds familiar.
Yeah, yeah. That's, I think, or it just sounds familiar.
It gets pretty
Oh,
obvious.
there was a person by that name for sure.
Oh, yeah, they.
Yeah.
Now we got them. It's always obvious when somebody has an account and they just text chat roll.
Thank you very much, Science. Yeah, it was a really good show. I think it's time to wrap it up now. If anybody wants to come in, it is the weekend. Next Level Discord. Click the link underneath the video in the description. Think that one might be working. If it isn't, I will have to check that one again as well and re-upload the Discord link. So I don't know why they would have ended, but they haven't. We will be back maybe sometime over the weekend. Who knows? Probably not though. And back on Monday for Model Affliction Monday. No doubt some new stuff will have happened. I think next week we were going to go over the Rumpus test and the build up to the next level trip to Bedford levels. Coming soon, so if you want to get involved with that as well, if you're in the UK, fancy coming down to Bedford, meeting up with the crew, having a look through cameras or what, it doesn't really matter. Please come into Discord, let us know. We'll be going on all the time now for a fair bit probably. I'm going to end with a Buster song.
I want Jesse to come back now. I'll have to speak to him again.
America is a nation that can be defined in a single word. I was going to put him. I was going to put him. America is a nation that can be defined in a single word. I was going to put him. Judge my physical and mental my physical as well as my mental fitness. I was going to put him. I caught part of President Putin's press conference. I was going to put him. So the best way to get something done, if you hold near and dear to you that you like to be able to. Anyway, I was going to put him. You know, folks, that's the America that George Bush has left us. And that's the America I got to the Senate 180 years ago. America is a nation that can be defined in a single word. I was going to put him. I caught part of President Putin's press conference. So the best way to get something done, if you hold near and dear to you that you like to be able to. Anyway, I got to the Senate 180 years ago. My President of the United States, I could be vice president. My mother and father believed prescription drugs judge my physical and mental my physical as well as my mental fitness. And the kids used to come up and reach in the pool and rub my leg down. I was to put him. Come on, man. That was really a productive segment, wasn't it? Judge my physical and mental my physical as well as my mental fitness. We choose truth over facts.
Yeah, boy.
1.2 billion. So you go ahead and you stack spaghetti sauce at a store. I was to put him. You know, the message is simple. Going after Mickey Mouse, for God's sake. We hold these truths to be self-evident. All men and women created by you know the thing. America is a nation that can be defined in a single word. I was to put him. I was to put him. The best way to get something done, if you hold near and dear to you that you like to be able to. Anyway, that was really a productive segment, wasn't it? Keep yapping, man. And the kids used to come up and reach in the pool and rub my leg down. I was to put him. You could inject some bleach in your arm, and that would take care of it. Prescription jugs. Prescription jugs. I was to put him. America is a nation that can be defined in a single word. I was to put him.
Space station is a serious place. We're doing serious research, scientific research, and engineering research. We have a regenerative life support system, which is a fancy way of saying that we've got a toilet that you use, and then a machine that goes chugga, 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 chug, and then you go to the galley and you make yourself a cup of coffee. And that's exactly what you are thinking it is. And this is the kind of engineering research that we're doing on space station.
America is a nation that can be defined in a single word. I was to put him. I was to put him.
It is photoshopped, but it's has to be.
I was to put him. We choose truth over facts. We choose truth over facts. You could inject some bleach in your arm. And the kids used to come up and reach in the pool and rub my leg down. Poor kids are just as bright and just as talented as white kids. My name is Joe Biden. I'm Joe Biden's husband. I was to put him. 1.2 billion. So you go ahead and you stack spaghetti sauce at a store and in a supermarket. You control the guy or the woman who brings out the carts on a forklift. What happens? I was to put him. So the best way to get something done, if you hold near and dear to you that you like to be able to. Anyway,
Here is Pig. And of course, Pig is the arch enemy of Angry Bird. And Angry Bird had some eggs. And Pig stole the eggs. And don't ask me how I got to eggs on space station. I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
America is a nation that can be defined in a single word. I was to put him.
I'd go to the moon in a nanosecond.
I was put him
It is photoshopped, but it's has to be.
The Earth is flat.
Why has nobody been to the moon in such a long time?
That's not an 8-year-old's question. That's my question. I want to know, but I think I know. Because we didn't go there, and that's the way it happened.
I was put him
Yes. There is no Earth curve. We can see way too far. Patrick, yes.
At Associated Press.
March at NAP. What was going through your mind? How amazed were you to see your roadster up there with Starman just cruising along with the Blue Planet? And how long will we be getting live views, do you think, from the car?
Well, I think it looks so ridiculous and impossible. And you can tell it's real because it looks so fake, honestly. Like, we'd have way better CGI if it was fake.
America is a nation that can be defined in a single word. I was going to put him.
And by the way, I sit on the stand, and it get hot. I got hairy legs.
Come on, man.
We choose truth over facts. That was really a productive segment, wasn't it?
Something that absorbs water on the back of your head. Hey, let's use a diaper. I thought that's a clever solution to this problem.
Yeah, pretty neat. They also came up with the snorkel idea too,
Unexpected turn. The astronauts doing the spacewalks will now be wearing snorkels after the last astronaut who performed the spacewalk nearly drowned when his helmet filled with water.
Just my gut inside me said, that's my dive buddy, and I should be with my dive buddy.
America is a nation that can be defined in a single word. I was going to put him.
My name is Joe Biden. I'm Joe Biden's husband. And the message is simple. Going after Mickey Mouse, for God's sake.
Nice.
Some flat earthers will also define science in such a way to include only experimental science, not observational sciences like astronomy, marine biology, or paleontology. I want you to notice something about the form of these arguments. You'll see that they generally say something like this.
A sea and an ocean, right? Everywhere you go, we see and observe flat level water. If 70% of the surface of the earth is flat, it cannot be a ball, right?
Flat earthers mean the surfaces of oceans follow a perfectly straight line. That's just a common sense idea of flat and level. We mean flat as in flat means smoothly curving around the globe. We're using a slightly different definition. But that's because a curved surface can look perfectly flat. So, do you think a tiny ant standing on the hour hand of a clock would notice it moving? But that's because we're using a slightly different definition, or you have the science wrong. Another kind of argument is to say something like, all oceans are flat, or water always seeks its level. I like to use this analogy. Flat earthers are correct, but remember, we humans cannot sense speed. Finally, what about air pressure? Again, flat earthers are correct about pressure requiring a container, but only on small scales. Next, flat earthers say we don't feel rotation, and they're correct. But that's because globers are saying that we're using a slightly different definition.
America is a nation that can be defined in a single word. I was going to put him.
Houston, we have a problem.
We don't have time for a meeting of the Flat Earth Society.
The Earth is flat.
It is photoshopped, but it has to be.
I was going to put him. The best way to get something done, if it holds near and dear to you that you like to be able to. Anyway.
Yeah, boy.
And the kids used to come up and reach in the pool and rub my leg down. America is a nation that can be defined in a single word. I was going to put him.
Yes.
It is photoshopped, but it has to be.
Yes.
The Earth is flat. Yes, that's right. The Earth is flat. Yes, that's right. The Earth is flat.
We choose truth over facts.
You know, folks, that's the America that George Bush has left us. And that's the America we'll continue to get if George.
America is a nation that can be defined in a single word. I was going to put him.
Houston, we have a problem.
Nice.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again. But going to Mars should be one of the next series of steps that humans do. The first step should be going back to the moon for a number of technical reasons and exploration reasons, and then after that, Mars, maybe high orbit in Venus atmosphere, maybe going to Europa. There's all kinds of targets to go to, places of interest in our solar system. The emotional damage.
I was going to put him.
How many bites do you have? Clay.
I think a lot. I just wanna show how ridiculous
you gotta have
reality is.
You have a lot of spare time, I see.
Right now, yes, I had a nice bike ride today, and just figured since no one is talking, I'm just gonna play some stuff. Because America can be summed up in one word, according to your president.
I was going to put him.
Yep. Welcome to America.
I was going to put him.
Where you will also find people like this.
The Earth is flat. Yes, that's right. The Earth is flat.
Or you find people like where is he?
When has anyone in your group, Nathan Oakley's group, when has anyone measured to that horizon? Because the Black Swan states that every measured horizon must be 1.22 meters times this whatever, right? When have you measured it? And when was the Black Swan put through the scientific method? You can't destroy 2,500 years of science with logic.
Emotional damage. Yeah, boy.
Does anyone know that guy's name? Who said that? The Black Swan.
I think his name is Nasser or something on the.
Oh, Pete Nasser, is it?
Yeah,
Okay.
something like that. Maybe I'm not 100% sure, but I think it is. There's this guy with this weird profile picture that says Nasser or something.
They're all deluded over there.
You can't just destroy 2,000 years of science with logic.
No, you cannot.
200 years, sorry, 200 years.
Oh yeah, that's what it is.
I was going to put him.
Houston, we have a problem.
Also, putting Black Swan through the scientific methods is about cause and effect relationship, so it doesn't apply to this even. It's an observation, not a scientific experiment.
That's
So
why I find it so funny what he's saying, you know?
yeah, definitely. Just handed himself red-handed. Not like that.
Yeah, Globers are so. I mean, the anti-flat earthers. I'm just sorry for them at this point. I really am. Really, you know, like, I'm just sorry that they put themselves in such a limited reality.
No, he's not. He's not using logic. That's why.
The funny thing is with these people, like, regardless them being presented with the flat Earth, they also, you know, since they're anti-flat earthers and they're sticking to the globe, they're the same people that would say, yeah, there's no problem with taking this or that, and what the TV says is all good and so forth. You know what I mean? These people, they force themselves to be in the Matrix, in this satanic matrix, you know, not a computer program, so no one misunderstands me.
Yep.
I mean, a matrix can be a construct, right? It doesn't need to be a computer simulated construct, if I'm not mistaken.
As in what? Making a model out of it?
Yeah, I mean, in mathematics, it's like a table, if that's the right term. No, not like a table. Tabelle of English. Tabelle of English. Yeah, table. Table with lines. And it has a certain order. But there are different type of matrices. I'm just using it as a metaphor, you know. Anyways, I'm gonna take a shower. I'll be right back.
Ooh, yeah. Rest.
This is awful.
Hello, Discord. Is anybody in here? Is my mic coming through? Probably not. It's a lively bunch. Okay.
We are here, Dave. Don't worry.
What's up, Sasha?
Both waiting in background for nothing.
All right. Well, nothing wrong with silence. We're just waiting for proof of this globe everybody thinks they live on. Need to start with the curvature measurement. Need to see drop over distance, please. Over a body of water. Thank you. At least 10 miles, still the 60-foot drop. 6 foot, whatever it is. That would suffice. Thank you. Anybody got that? Come on in here and tell us about it. Show it to us. Demonstrate. That's a word the globe believers hate. Demonstrate. Don't just talk about it. Show it. I'll shut up now. My mic sounds like shit. I'm tired of using my crappy mic. See if there's anybody new on here. Look at the screen. If you're new, say hi. We're done. That's your choice. Thank you.
Beans.
What was that?
Beans.
Beans? What are you saying? Come again. Back to silence.
Yes. Yes.
Whoever's trying to talk, that was incoherent, at least to me. Say it again. You know, whoever's trying to talk. Learn.
My turn.
These brief utterances that make no sense, I cannot communicate with. Unless that's just me hearing it that way.
Oh! Hey! Oh! Hey! Attention! Oh!
All right, mic check for signs of life in here. Anybody got anything to say? This is the 24/7 Flat Earth. Best place on earth to talk about Earth. If you think you currently live on a spinning ball, come in here and discuss, please. Thank you.
be being quiet here.
Yeah. Oh, hey, Morpheus. What's up? Oh, well.
I can hear the door close loudly behind me. I can hear my footsteps walking, crunching over leaves. I can hear the wind blowing through the trees. I can hear faint sounds of construction still. And I hear a helicopter overhead somewhere, blocked by the trees. I can faintly hear the sounds of a busy street next to me. I can hear the helicopter overhead. I can hear a biplane overhead as well.
Who was talking? Somebody talking? My mic working?
Yes.
Hello.
Hey.
Are you the delusional Dutch space crab?
Yes. That's me.
All right. Nice to make your acquaintance, sir. Do you think you live on a spinning space ball covered with water?
I suppose so.
What makes you think that?
Well, because one of the reasons are, for example, satellites that orbit around us.
Satellites in orbit make you think you're on a ball. Is that
That's
what you're telling me?
one of the reasons.
So how can stuff in the sky possibly make you know the ground's curving?
Because those orbits would not be possible if the Earth was flat. The triangulation on the horizons would not really work.
That's kind of vague. I don't specifically. How does a satellite make you know that the ground is a ball?
Well, what you can do is if you have three telescopes, you can triangulate the location of the satellite, and these figures would not match up if it was rotating in a circle around us, as would be required on a flat Earth. For one thing, the height, and also the speed, and also how it is going under the horizon. I suppose on a flat Earth you would have diffraction or refraction, but that's only.
I have no idea what you're talking about.
Oh no, I mean, it's not those. It's the what makes things disappear on a flat Earth again. It's the what do you guys call it? It's the it escapes me. Why boats disappear on a flat Earth? It's called the name escapes me. It's like when you look down a very long corridor, it appears to go down. This phenomena has a name, but it escapes me. But I think that only really works with a boat, not something in the sky.
Is there anyone else on here who wants to respond to any of that? I really couldn't make much sense out of it.
Oh well.
But do you agree that if we really lived on a ball, we would be able to measure the curvature of the ball?
I would say that would be a reasonable assumption then, yes.
Okay, so like you and me, we could go out to, say, a coastline and an island like 10 miles off the shore, and we could use a laser or something, and it would show the 56-foot drop over 10 miles, and we could measure that. Do you agree?
Well, it is. That's the rough idea is good. It's a bit more complicated because you are dealing with things like atmospheric interference and beam spread, but you would be able to account for those, obviously.
Well, what if we could show you? I don't have them at my fingertips, and I'm driving, but there's people on here that have got research done. I believe it's by the U.S. Air Force. It's some part of the military, and they've measured lasers accurate for like 30 miles or so. Don't hold me to the numbers, but there's not much deviation in the laser. So don't you think we can find a laser that can go over 10 miles?
Well, beam spread you can mitigate with a high quality optics, I suppose.
Well, how come no
Atmosphere.
globe believer has done that yet? It showed the 66-foot drop. That's all we need to see. Somebody be able to repeat that. But nobody's done that. Every time we go out with a laser, we don't see any deviation between the surface and the laser. And you guys say it bends around the earth or whatever, but that's just bullshit. I hope you agree. Does anybody else want to talk? My mic probably sucks.
No, it's all right. It's I mean, this isn't a professional production, right? So it's obviously perfectly acceptable.
Driving a car and I got a lot of road noise, so I apologize.
Yeah, I mean, no worries. I mean, it isn't a professional production.
Actually shown that deviation in the drop. This channel wouldn't exist if we saw that.
Right. Wasn't there this really popular documentary where they tried something with a laser on a camera on a board with a circle in the middle. On the camera couldn't see the light.
That was a failed experiment that it's not worth going into. It's just a Netflix thing, and they misrepresented it anyway. It didn't prove anything.
So
what I just said, go over 10-mile distance and show the 66-foot drop. It should be easy to do.
Right. Okay.
I got next to get a powerful laser, aim it straight across the water, and at the other end at point B, you'll see a deviation from the surface to the laser of about 66 feet. Bam, it's a globe right there. That's all we need to see. Somebody should have done that already 7 years ago.
Right. I mean, there are documents about. I mean, there are several documents about this. What you're talking about. FE Core, I think, did several of those experiments and documented them extremely thoroughly. FE Core, right? I think did several.
That's correct. They did those over a frozen lake in Hungary, and it's well documented. It's down the bottom of our server if you want to look for it. They did look, I think their longest one was like 25, 26 miles. And there was no curve, no deviation of the laser. So
that's not a problem.
For what it is, I know it's not a spinning ball. If you think it is, it's just you can't prove it.
I do get your point, obviously. But one thing that I do have a problem with on a regular basis when I try to visualize the flat Earth in reality is that doesn't plane navigation use great circle routes, and those wouldn't really work on a flat Earth. The distances, especially as you go further outwards, would be increasingly longer than they are on a globe.
How much do you know about navigation across bodies, across oceans, and how much do you know about how they actually do it in real life? There is a thing they call the Drake Circle route. That's basically a thing they made up to make people think they're on a globe. But in real life, like sailors, for example, for hundreds of years, We've been using a horizontal datum line to use a sextant to navigate from point A to point B. And they've been doing that for hundreds of years. You can't have they can never use a
Right.
sextant. If it was a curved surface, the sextant would not work. It would not be accurate. So if you're talking about navigation, that's not a good point for the globe. I don't care about your circle routes. I mean, do some research into those circle routes. You'll see that it's just another way to make people think they're going across the globe, but they're not really. They may go in a
Right.
curved path, but it doesn't mean anything.
Right.
Anybody else know anything about navigation?
But I think part of the problem still stands where on a flat Earth, if you start in the middle, the distances are the shortest, and as you go outwards, the distances keep increasing. But on a globe, if you start at the if you start like at a pole, the distance is the smallest, the circle is the smallest, and then if you go outwards, it increases, and then at one point, you are at the like in the middle when the distance is the greatest, and when you continue the distances towards the other pole, the distances get smaller again. So that's like a difference between the flat Earth and the globe Earth, if you get what I'm saying. In the flat Earth, the distance keeps increasing as you go outward.
Now you vaguely refer to some kind of distances and everything. You don't have anything specific. So I really don't know what you're talking about. Does anybody else want to talk to this guy? Because I know my mic sounds like shit. Is there anybody else?
To Bravo.
Who's that? Somebody just said something. Who was there? Anyway, all you did was vaguely describe something about distances being shorter or something, but you know, you'd have to specifically put together what you're talking about and explain it to somebody. He said, I'm driving a car right now, so I can't look. Doesn't it bother you that to prove you live on a ball, you have to motivate stuff like that? I mean, I'm not sure what you're talking about, to be honest with you. I wish somebody else would start talking to you.
No, it's fine. I don't think the principle what I'm talking about is vague, but perhaps I'm not explaining it in the best possible way. Perhaps I'm not clarifying myself right. So it's probably my fault for being vague, but I don't think the principle is vague. But no, it's fine. I understand you're in a car, so just drive safe, alright? Drive safe.
It's all good, man. I appreciate the combo. Hopefully somebody else will jump in here in a minute. Like I say, if you live on a spinning ball, you need to start with the curvature. We need to find that curvature first. None of us here can find the curvature.
Right.
I've seen a lot of pictures that say there's curvature, a lot of explanations about refraction and blah, 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 but we still haven't seen the curvature. So that's all we need. Start there.
Right. Well, thank you very much for your time. I appreciate it. I appreciate you being calm and stuff. Cheers. Oh.
Yeah, cheers. Think for yourself and accept reality as it presents itself would be my advice. But you do, man.
Yeah, I guess you're right. But I think I must go. It's quite late here and I have driving lessons tomorrow. So I need to sleep early.
Oh man, that was a great way to end.
We have Seer of Death joining the panel. Hi, Seer of Death. How did you find your way down here? What makes you interested in this topic?
I literally just told you.
Yeah, but now you're on air. So we gotta rehash it a bit.
Because my sister's a flat earther, and like in about 2 months she's coming back from her 2-year thing at uni, so I want to have an interesting conversation with her when she gets back.
So you need our help to have an interesting conversation with your sister when she gets back from uni.
More or less.
What's she take in uni?
I don't really know, like I said already.
Not too clued up on your sister. Well, how about the Earth? What do you know about that?
Apparently it's flat, but some people say it's round.
How would you determine?
I don't know, that's why I'm here.
Oh, okay. So you don't know how you would go about determining whether the ground is curving? You have no ideas?
I mean, just by looking at it, you should be able to tell it's not curving.
I guess, but isn't it so big that you can't see a curve?
But how would we actually get that far away from the Earth to see if it does or doesn't curve?
Do you have to get far away from it? Or can you just do it on the ground? Check whether or not it's curving.
Well, you can't, because on the ground you already can't tell.
So is that how they determined the Earth to be a globe? They went to space in the 10th century and saw that it was a globe? Or were they on the ground when they supposedly worked all that out?
I mean, how would you even get to space? Because when they placed down that American flag, didn't it, like, wave in the wind? And I don't think there should be wind on the moon. It's just illogical.
Yeah, so the ground must not be curving then, right?
It's not curving.
So they made a movie that didn't look too convincing, and you came to the conclusion that the ground's not curving.
The ground is not curving, it's not convincing at all.
I understand. Well, this is going to be really interesting conversation material for when your sister gets back from whatever she's studying.
I should hope so, because everyone calls me boring.
Yeah, otherwise it could turn out boring and that would be tragic, right?
I think that would just be boring too.
You wouldn't want to be boring.
I don't want to be boring.
Well, thank goodness. Thank goodness you're doing a good job keeping us all really entertained.
I doubt that.
Yeah, everybody's bleeding to tears here. Say something entertaining.
I can't think of anything entertaining, that's the issue.
You need better programmers.
But I'm not a bot.
That's just what a bot would say.
A human would say that too. Like, if I called you a bot randomly, would you suddenly say that you're not a bot?
That's probably not how I would even respond to that, and the question also probably wouldn't come up.
Okay, assuming the question did come up, what would you say?
I'd be like, ha ha. That's funny, good one.
Okay, what would you do if they genuinely believed you were a bot and kept pressing on about it?
I'd be like, well, it sounds like that's a you problem.
Huh.
That's about it.
So you're saying I can just stop trying to prove I'm a human and just say it's a you problem?
Yeah, I'm saying it seems that you protest a bit much.
I care about other people's opinions too much.
Yeah, let those go. Let that shit go, man. You know, be human.
I am a human.
One day, perhaps, just keep repeating that.
Sia, do you have any questions about the flat Earth?
Not really. He just wants to sit in and listen so he can have an interesting conversation with his sister who went somewhere. He hasn't had any interesting conversations yet, but he's gearing up for them. So that's what we're here to help him with. Is there anybody human to talk to? Who's dummies?
Shooter McGavin.
That's right.
Got that gold jacket yet, Shooter?
I got it. My name's in gold.
Congrats, man.
Did it, finally. Took a bit longer than expected, but I made it. You want to talk to a bot? Doesn't sound like there's anything else going on. Say hi to Seer of Death.
Is he a bot?
Yeah, it's a bot. It wants to learn how to have an interesting conversation with its sister, which went to university to study something. Maybe you can help it. His sister was a flat earther, but then it went to university to study something. He doesn't know what she's studying or where it is. Or where, you know. He doesn't know much about his sister. Doesn't know much about the Earth, but he's gearing up to have an interesting conversation one day about it with his sister. That's where you come in. You gotta help this bot learn how to have an interesting convo.
He's on mute, though. Can't do anything about that.
I don't think it can multitask. It's in the chat right now, so it had to put itself on mute for the VC.
I'm perfectly capable of typing and speaking at the same time.
Yeah, it's tough.
Which chat? Live stream, voice text?
Yeah, live stream voice text.
Okay.
This thing's finding out that being human is harder than it thought. We have to do things like type and talk at the same time sometimes. That's tough work, right, Seer of Death? Once you master that, though, maybe you might be ready to start thinking about having one of those interesting conversations you're aspiring for.
You know, sometimes it's so hard when I when I talk to someone, and I also need to use my legs to stand upright. Man, you can't imagine how much I'm thinking at that moment.
In all fairness, it is hard to type and talk at the same time if you're on push to talk.
In that case, yeah, it's physically sort of difficult, yeah. There are some obstacles to be overcome in that scenario.
So did I hear right, Shooter? We have a bot here that thinks they live on a ball.
Well, we have a bot here that doesn't know what anything is. It's not sure if it lives on a ball or a plane or how it would go about testing that. It saw a moon landing video where the flag seemed to be waving and it concluded, yeah, Earth flat. Well, that's the story I got so far. I asked it how we'd go about testing. It said, well, we'd have to go to space, but nobody can go to space. I guess, you know, Eratosthenes must have gone to space or something.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
Yeah, boy.
But I can't believe that's a thing, by the way.
Man, I hear
You're quiet,
So,
Dave.
when I heard him say that, that was it. I was like, okay. This is a joke, isn't it?
Because it's so real, you know. I mean, if you can't believe that this guy said this, then just listen to the president of that country.
America is a nation that can be defined in a single word. I was going to put him.
It's one of my favorite words.
Yeah.
What do you think of that one, Seer of Death? That other bot likes that word. What about you?
I stopped paying attention to you a while ago.
Oh.
Oh.
It hurts my ego, Seer of Death.
That's fine.
I have one of those, you know, I'm human. Be mindful of that.
Okay. What if I don't want to?
Well, then you're just a bad person, not human.
I was going to put him. I got to the Senate 180 years ago.
I think we have one of the most intelligent and well-spoken presidents ever, Manny. You go, Joe.
Ah, man.
Have you got
The kid used to come up and reach in the pool and rub my leg down.
You know, Seer, maybe after you learn how to have that interesting conversation you're looking for, maybe you could run for president.
Yeah, that would be
That sounds
great.
like way too much work, and it's way too controversial.
Yeah, you don't want to be controversial, right?
You don't want to say you don't want to say things that are you know, so inspiring as this.
Poor kids are just as bright and just as talented as white kids.
I understand. Or you don't want to say things
Oh wait,
like.
what do you mean to say it? Vespado.
No, I think you don't want to say things like this as a president.
We don't have time for a meeting of the Flat Earth Society.
That's too controversial. Don't you agree, Seer of Death?
Yes. Way too controversial.
This room is kind of controversial. If you don't like controversy, you wouldn't want to be here.
So, Tia, what do you think about the head of your country?
I mean,
the
I didn't actually think he was that good to begin with. I'm kind of happy that he decided to step down.
Oh, yeah, but he's still a representative of the country that you're living in, that great US and
It's depressing.
Oh, okay.
He's a failure. A joke.
Oh, okay.
Yeah, he's stepping down from the presidency to chase an ice cream truck, right? Isn't that what he's doing? That's what I heard last.
Or fall from a bicycle. Or fall up the stairs. Or, for example...
My name is Joe Biden. I'm Joe Biden's husband.
Did you know that Joe Biden is Joe Biden's husband? Your death. Okay, anyways, let's get back to topic. So, wait, there is no topic, right? For Seer of Death.
What did you guys speak about in voice chat check-ins? They won't let me in that channel.
Oh, yeah. Not much, actually. We're just trying to actually have a conversation, but Seer of Death is like... He somehow wants to have an interesting conversation with his sister, that's why he is here. If that makes any sense at all.
Yeah, we're gonna teach. Yeah, see, like how he stops right away when someone else talks. It's just perfect. But yeah, he's just looking to learn how to have an interesting conversation. We're going to teach him how to have an interesting conversation with his sister, who he doesn't know where she went or what she's studying at uni or any of that. But he's going to have a great conversation with her.
University, and she's studying to become a doctor.
Okay, so now you know what she studied. You figured it out. That's good.
That's very
I said that she wants to become a doctor a long time ago.
Well, actually, you said, I don't know what she's studying.
I don't know what she's studying, but I know she wants to become a doctor. Or nurse, one of those two.
Well, I would guess she's studying medicine then.
There's a huge difference between a nurse and a doctor. And,
Exactly.
And what you have to go to uni and study become one of those things. So you should probably know what she's doing.
I wouldn't know. I don't want to be a doctor or a nurse.
Anyway, who cares about that? Why do you think the Earth's a globe?
That's Spado.
I would also want to talk to Cactuar because he seems to be a heliocultist. Maybe he has some proof of a spinning, wobbling space tactical flying through an ever-expanding universe while other planets are revolving around it. Would be a great story, actually. It's been a while. Do you have any proof of your spinning ball flying through ever-expanding universe while revolving around other so-called balls?
I never said I was a...
No,
I don't believe in globe art.
I'm not talking to you right now. I'm talking to Cactuar.
Oh.
Who?
And heliocultist.
Oh, the guy at the top there.
I mean, he must have had great arguments already to, gain the glorious role of being a heliocultist. So he definitely is onto something. But I guess he is only going to talk in chat.
I guess I am.
Yeah, I don't think he's a bot, personally, but that's just me.
Yeah, I still, Sea of Death, I was not talking about you. I'm glad that you're talking. I would just wish that you had maybe a question or any way of having a reconversation possible.
I just started out halfway through.
So maybe let's...
Why did you come to this Discord?
Yeah.
Like I said,
because of his sister.
You keep cutting out, dude. What are you trying to say? I haven't spoken to you yet, so why don't you tell me why you're here?
So basically I joined because my sister went off. She's a flat earther. It's been about 2 years. She's coming back in 2 months. I want to have an interesting conversation with her because she constantly calls me boring.
Right.
So you're gonna level up.
You've come into
I came into learn about flat earth.
Okay, so do you have any questions? How come you're being silent so far?
Not really. I mean, I don't think I can question anything without anyone questioning me.
It's kind of hard to learn something if you're not going to ask any questions, though. You got to have some questions when you're trying to learn something, right?
That's true.
So if your sister won't talk to you, why is that? Are you asking her a question? If so, why don't you ask us that question instead?
Okay, so I never actually asked her anything because I just assumed that she wouldn't respond to me.
Right.
That's how that usually goes.
This isn't some random girl that you're afraid to approach on the street as from fear of rejection. This is your sister, you know?
Yes, it's my own flesh and blood. I'm not going to go date them.
Exactly. So why are you afraid to talk to them?
I think I probably have a
because she's always so mean to me.
Right.
I'll help you out. Just ask her nicely and stop making any prejudgments. Just be honest. People like that.
So let's maybe try to start a conversation like this. Imagine that everyone in here is your sister. So we can try to maybe, improve improve the conversation, or maybe point out the flaws that you have when you talk to your sister. So now start a conversation about whatever. About, I mean, it's going to be Flat Earth, I guess. If you want to have an interesting conversation, you should talk about Flat Earth. So let's say you're going to start a conversation about the Flat Earth. Since she's already a Flat Earther, we can take the place of your sister, right? In this case. So now just start so we can help you and point out the flaws or the problems you have in a conversation with your sister.
Please don't ban me.
So how would you normally approach this when she doesn't react well?
I'd just leave her alone until she calms down. She gets violent.
No, I mean the before she gets mad, how do you start that conversation?
Exactly.
Usual greetings like how are you?
So small talk.
Very human. I like it.
Yeah. And how does she respond to small talk?
With small talk?
Yeah,
and then we just leave it at that
How are
normally.
you doing?
Stuff like that.
How did you find this Discord?
A friend recommended it to me.
Yeah, I'm just trying to identify where the problem lies. Some people don't like small talk, so that could be annoying to some people.
I'm a boring person.
Yeah, they some people think that is boring, so that could be a thing that puts you off on the wrong foot at the start of the conversation. If you, for instance, just told her, "I honestly want to learn more about the flat Earth or whatever it is you're all about. I just want to learn from you. Could you tell me something?" She would probably want to tell you something. I'm pretty sure of that.
Last time I asked her that, she just told me to research it on my own.
Okay, so what she's then asking you for is to show a little bit of what's it called? Stupid word. It's initiative, yeah. To show that you're interested in what she's interested in. So there's probably some things we could go over here that could probably spark an interest of yours that you could then talk to her about. That could work. Because if
Such
you
as
like, for instance, we have you heard of the black swan argument?
No.
Can someone run him through it?
Black swan.
So the thing is, if you were on a ball, a globe Earth with a radius of 3,959 miles, the horizon should be no further than 1.22 miles away. The horizon would be no further than 1.22 miles away at 1 foot observer height. And so we have it photographed as being more than 10.2 miles away off the California coast using oil rigs to demarcate distance. So this observation falsifies the radius of the globe Earth.
So should I just ask her opinion on that?
You could, for instance, say you went to a flat Earth server and you talked to a few flat earthers. They showed you the black swan image, and you've been thinking about it. Has she heard about it? And that would start the conversation.
Actually, that's a good idea.
Yep, especially if you learn a little bit more about it and understand the argument, because a lot of people don't. So when you look at this picture of the two platforms, where's the horizon?
Somewhere between it. Like both the two black things.
So the horizon is between the two Aldrichs?
Above the water, but below the sky.
it's where the sky and water meet, or it's the apparent junction of sky and ground. That's the horizon. That's what we're looking for in the image. So is it behind the platforms, in between them, or in front of them?
Behind.
Yeah, so it's way past 9.4 miles, and the horizon on the ball should be only 1.2 miles. So it's like over 10 miles or 10 times the distance where it should be, which would require the ball to be inflated to like insane degrees, like from the Earth to the moon. That's how big the ball needs to be now.
Okay, that's a moment to think about it, but it makes sense.
And it's pretty crazy, but because we found stuff like this all over, we started to think, like, what is the horizon if it's not?
Oh, I want to go now, my mom.
And he's gone. Anyway, but he's got something to talk to his sister about, at least.
You taught it how to have an interesting conversation.
Every time mother is coming.
Another one shows up. We got Ethan.
Emotional damage.
You gotta drop the volume on that a bit, but
that's always so funny.
Emotional damage. Stephen He is one of the funny ones for sure.
I laughed so hard when I saw that original video.
But that's why. Just under 11.
So it seems like Ethan actually has no roles.
2 by 10. Beam. Okay.
What is gravity?
You have no idea. Okay, next question.
I don't know. Nobody in the entire world knows why that falls. So what is pushing this? Here. Why does that fall? Newton didn't know. We can describe it pretty accurately. but no one knows why.
We can describe gravity. We can say what it does to other things. We can measure it, predict with it.
I don't need a computer to get a kid interested in that. To spend a week playing with gravity and trying to understand it and come up with reasons why. So what is pushing this?
I don't know.
Nobody knows why. So Newton simply threw his hands up and said, I don't know. So I'm going to invent something called gravitational pull.
Yeah, boy. Emotional, damn it.
Nice.
Something that absorbs water on the back of your head. Hey, let's use a diaper. I thought that's a clever solution to this problem.
Yeah, pretty neat. They also came up with the snorkel idea too, you know.
Unexpected turn. The astronauts doing the spacewalks will now be wearing snorkels after the last astronaut who performed the spacewalk nearly drowned when his helmet filled with water.
Just my gut inside me said, that's my dive buddy, and I should be with my dive buddy. That's my dive buddy, and I should be with my dive buddy.
Snorkel cut from rubber tubing.
This snorkel is now installed inside the suit.
America is a nation that can be defined in a single word. I was going to put him.
I'm like 99% sure that Joe Biden is like, he just dies every 24 hours and then they replace him with a clone. There's no way he's a real person.
Come on, man.
I don't know what you guys are talking about. That's the most popular elected individual in the history of mankind.
True.
We choose truth over facts. I think I probably have a much higher IQ than you do, I suspect.
My mother believed and my father believed that if I wanted to be president of the United States, I could be vice president. I got to the Senate 180 years ago. What a stupid son of a bitch.
He's especially popular among the dead.
What a stupid son of a bitch. The best way to get something done, if you hold near and dear to you that you like to be able to. Anyway, we hold these truths to be self-evident. All men and women created by go. You know the thing. The message is simple. Going after Mickey Mouse, for God's sake. Thank you, Dr. Pepper. Prescription jugs.
It is photoshopped, but it has to be.
Is a cat on your soundboard right now?
What?
I was wondering if there was a cat playing with your soundboard.
Oh, no.
Ah, nuts.
That's true, too.
Space Station is a serious place. We're doing serious research, scientific research, and engineering research. We have a regenerative life support system, which is a fancy way of saying that we've got a toilet that you use, and then a machine that goes chugga, 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 chug, and then you go to the galley and you make yourself a cup of coffee. And that's exactly what you are thinking it is. And this is the kind of engineering research that we're doing on Space Station.
I was going to put him.
Okay, AI, what were you gonna say? Saw you trying to speak.
I was going to say, learn how to soliloquy.
Learn how to soliloquy. Not bad advice. That Obvious at B just came up with a money-making scheme like I haven't heard in years. An exclusive interview with Joseph Biden and Donald Pettit. Got to find the biggest stadium in the United States, and all the tickets are, I don't know, $500.
21.
And the beer is $20 a can. There you go. Extreme exploitation on that ridiculous combination of awesomeness. It's a great idea, obvious. Anybody else enjoy the way that sounds? Donald Pettit and Joseph Biden. Don't use the shortened version.
The summit on international leak tests. What do you do if you have a leak? The solution to Biden and Pettit's problems was diapers.
Come on, man.
Joist. Oh, cantilever.
Did you know that the Earth is flat? There's no curvature, it's not spinning, and space is fake. Do they have any evidence? They do.
Wait. Now I don't know what is cantilever deck joist. What is a cantilever?
Wow,
joist?
that's a good one. Cantilever means that it's only supported by the portion that's attached to the wall. So like imagine a 90-degree angle.
I understand now. Thank you. I got it. That makes perfect sense. Okay. Well, in that case.
I like you. Do you like me?
I'm over here trying to decipher building code.
It's like a bunch of guys that don't know how to talk to a girl in here.
Or a bunch of guys that are preoccupied doing other things. They're just waiting for something special to happen.
Do you come here often? Oh. Bunch of guys waiting for something special to happen, rather than making it happen. Yeah, that's right. I'm looking at you. Yeah, you know who you are.
Mm-hmm.
Dude, you'd be surprised how many people DM you. Is it me? Well, I'm going to do a lake observation.
Oh yeah? What's the distance?
Let me see. Less than 200 meters.
So you're gonna be like an inch off of the water, and it's gonna be really calm.
Yeah. Yesterday was a bright sunny day. Not too much effect. Today is humid day.
You doing like some RC boat type stuff, or
Just
something?
my eyes.
Gotcha.
Just my eyes and observing how it changes through different days.
Yeah.
Now, at this lake, I've been different varying degrees of the opposing shore being disappeared, and objects on the shore like the pylon cement thing where you put the boats down. It's like this big orange horizontal concrete block that disappears. I've had kayakers disappear all the way to their head, so you can only see their head and their blades of their paddle every so often, when they get different stroke angles. You get quite dramatic effects on a small lake throughout the season.
I see. I could.
Danny Faulkner just popped in for 2 seconds and then left.
Yeah. Gospel Bear's got to change his name to not Gospel Bear.
Yeah, it's bad.
Yeah, but also he owes me an apology, as well as a myriad of flat earthers, whether they be mothers, sons, daughters, uncles, aunts, believers in the same faith as him, inquirers, non-inquirers, non-believers, whatever they may be, that he castigated and threw under the bus under a broad brush of being disingenuous liars. So when he's man enough to apologize for that, then maybe we could have a good discussion.
All right, so I think I know the answer to this question, but I read one of the building codes, and it said absolutely no screws, only nails for attaching stringers. No screws allowed according to building code for attaching stringers. Is that because of the climate that I'm in, expansion and contraction, because we have 180 degree temperature range?
That's correct.
Wait, who answered this time?
Timbo, I'm a builder.
Hey, Timbo. Yeah, we get as hot as 120 and as cold as -60 Fahrenheit, so I figure that might be why.
The screw heads snap off, and the thread doesn't give it enough expansion and contraction. So
yeah.
The nails allow it to move slightly. But what's holding it mostly in place is the brackets. So
yeah.
And they're nailed as well.
Yeah.
Gotcha. Well, I fully intend on screwing all my deck boards down, though, and not using nails for the deck boards. But
yeah, that's fine as long as the joists and bearers are nailed. The bearers should be bolted, but the joists should all be nailed.
All the joists
and bracketed.
Yeah.
I think we call it a hanging bracket here, but I'm not sure what.
Joist hanger. I know what you're
joist hanger. That's right, yeah. And boots as well. Joist boots, but I'm not sure the technical term for it.
That's 8 nails. 8 nails per hanger. Get swinging.
Yeah. I know. I'm going to be doing a lot of manual labor. Okay. Cool.
Not sure who Joyce is. Did you actually go and screw her or marry?
I missed the second half of what you said, Dave.
Oh my goodness. You aren't at any loss.
I know he's just telling some kind of joke.
Very rude. It's very rude for this family-friendly forum.
Oh.
I apologize. I'll shut up.
Oh boy. Huh. Fascinating.
Yeah, and of course you got to use non-corrosive nails or coated nails.
Mm-hmm. Hot dip.
Depending on the size, you can get away with just those common nails. Otherwise, you use like the load-bearing structural nails, which cost like $1 bajillion.
It's a really small project, so.
The last one I got a whole set of nail gun nails for like 40% of the price. And I just broke them off the paper and used them rather than buying them free in a can. That's so much better value.
Wow. Usually would be the other way around, I figure.
Well, yeah, like this box is like normally like $25 or more, but I got it for $8.
What about hiring a nail gun from your, I don't know what you guys call it, Home Depot or whatever?
Sure, yeah.
Set it all up, shoot it all in, and you'll be done. Better save your thumbs.
I haven't hit my thumb in so long.
Yeah. They do have holes for the joist hangers, but
yeah,
like a novice that's not used to using a nail gun trying to nail gun a joist hanger, like maybe the straights will be fine, but the diagonals are probably going to screw it up.
So I once had a job where I had to do like 100 hurricane strips, and the guy that I was working for handed me, he's like, "We haven't used this yet, but you're going to love it." It was I don't know its official name, a palm hammer.
Yeah, those are good.
You know what I'm talking about?
Yep.
It was like it was just so easy to use. Pneumatic.
That would actually be really good for the joist hangers.
Yeah, that's what I mean. Hurricane strips, joist hangers, it's all pretty much the same. But regardless, it's out of my scope. I have a hammer, so I'll be all right.
For doing that like just having a heavier hammer makes it all the much easier.
I've got a framing hammer. What do you know? Not very surprised, but Milwaukee apparently makes one of those. Huh. Amazing.
Yeah, so this lake is where I took my son to witness the disappearance of the bottoms of things without any chance of the curvature of the earth being the cause, and intellectually inoculated him from the retards in the future that will posit the idea that things can only disappear if there's a curved earth. Derp.
Yeah.
So, of course, any glober worth his salt, if you wanted to counter argue, would have to argue, well, of course, you're just experiencing optical effects over the surface. That's what's making it disappear when you go to that small body of water. But when you scale it up, it's necessarily the curve of the earth, because those same optical effects couldn't possibly be doing anything at a large scale, except when it's bending light around the earth 1,200 miles to make it reach your eye.
This is the epitome of cognitive dissonance? Or bias. It's more like cognitive bias. Or like I once upon a time said, religiously forbidding falsifiability. The dogmatic adherence to refusal to, I can't even remember how I phrased it. I think I wrote it down somewhere.
My name is Joe Biden. I'm Joe Biden's husband.
Let's see. Oh, it's only. Yeah. All right. Neat. At 24. Yeah, there's a few things going on there graphically. Or oh, I see. Oh, those are like the little floaties. I'm just now noticing the floaties. Okay. I'm like, what are those things? That's floaties.
Oh yeah, they disappear. So there's a close set and a far set, and the far set they disappear as you go down. But the thing that's interesting when you do these types of observations, depending on the day, is that the thing in the distance at varying distances disappears before you get to what would appear to you to be a horizontal to it. Like once you reach a certain critical angle, that thing will disappear. And you can, this is why I love doing it like a lake or something that's pretty still, is you can use the buoyancy of the lake to bounce yourself up and down. And you can watch the thing. You can watch it blink in and out of existence, your field of view. And there's nothing obstructed there. There's a lot of observations like this that people don't even realize. Like they put these little videos out there and they don't really notice that the thing actually disappears before it even reaches the midpoint of their vision.
Yep.
It looks like it's scaling down in size, right? So you see, just imagine like what it would be. Like if it was a hill, you would slowly lower yourself down and you would see a uniform decrease in the object. But that's not what happens. What happens is you see a uniform decrease for a while, then all of a sudden it just goes hyperbolic and disappears almost instantaneously.
Yeah.
Before you reach the angle that you think it's going to fully disappear.
Yeah, it's not. Yeah, I get exactly what you mean.
What you doing there, Gospel?
Rethinking my life after all of your Debbie Downering me. I'm just kidding. No, I am gonna go ahead and rebuild the structure. Yeah.
Well, which part?
The frame. Yeah. But I'm gonna keep. I'm gonna keep it the same size. I am gonna keep it the same size though.
You're not gonna expand it?
No, I don't have.
Expand it?
Nope.
Yeah, I know.
You're robot a little bit. Probably on the road. And by a little bit, you're roboting a bit. You back? You better. If you're driving, drive safe. Drive safe. You're gonna have to just text me or something. that is some bad connection. Like it's pointless to talk right this minute. It's like really not working for you. Yeah, but you're still roboting.
That's man. now?
Pretty much the same. Maybe a little better.
How about now?
That's better. Whatever happened.
Yeah, probably because I am driving. No, I said I'll come back up Sunday and we'll get back at it.
Cool.
Did you get all that crazy wind yesterday too?
It's been on and off, kind of wacky. I can't even remember yesterday at this point, but right now it's blue. Well, actually, I'd call it partly cloudy. There's some nice puffy cotton balls in the sky.
Yeah, it's beautiful out. It's another beautiful day.
These next 4 to 6 weeks are going to be the hot ones, and then we'll start tapering down more than likely after that. You'll be glad to hear I did schedule a foundation team out of Fargo that are going to come up here, but it's going to take like 4 weeks. Maybe they'll squeeze me in before then, but
Before you see them, did Meme get back to you yet?
no. He's been busy, apparently. Mm-hmm.
Oh my gosh, you're doing so much road work here, dude. In my nut, this is ridiculous.
Yeah, I think the weather and the salt and all, the carby gun stuff that they put down and all that stuff, it apparently really wreaks havoc. And just the extreme temperatures. That's a nice one. I like that right there. It's good. That's a good one, Jim. Keeps on posting stuff, not in the VC though.
So when you're mounting your deck, Gospel, how are you going to make it level? Use a water device.
You're coming in really low, but I did hear you. How am I going to make it level? I have levels, and I will be using them. But if I get lucky, I'm going to get a clear plastic tube, just for kicks and giggles, and to show my kids, because I think that thing is really cool. I guess it's just known as a water level, and yeah, that's really cool.
Sounds like a good idea. Even though you're on the outside of a ball, you're still going to make something level. That's a great concept.
Yeah, that sounds too good to be true. I know what they say about things that are too good to be true. What do I mean?
Have you seen how low and big the moon is? Gospel at around 9 o'clock.
No, but I'll check it out.
Yeah, if you get a chance, you see the sun and the moon almost the same size and diameter because they're both about the same height at 9 o'clock. It's pretty spectacular.
Yeah, it'll be on the southeast side of the sky or the moon, though, at around that time, right? I think it's in the. I've been seeing the moon on the southwest sky in the mornings, or just straight south, really.
Yeah,
as early as I'm getting up
today. Because yesterday it was pretty close to full, so it should be full today.
Okay.
But it's just really low in the sky. It's like, well, pretty cool.
I'll check it out.
I thought I closed my damn garage door. Look at this fucking shit. Oh, it's so fucking annoying.
Oh man, there we go. Observation. So today.
So what in particular is disappearing? The second set?
Yeah, the second set of buoys on that shot. Now, the thing about the buoys is they're intermittent, right? So you can tell the peaks and valleys of the height, right? It's not a continuous height across. The buoy sticking out of the water is actually greater than the height of my phone, which is about 2.5 to 3 inches max to the camera lens. And if you look at something further away, you don't even need to go as low for it to disappear. So across the other direction, there's a kayak right next to the dock.
Those are on the shore, aren't they?
Those buoys are close to the shore.
No, I mean the kayaks are like sitting on the ground, right?
This one is in the water, just like with a like a rope, I guess. But still, it's bigger Yeah, the part that's extruded out of the water is bigger than the foam. Same like over here, you have a paddle boat. Another good visual marker that I use is the bottom of the reeds are orange, right? So the normal water line, you know, as it rises and falls throughout the season, keeps the bottom of the reeds in orange color.
Uh-huh.
You can get that to disappear.
Oh, I see. Yeah, I got you.
The rock line on the far shore is the same thing, and these things are well in excess of the height of the differential of the lens to the water.
Somebody in the chat is asking, is Simon Dan confirmation bias or controlled opposition? I mean, some of these people are just...
Right. Are those mutually exclusive?
Professional Dunning-Kruger people.
Yeah, fair, but also some of them are opportunistic.
Yeah, there's that too.
Yeah, so these Globers, you know, that have been here for years that say, I can't reproduce the effect of something disappearing at a short distance. I mean, they're just being disingenuous.
They're not trying.
Yeah,
they're trying it on their desk. Their kitchen table or something.
Yeah, and to be fair, at least one of them that I can remember actually attempted to prove that they did it in real life. That being Ed Masto, where he went to a river, because that's all he could find. And basically took shots from the bank of the river. So multiple feet above the river, if I can remember.
Oh.
You gotta get into the water, dude.
Yeah.
You gotta get low. Well, and then he said something to me like, why would I need to get into the water? And I was like, dude, you have to go the gamut of the angle all the way to the minimum. Otherwise, you're not trying. If you're not willing to get in the water to test these things, you know, you might as well just resort back to Matthew Learn's level, which is like, why bother testing it at all?
Mm-hmm.
You gotta get in the water, chillin'. You gotta get in the water. If I remember correctly, that's a Negro spiritual. So clearly these guys are racist.
Ah.
Yeah, that's right. If you're not willing to observe and test, then you're a racist. It's that simple. So what's the last observation anybody did in here that they can pontificate about the lack of oblateness of the sphere?
Me, it's just seeing into Canada. I don't have really good elevation height data to go off of, but I've got roundabouts. I think I've tried to pull it up on the data.
So we've got tons and tons of observations that supersede the globe prediction, both at the short range and the far range, and well excess of any tolerance for margin of error by orders of magnitude. So what's left to argue? Well, in their camp, the only thing left to argue is, well, light just does what it does to present the Earth as it appears to you, regardless of whether it's a globe or not, as a globe all the time. Right? It's just enough of light doing what it needs to do to mitigate out all observations. Now, I want to make that clear, all observations. The explanation is a penumbra from which every single observation falls under. That makes it unfalsifiable by that means in their worldview. So rather than present the evidence that light is doing what they need it to do in those instances, they just assume it post hoc. by saying, I know Earth is a globe with these dimensions, therefore light must be doing this in order for me to see what I'm seeing, because geometrically it's impossible. Now that is faulty reasoning. That's a formal logical fallacy. So you can't make a conclusion based on a formal logical fallacy by just assuming the premise is true in the first instance without having proved it. That's called presuppositions. And if your entire premise of your worldview is built on a presuppositional framework, maybe you need to rethink it.
Yeah. I'll be back.
That's a difference, by the way, between a presupposition and a supposition. A supposition is basically just essentially an inquiry, in a sense, where a presupposition is it's assumed to be true at the beginning. So you're not even like questioning whether it's true or not. You're assuming it's true and then giving line of reasonings that would be true if it was true to support that your initial premise, which you already assumed to be true, is true. So if anybody was following that, that just results in circular reasoning without the first premise that you presupposed being proved in the first instance. So who's got that sweet, sweet proofs of the hurtling globe through space in the first instance without the post hoc rationale and presuppositional frameworks? To my knowledge, there only exists two things that the majority of them claim. One being pictures from space, two being eyewitness testimony from people who have allegedly been to space and seen the Earth as it represents itself in those pictures. So ultimately, they have faith, just faith and trust in another guy's story that it's legit. That's really what it boils down to.
Right here. This is where I need to know. What is the elevation of this spot? Oh, 700? Oh, okay.
So I just had to coach my son on how to use his iPhone to videotape the boat disappearing. It's got a waterproof case, and this iPhone is already like IP68 or whatever, so it should be safe. Unless he drops it, yeah, then it's just lost.
Oh, 700 foot prominence. So we're talking about 2,300 feet. I'm a little 2,300 foot above sea level.
Oh, man. Yeah. So he also is kind of still naive and innocent, and he'll just talk to people about it. It's like, what are you doing over there? I'm videotaping things disappear from the bottom up without the presence of any earth curvature. Aren't you afraid? Aren't you afraid that people are going to laugh at your change? That he doesn't conform to the status quo narrative?
Aren't you afraid that you're going to be proud of your child? for not being a complete moron.
Yeah. Dude, there's no arguing. Okay, so if you take anybody to this lake right here, you could bet them $1 million on the spot that the bottom of that boat will disappear. Right? You can show them the globe math, you can show them all that, and they'll lose the money every time. Well, 99.9% of the time. On a super pristine day, stuff doesn't disappear quite as much. Which is, by the way, the opposite of what people who try to argue against the Black Swan argue. They argue that on a super pristine day, you see the bottoms of things here in excess. And then on, cloudy, humid, refractiizer days, that's when it doesn't disappear. So, like the refraction flips at short and near ranges. You know what I mean? So, like everybody knows that, well, most people know that in an optic, the light comes in and splits in the opposite angle before it's rendered, right? So you have to flip the image upside down to then see it right side up.
Uh-huh.
So they think that there's something out there in the distance that does that ahead of time for the refraction at a certain range, so that at close range, a pristine day, nothing disappears. But at a far range, a pristine day, everything disappears. Except the Canigou Mountains, right? They don't disappear when they're supposed to be a mile under the curvature at 250 miles or whatever it is. Of course, they'll appeal to refraction there, saying, "Oh, well, I can't see the bottom of the mountain." Like, well, no freaking duh, because there's a town in front of it. But now the question is, why can I see the town and the beach and the shore and the water leading all the way up to it, when they're all supposed to be 1 mile under the curvature from the peak of the mountain?
So the real question... Go ahead.
No, go you go. The real question?
The real question is, can I see Regina?
Yikes. This is a family show.
Yeah, I know. So apparently Canadians don't know how to say Regina, and they call the city Regina, which is what any good American would call it. They call it Regina.
Oh, dude.
No way, dude. If it was Ina, it would be an E instead of an I.
Yeah, but, I think you're going to know that one.
You know how people say...
Answer?
Regina is not Regena.
Right.
Like the musician Regina Spektor is a Russian singer, I guess, or whatever. I don't know why I know her music, but the name just came to the only Regina.
It doesn't even matter. Any woman named Gina, there is no freaking E in it. It's Gina. So.
Yeah. I probably the mistake is made because of rhyming it with female part.
Yes, we are. Exactly. This solves the episode of Seinfeld, by the way.
Gotcha. Well, anyway, 140 miles to that city. If I could learn the features, I just, as far as I see, I'm doubting. I don't know what I can see. I just know I can see multiple cities into the horizon at a 2,300 foot elevation, which would be up to a 60-mile horizon. I think I might be seeing this city though. I'm not sure.
My son is stressing out an old man.
Stressing what?
There's an old man swimming, and I think he's stressing them out with his observations.
Oh, nice. He thinks he's being watched.
No, I think you were saying, like, if I put a quarter out there, it'll disappear.
A little while ago, I was driving when I was in here. Gospel, what was that you pinged me about?
Oh, yeah. I'm just working on trying to understand the building code. I think I'm building code stuff for a deck. I think I figured it all out.
What was that when you were where I heard the thing about a cantilever or something or another?
Yeah. There's like spacing of deck joists with no cantilevers, spacing of deck joists with cantilevers. I figured it out. Deck joist span. It just gives all these different numbers, and obviously it's what building code's all about. But I was trying to figure out, what I could get away with, but also not compromise. And I don't want to. I can't afford doing stupid overkill, but then on the other hand, I don't want to just do the absolute bare minimum. So try to pick a sweet spot.
And then have it sag and not hold up and whatever else.
Yeah.
Right.
Yeah. But based
or you
on
have a big party on the deck and it all collapses.
It's a really small deck, so I actually think that I can get away with with some give and take play, basically. Higher than the minimum, but yeah, anyway. Yeah.
Yeah, this is a great little lake for observations. I think you got 200 meters across this way and 300 meters across the length way.
Small lake.
Yeah. That's why I like it.
Yeah.
Yeah, no, nothing wrong with for swimming hole or whatever, but like for flat Earth observations, it seems kind of small, doesn't it?
Well,
no.
It's like when I tell people short distance observations nullify curvature, long distance observations falsify curvature.
Yeah, so the thing about this lake, like this is the one from I can see the boat now. I can't video with my son. So at this lake, everything disappears, right? From the bottom up. You know what I mean? So it's like, no, there's no. Yeah, exactly.
Does Professor Phil just live in like everybody's DMs now?
I've never gotten DMs. Sir, most of these people, I wonder what people do, like why they choose who they choose, because I do get DMs, but it's usually like underwhelming. I don't know.
I got a lot more back. I got a lot more back as a gold plus than as a moderator, honestly. And then, and Phil, I think he dropped into my DMs at one point, but that didn't last long. I pretty much told him off, and I think he knows damn well that I'm like the first person who got real vocal about how his behavior by sliding into the direct messages of any Glober that we're talking to, well, on the ban list and everything. Like, I was the one wait a minute, who's messaging you? Is it Phil? You know, like, yeah, he knows I think he knows better than to mess with me, that I don't like him or whatever. Pretty sure I heard him one time say you could weigh helium, or maybe it was hydrogen or whatever, but putting it in a balloon, letting it lift, and then hanging using a spring scale to measure, like,
wow.
Reverse measuring.
Yeah. Like you're weighing a fish, but it's going up into the air.
Well, you got to be careful with Phil in the DMs, because he swears that he's a satellite launcher, right? So he shoots rockets off, and he swears he can prove that he can shoot his rocket by fiddling his joystick. So you might want to watch out.
That's why I don't mess with him.
Yeah, he swore up and down that because he fiddles his joystick and he watches things on a screen, that means that rockets are going to space and little floaty things are coming out of it. Now, his claim to fame, by the way, is working with the Indian Space Agency to launch their moon lander or something, which crashed. You know, so he sucks. It wasn't my fault it crashed. I was fiddling my joystick adequately. Also on a secret committee, quote unquote, to establish ways to contain gas on the moon. So this committee of engineers, right? Because, okay, check this out. So you have to bring a very small payload up, right, when you go, or, you know, theoretically. You can't an entire, hold on a second, you can't bring a tanker, right? Like you would see on the back of a train car or something to contain all the gas that you need, right? So what are we going to do? So this dude's like has a bunch of engineers, bunch of mathematicians and physicists trying to figure this out, right? So what did I tell him to do? I said, you bring up some cables and a balloon. You let the gas fill the balloon till it expands into the cables, and then you have your structure. Thank you. That'll be $33,000 for my consultation fee.
Why 33?
No reason. It's like we can't figure this out. How do we have a large structure that starts off small and gets bigger? Now, this super consortium of intelligentsia, where do you think they held their meetings? Right? In a DARPA secure net? No, it was like on a Discord server. You know, if I didn't know any better, I'd think he was LARPing as this hero of intergalactic space travel that he claims to be. You know, like fantasy football, you know, where you have the men and you pick the guys, and then you get rewards if they make it. So it's kind of like that, but with space agencies.
Yeah.
It's like I work with NASA. Well, friends, my crappy DeWalt headsets are dying, so I'm going to have to go make some more flat Earth observations.
I posted one of mine in the chat, and it's not over water, but it's 112 miles from my observation point to a mountain in Colorado. And I think actually even it's more condemning than doing it over water, because I'm at the foothills and the elevation climbs as you look in that direction. So there should be foreshortening of the foothills to the mountain to occult the entire thing. But you can see it base to top. It's kind of faint in that picture, but you can see it. There's like some black trees right in the center. And then behind that, I had to turn the contrast up so that you could see the mountain behind it. Or there's 3 mountains right there, actually.
Have you looked it up? I was looking at that picture. Have you looked it up at all to see like what your elevation was where you took the picture and what the base elevation of that mountain is that you're looking at?
Yeah, so the elevation of the mountain itself, which I have hiked, it's 14,200.
But that's at the peak. That's at the peak, right?
That's at the peak, right? My observation height is 4,200. So there's about a difference of like 10,000 feet. The occulted, what's supposed to be occulted is around 8,000 feet, but you can see it base at the top. So if you can see a whole mountain at 112 miles.
I think what you would want is the elevation of the mountain at the base, though, like what you're sure that you're seeing. Not really the peak, right?
Well, where would you start the base of the mountain to be? I mean, I guess they would officially determine
you can look
that.
that up. I mean, I think like every named mountain, they're going to tell you like its base elevation and also its peak elevation. And you'll know, then you can find out like how tall the mountain itself is. You know,
it's called prominence.
Yes, yeah, that, yeah.
So there's prominence of a mountain, and then there's elevation of a mountain. Prominence is the distance from the ground to which is already above sea level. Elevation is the actual from sea level number. So you're looking for the prominence height, more than likely.
Says prominence of Long's Peak 2940. 2,940 feet.
And you said you were where you took the picture? You were at?
So elevation above sea level, I was about 4,200 feet.
And you would need to use that number.
Yeah, you could take the peak elevation and then subtract the prominence, right? And that would give you the base.
You just need your elevation height based on sea level, and then you need your distance.
Right. Well, I mean, I did it real quick. I didn't get too technical with it. At the end of the day, above sea level elevation-wise, from my observer height to the top of Long's Peak, there's about 10,000 feet. And 8,000 of those feet should have been occulted by curvature. So we're talking 2,000 exposed. But you can see it pretty much the whole thing.
Yeah.
So I remember when I was a kid, I used to live in a town out on the plains of Colorado, and we would drive to Denver. And like, as soon as we would head that direction, it was 120 miles. We could see the mountains, and we were kind of like, certainly we shouldn't be able to see the miles this soon, right? Because we were thinking curvature and just it's a long way. It's 120 miles. But a couple of winters ago, we were out there visiting family, and I thought, I want to put this to the test. So we were driving from my little hometown out to Denver, and I'm like, sure enough, there they are. And it was a low humidity day. So
I know we used to drive when I was younger. We used to go as a family out to Colorado for skiing, snowboarding, and stuff. Right. So we take. I'm from whatever. We take 70 all the way out west, and I would usually end up getting like the late night and early morning shift driving going out there. And there was one time where, I mean, it's a long time ago, so I can't say for certain, but I know it was like we had just crossed into Colorado from Nebraska, or we were still like almost to the border then. Like, and I swear I was already seeing the mountains. I was like, there's no freaking way. Like, or we weren't that far in. I want to say I was probably in Colorado, but I want to say we were at least like, fuck, I want to say like 300 miles out. But like I said, I don't know for sure. It was a really long time ago. And that just couldn't be if that was the case. It was early morning, like as the sun was just coming up. But it's nice when you're driving all the way out there and you first start to see the mountains coming up over the horizon. You're looking for it after you've been driving for a long time. You're like, hey, holy shit, I think I see the outline out there.
Right. Because when you're out there in the plains, like when you actually start to see the mountains, it's kind of exciting. You know, you anticipate that, like, oh, good, something different than flat. And yeah,
because Nebraska is just nothing but it's like 9 hours of flat, like tumbleweed, one straight road, not a single hill.
Right. Yep. Well, we goof around in are you from Nebraska, Lou?
No, Dad, we drove all the way up from Wisconsin, so 1,000-mile trip that we would just go nonstop. Yeah.
Okay. Yeah.
We drive south from like Milwaukee area to like Illinois, and then catch 70 from there, and then head out west.
Yeah, totally, man. I'm willing to bet that from the border of Colorado, looking due west on a good day, you could probably see the mountains from about the border.
I'm pretty sure I've seen it from around there. Like I don't know if I was a little before there, a little after there, but I know I was like I had either like just crossed or I was about to cross. You know.
Yep. For sure, dude.
That's a long ways to the foothills, to the mountains still.
Yeah, it's a super long ways, and that's nail in the coffin. But when you see it when you're a kid, you just don't even think much of it, right? Like, oh, there's mountains.
I even thought about it. I was like, there's no way I should be able to see these. Like I thought about it.
But when I started to get into flat Earth, that came to mind one day. I was like, holy crap, that's how I seen them, because it's flat, like, okay, fair enough.
Just back in those days, yeah, even though I thought about it, I'm sure if I asked anybody, all they would have had to do is say, well, Lake Bends. I've been like, oh, okay.
Yeah, didn't think to fight it. Earth was a ball.
But if that's the case, whoever that was, I was just speaking. It should be easy enough to like go and get that picture too. For somebody who lives in that area, I'm sure that we got somebody in here who lives near the Nebraska-Colorado border. It's got to be someone. Try to get a picture of the Rockies from there.
mighty talkative bunch. Get on here right now. Is there any new people?
No.
No new people. You didn't even look. Did you look?
No, I'm just thinking. I'm not new. I don't know. Who we got?
Lumpy. Oh, never mind. I know who that is. Didn't really say Lumpy gas in the vacuum. He's a crazy globe denier too.
I can be new.
No, we're not doing that.
Okay.
Luke shoots that down right away.
That's one of the cringiest things that I hear us do from time to time is when we pretend to be Glovers. It's seriously bad. That's my own opinion, though.
I will not pretend. I will give proofs.
Fine. No, it's not just a Glover.
All right, Sasha, show us the drop over distance over a body of water, at least 10 miles, 60 feet. Go.
Well, everybody has computer or television. You type the NASA live stream and you watch the ball from the space. That was easy.
Well, why did you say so soon?
It's only probably because your people don't believe television.
Curses, foiled again. I never would have thought about NASA pictures. Damn.
Why we don't trust each other? If I say curvature is there, you need to trust me. And then we will be like a good human beings, friends even. Trust me, people.
Sasha, are you saying curvature is there?
If you trust me, you will be my friend.
I'm not going to tell you if I trust you. I want to hear your answer.
I also trust. I don't know. some guy.
Now we can't answer. See, just like a Glover in the hot seat. Now he fucking jokes up, can't fucking give us a simple answer, direct answer to a direct question. Come on, Glover.
My best friend told me he would not lie to me ever.
Kick him out.
He died. An idea of curvature died with him.
Sorry, Sasha, you suck at being a Glover.
Man, I cannot be Glover because of mountains. I cannot perceive how they measure that. That's for me too much. That sea level thing.
I know what you mean, that pesky, curvy sea level. It's hard to figure out.
Yeah, that sea level. Why we are calling sea level everywhere, and why we are using that sea level even, if we are only speaking about that. Are we using that, or we are joking with sea level? or better, where we are using a curved surface for anything.
Yeah, it's just so strange. Like, obviously, yeah, it's accepted. Sea level is sea level. Everything is based off of that, and as you go up or down from it, And yeah, we treat it as level every time we have to do anything with it. But in our heads, we somehow left, elementary school with this whole idea that all of a sudden it snaps out like you just, like when you're watching a rocket launch and everything's up close, and the next thing you know, they're in space, and like now everything's curvy.
But I cannot have that in head anymore, because for me it's so obvious, like a lake, and then you make a big lake, and then you make islands in between, inside of that lake. Make, like, let's say, experiment, and then you measure everything what you want on that lake, all that islands or whatever. You can put the football ground like 10 meter, 1 meter high, and you say this is 1 meter high. Why? Because it's on sea level. Fuck. So easy. But with curved surface, you need math there. You need to kill yourself to calculate and to get the point of how high it's something on the sphere. In my opinion, how you can fucking measure the elevation on curved surface?
The idea that we live on a ball is just like a philosophy, like that they put into people. It's not reality whatsoever. Somehow, yeah, we use that word cognitive dissonance a lot, but that's exactly what it is. Two contradictory beliefs being held both as true at the same time.
Yep. Did you ever take in consideration the depth? It's the same thing. How we measure depth if it's curving upward?